get seated from the front rows. When you enter on your right-hand side, at the front, we've got several seats available. Okay. Okay. So I think we'll start now because we're running late and we have a larger live stream audience waiting than in person. So we don't want to keep them waiting. So if you can just get seated, we will start today's session. Just a second. Can I? Yeah, the pointer is here. Right. Okay. So are we live? Are we live? We're live? Yeah. Okay. So good morning, everyone. Good morning, everyone. So nice to see you all back here in person at the 80th Global Edition of the Zak World of Façades Conference. My name is Ahad Ahmed. I'm part of the organizing committee here. Thank you so much for being present. It's been a roller coaster ride for all of us last 18, 20 months. We've unfortunately had to change our lifestyle, had to change the way we think, had to change the way we work, but I'm glad that we are slowly coming back. We are not yet there, but we are slowly coming back to what we are, which is basically social animals. Humans are social animals, and here we are meeting each other in person, face to face. So thank you once again for being present. So quickly, this is the 8th edition of the Zak World of Façades in Bombay. It is the 80th global edition. Of course, we are here after 31 months. The last event was in April 2019. So a lot has changed from then until now. But I'm sure the desire, the drive to meet people, to learn new technologies and innovations in the world of facade is still there. And I hope today's presenters will enlighten you with their views, with their take on on designing and executing modern building envelopes. So I'll give a quick brief before we start today's session. With the Zak World of Façades Conference, we've been organizing this globally, as you're aware. We have completed 79 editions in 27 countries. Planned events are in 32 countries. We have a lot of new countries planned. We should have crossed over 100 events last year, but it didn't happen. But now we are slowly getting there. We are executing events in places where cases are low. There is sentiment back for in-person meetings, and we've already completed 3 events this year. We did Dubai in March, we did Cairo in September, we did London end of September. So it's slowly coming back. We're still not there. It's still not 100% to the way we would want it to happen, but at least it's a start after a big pause. We are on a roll. We have events in Doha, Istanbul, Frankfurt, New York, and Jeddah from now until the end of the year. So we're slowly trying to cover our backlog of 2020 now. So I'd like to thank our event partners. I think without their support, we wouldn't have been able to do this in person. So our presenting partners, Technal. Technal is a world leader in aluminum door, window, curtain wall systems. They are our presenting partners. They've been present from the last 25 years here in India through various brands. You would have heard of Domal, you would have heard of Sapa. So Technal is there now. Face brand in India. Powered by partners, Glass Wall System, a leading facade contractor here from India, based out of Mumbai. Associate partners, so we have Aluform, who are distributed by Technocrat Performance Materials. We have Codina, which is a mesh company out of Spain, first time here in India, along with their distributor Diamond Engineering Corporation. Dow, global leaders in ceiling solutions. Earlier, they were known as Dow Corning here in India. FG Glass, your favorite glass, one of the leading value-added glass processors based out of Mumbai here. Fisher are debuting with us. So Fisher have anchoring solutions, fixing solutions, pacifier solutions for the whole building envelope. We have Fundamax, Austrian company into high-pressure laminates, global innovators of this product. Kinlong, they are on a roll. They are buying companies left, right, and center. Originally started off as a glass hardware and fittings company, but now have much more in their portfolio in the last few years after the acquisitions. Curare's primary brands are Throsifol and Sentry Glass, which are basically laminated glass interlayers. Ozone is a leading glass hardware fitting manufacturer out of Kalamb in Himachal Pradesh. Saket is the distributor of roll plug. So roll plug is a fastener and anchor solution provider. They are also debuting with us for the first time. Search Ferrari is a leader in technical textiles. They have textile materials which can use for facades, especially for lightweight structures, more popular for their roofing structures. Now they have a full system for the facade. So Siderise is a British company. They have pacifier protection solutions. They are distributed by Allark India Private Limited. Techronail out of Gujarat is a leading standing seam and free, what do you say, you have these new freestanding railing systems. So they are having a nice range of products, aluminum extruded and in stainless steel outside. Viva is a leading manufacturer of non-combustible aluminum composite panel solutions. Wienerberger is an Austrian company. They are manufacturers of the Argiton terracotta brand. They have been distributed here with Diamond Engineering. They are also participating with us for the first time. And then our live stream partners, for those who are seeing the this event live, we have Blick Systems. They have some innovative solutions for curtain wall and for ventilated cladding. So these were our partners for today. All of them have a booth outside, so I please urge you guys to please visit their booths, interact with them. They're ultimately here to see you face to face. And also the 3 exhibitions which you do, glass tech doors and windows and aluminum extrusions. We intend to do this December 2 to 5 in Mumbai. Of course, it's not going to be of the same scale as how it was earlier because of a lot of international people not being able to still come into India easily and freely. But yes, to get things moving, we will be doing a small boutique show at the Bombay Exhibition Center. So that's it from me. I'd like to introduce today's event host and convener for the day, Mr. Tariq Kachwala. He's the director at FG Glass. So Mr. Tariq Kachwala, please.
Edition 80 or 88? 80, right?
Yeah, sorry, forgot, most important. We need to follow the safety precautions, which the bare minimum is wearing a mask at all times, at least inside the hall. So I would please request you to all wear your masks inside the hall. Maybe outside I can understand for the networking, but at least inside the hall, if I can request you all to wear your masks, that will be much appreciated. Thank you so much.
Right now.
Yeah, because...
Good morning. This is working? All of you had a coffee? Good morning. So welcome all of you to the 80th edition of the Zak World of Façades, the 8th one to be held in Mumbai. I'm Tariq Kachwala from FG Glass, and I have the pleasure and the honor, after a very long time, of being the host of this wonderful event yet again. As Ahad said, this was, and some of you may know this was supposed to be held in April earlier this year, but had to be cancelled for obvious reasons. We could not hold it last year, so it feels good to be back again under one roof, and it's kudos to the spirit of humanity that we've been able to overcome this pandemic in such a short time. This event is special for 3 main reasons. First one, obviously, is this sense of normalcy that has finally come back into our lives. So we were all confined to our 14-inch and 16-inch screens for so long, and it feels so good that all of us are here again. So I think, again, as I said, we've come a long way, and it's good to feel the products, touch the products, to have more meaningful interactions and hear these wonderful presentations that are to follow right now. The second important reason, and I'm sure a lot of stakeholders in the facade industry will relate to this, is this sort of flux that we are in right now between opportunity and turbulence. On the one hand, there is a huge opportunity that is staring us at us in our faces. Building real estate has gone up. People are looking at buying apartments. People are looking at moving into bigger and better homes. And in general, there is a big gap between supply and demand that has suddenly come up. But on the other hand, as we all know, there is a huge upsurge in the prices. There is logistics, shipping, freight, which has gone to astronomical levels that we've never ever witnessed in our lives. We are getting orders at prices that we want, but we don't have material to supply. And I think it's events like this that gives us an opportunity to reflect upon these things and how we can capitalize on the situation that we have And rather than looking at this as a drawback, take it as an opportunity and come forward. The third thing, why this event is important, and something that is very close to me personally, as I'm sure it is for most of you, is as a facade community, we have a huge responsibility. We have a huge responsibility in terms of developing and building buildings which are low on carbon footprint and which can give us as high an ecological advantage as possible. Buildings are big energy guzzlers. There are people who are wanting bigger and more comfortable living spaces, and that unfortunately translates into buildings that have a bigger carbon footprint. And as entities in the facade industry, I think it's a responsibility that all of us have to ensure that we come up with buildings, designs, whether we are supplying materials, whether we're installing facades, to have as low a carbon footprint as possible. So with that, and I'm sure a lot of presentations and panel discussions today will also focus on this. So with that, I'm not going to waste much time. We are already running slightly short. I would call upon the first speaker of today, Mr. V. Gurumoorthy, to give the welcome address. And I'm sorry, I would request all the panelists and the speakers and the moderators to please stick to the time frame. We have a very packed schedule. We have a fixed closing time. So we want to give justice to everyone. So Mr. V. Gurumoorthy, over to you.
Good morning, everyone. And it's really a pleasure to see, after a long, long time, as Mr. Tariq also said, and Ahad said in his opening address, all the stakeholders and all the people under one roof. It's been more than 18 months that we have been confined to the computer screens. So on behalf of Technal and all the other sponsors of this event, a very warm welcome to each one of you. I know this was supposed to be an early start, and I was wondering that whether we will start at 9:30. So thanks to the organizers for delaying it a bit. And then I can already see there are a lot of seats that are filled up, and as we go along the day, this room will be full. There are some more empty seats, but I'm sure that this will be filled up very soon. And this show is, this event is really important for me in one reason. I think this is the first event post the pandemic which is being held in India in an offline mode. And I think not only in India, if I am not wrong, this is even in South Asia. Maybe Ahad can correct me if I am wrong. So in this respect, this event is really very special. So we can all say, Zak is back after a long time in India again. And for some of you who don't know me, just to give you a very quick introduction, I am Gurumoorthy, heading the Technal operations in India. I've been in the building and construction industry for the last 15 years, and out of this, 6.5 years has been with the facades industry. And this is my only company in facades, Technal. Technal is just a part to give you a very short introduction about Technal. Most of you know, and we'll have some opportunities to discuss even during the break. Technal is a part of the Hydro, which is a much larger conglomerate, with presence over 150 locations and in 40 countries, and with more than 35,000 people worldwide. And in India, we have been here for the last 25 years, and we belong to the South Asia region with more than 200 employees. So this is about Technal, a very quick brief about who we are and where we come from. Talking about the market, some of these points have already been discussed by Mr. Tariq, so I will not take much time. I will cut those points off. And what I want to say, the facade industry is really a big market. And as per the estimates, we have a business, or the market size is estimated to be around 20,000 crores in the fenestration industry, of which close to 35–40% is contributed by the curtain wall systems and the others by the fenestration. Times have evolved. Earlier, facades or fenestrations were being looked as just covering the building envelope with some materials. But with the evolving times, and thanks to events like Zak, who have been instrumental to a large extent in bringing all the stakeholders under one roof and with the main purpose of sharing the knowledge. The facade industry has evolved over time. Today, no longer facades is just a means of covering a building envelope. It is much more than that. People are talking about design, people are talking about aesthetics, people are talking about performance, which is the most important thing. And last but not the least, there are some other very, very important topics like sustainability, lower carbon footprint. This is the need of the hour, especially for a country like India. When you look at the advanced countries, I think India is still a long way to go when it comes to sustainability and low carbon footprint. And with a lot of incidents that we have seen in the recent past about fire. So now these type of topics are gaining a lot of importance, and this is where I am really happy to see all the subject matter experts under one roof who will be sharing the knowledge, and we need to see how we can work together for the betterment of the fenestration industry. To conclude, one last topic which I think we are aware about, but we are missing. Yes, the design and the performance standards have improved. But if you look at India, it is really a fragmented market. We really don't have a very clear set of guidelines when it comes to fenestration industry. We really don't, when you look at developed countries like UK, US, there are clear guidelines. You can have the best of the product, but probably what we need to focus more, and as industry leaders and as the well-wishers of this fenestration industry, is something where we need to focus is on the quality. Finally, you can have the best of product, but if you are not able to execute the product with the right sort of metal builders and being able to deliver the quality to the customers, it will be, again, we'll be going a step back. And I hope in today's session, we will also be having an opportunity to address, or at least to bring to light, these type of topics, so as to have a brainstorming on how we can take this industry forward for the betterment of all of us. So with that, I conclude my speech. And once again, thank you everyone. Thanks for coming, and hope to interact with all of you during the break. Thank you.
Well, thank you. Thank you, Mr. Gurumoorthy. With that, I would like to call upon our first speaker for today, Jayesh Hariyani, who is the CMD and Senior Principal at I&I Design Studio based out of Ahmedabad. It's a great design firm, and we've had the pleasure of working with them on one of their very nice projects. He will speak on design based on ethos of sustainability and spirituality. I think in the theme of what we've been speaking all along, about sustainability, the process of seeking guide design process, and 10M, what he calls 10 matrix drive design innovations. So over to you.
Good morning. Mic, please. Hello. Good morning. Can you turn this on? Doesn't look like. Hello. You guys can hear me? Good morning. Thanks for the introduction, wonderful introduction, Tariq. We have been working with you. Unfortunately, I'm not included your project, but in the next round I will do that because it's under construction. Good morning, everyone. So I think the stage is already set wonderfully that after a long time, such an event is happening, and I think at this scale, it's a beginning. I'll just excuse myself with mask on. So it's wonderful to really meet in person in such a gathering and share ideas and knowledge amongst industry peers. During this past 18 months to 2 years, I think all of us have gone through various dynamics and roller coaster ride and have reflected upon differently as a professional, as an industry, as an individual human being. So with me also that same journey has happened, which I'm going to talk in the first 5 minutes. But before I get started on the main theme of the today, I'll just introduce us very briefly. I Design Studio. We really are driven by values that we believe in and we preach in. And these are the 5 values that really drive our spirit and our projects. I won't read it, but I think as I show some of the case studies, you can really see how these values drive us. The other thing that I'm going to touch on is 10 metrics. Now, based on the value system that we have, you need to create the framework to guide, to channelize those values into your work. So what we have done as a professional team is to create a framework of metrics that guide us through every project. And those are listed here, and I won't read it, but most of the things are very relevant to our projects, and we really push ourselves to really go through this framework and measure our projects and our work with these lenses. So the theme that will reflect upon the case studies again, I will bring that slide back towards the end, but I would like you to just look at the values framework. The culture is driven by values as well as the framework that you really set yourself. And collaboration is the key. I mean, as a designer, there's only so much that we can know. It's about creativity, but there is a lot of technology, a lot of other expertise that needs to make the creative idea into the reality. So collaboration is the key, and I think thus building skills have evolved a lot over the decades, and expertise are needed. The collaborative spirit is needed to drive the project to realization. We are offering expertise in pretty much every built environment. You can see we are into most of the sectors in South Asia as well as internationally. And some of the milestones that we have achieved in last 10 years in South Asia in different sectors and services. This is the footprint of our projects and some of our I&I brand offices in India, South Asia, across the other regions internationally. So to sum it up, we started as Burt Hill, North American brand. From North America, expanded internationally. Burt Hill merged with another brand called Stantec, very large global firm. We started practicing at Stantec. Over past 5 years, we have reorganized, restructured for South Asia and introduced ourselves the same values, same ethos as I&I Design Studio, and we carry the same legacy and value systems to drive our projects. So, going into the theme, design driven by ethos of sustainability and spirituality. In the 18 months, I had a time to really think internally that what are we doing? And that's what connected the story or a hypothesis that is there some relationship between two S. So I kept asking myself, what is my purpose? What as a professional I'm responsible for? As an architect, as an urban designer, as a planner, am I doing design? Am I doing architecture? And so on and so forth. The questions kept coming even today. And I keep doing that year after year, project after project, in past 3 decades. So the answer more or less reframes and develops. And the last answer that I have is that we create physical framework for life, and purpose should be to facilitate enhancement of the life. So it's not about design, it's not about architecture, it's not about facade, it's about holistic approach that we bring to our projects. And the goal is enhancement of life. So that's the purpose that I keep thinking about. Then I'm just a small designer, architect. The world is huge, and can we really infuse change being a small guy in the whole industry? Right? Each one of us can ask that. And the more you think about it, always the answer is yes. That no matter what you have to offer, you can infuse change, and today we need a lot of that. I think we all have experience in past 18 months. So seeking is the key. That 18 months we have been thinking, seeking something, and we don't know, are we on a right path, right? So that's where the journey starts of spirituality. Spirituality is about seeking. Seeking what? Becoming aware, right? Becoming aware of connections to something bigger. And it typically involves a search for meaning of a life. It's about softer aspect, and you can't really define and talk a lot. You have to really go in that journey to feel it. So that's the spirituality. What is the experience like? The more you practice, the more you really grow into it, and more you feel it, and more you get transformed, right? So that's the spirituality, deep awareness, aliveness, connection to bigger. Sustainability, more or less same. Sustaining existence in harmony and continue existence in harmony. So that's the parallel. Again, sustainability, we use that word a lot, but to measure it, it's a softer aspect. Yes, performance can be measured, but there are many other aspects that are more softer to really feel the sustainable side of it. A relationship. Is there a relationship? The more I think, I see that without spirituality, you can't even practice sustainability. So it's a two side of a single coin. So that's the hypothesis, right? Are you with me? Thank you. 2S, concept of 2S. It's about journey. It never ends, right? It never ends. It ends with one life, but it has continues with another life, and so forth. So it's always dynamic, and you grow into it. So that's the journey that I'm talking. Being a designer, architect, we like to draw. I've talked a lot of words, and if I put that in context of a sketch, 2S starts with process of seeking. Seeking brings you to becoming more aware in sustainability and in spirituality. In sustainability, you become more aware about your body, mind, thoughts, emotions, energy, and so forth. In architecture, in planning, practicing sustainability, you have to become more aware of context, sounds, vegetations, social aspects, economic aspects, national, international, global aspects, and environment, and so forth. The more you become aware, the better you connect with a bigger, larger goal, right? And there's again parallel, connect with big, whether it's God, universe, nature, whatever you believe in. In the sustainability side, you connect with community, city, country, environment, and so forth. And then the more you do, transformation happens. So that's the concept. Good enough? So how do we really go about? I mean, this sounds all wonderful theory. So I will go with few case studies very fast. I will speak less in details, just the broader aspects. The first one is more holistic. I will not speak little about facade. It's more holistic aspect when we talk about sustainability and spirituality. And it's not interesting, glamorous theme that I have picked for the case study one. It's about what we need to do beyond. So the first one is waste to energy campus done by us for a PPP project, Ahmedabad Municipal Corporation, and Abalone and I&I Design partnered with this project. And I'm going to speak about the process and less of the facade for the first case study, so excuse me. 2S, seeking process, right? Sorry. Being an architect, I know nothing about waste, city waste, right? So seeking process helped me to understand what is waste and what technologies really help on this project. So seeking process starts. Visited the site. Every city in India has these mountains of landfill, and this is the mountain of 84 acre, one of the largest in South Asia. City has been creating waste, right? And many families thrive on it for making living, not a nice thing to offer as a humanity, as a professionals. You can see how dangerous and safe environment people are working there. And the entire city is transporting waste from 7 transfer stations to these landmines and creating more and more mountain. So we started seeking that what is happening, these 7 transfer stations going back and forth, many trucks moving this waste across the city, and we looked at to the seeking process and how much CO2 we are generating and doing nothing, just creating mountain. So the summary of the seeking, every day about 4,000 tons of waste is being added, right? Diesel consumptions to move things and CO2 emissions. So we started looking with experts characterizing the waste and so forth, and did all this analysis, segregation, what waste and this and that, and came up with analysis of the composition and what toxics and the things it creates and how it harms. So, lot of seeking. Every project offers the opportunity to connect with big. One approach could be just let's use the technology and be done with it to create the wonderful facade to it, right? Can we do better job than just what is the client's brief? And that's where we push ourselves that what more brief we can create for the client. Seeking continues. We haven't even drawn about 4 weeks of analysis to understand the waste. Seeking process continues with the design workshop. We call it seeking process. And we invited a lot of stakeholders, so forth. And you can see the images of these discovery sessions. And at the end, as a society, as a city citizen, as a leadership, political, we all together draw to commit ourselves to these 2S. Use optimum in terms of a land offered to us, enhance neighborhood profile, create a campus for all, and offer more facilities for the community and neighborhood, right? So a lot of commitment, and create through this commitment a wonderful example for other cities to follow. The technology that was adopted for this. So what happens that, and at the end, wonderful architecture comes out of it, where what we thought is there is a base like a temple which signifies a more metaphoric aspect for the city and for humanity, that let's not keep going this way, generating more waste. So we did a translucent facade using the insulated multi-layered polycarb sheet, and wanted to show the technology that it's time for us to reflect upon what we are doing as a society and create a wonderful campus at the end. What we did is we used only 30% of the land provided to us by the client, and another 70% is given back for other community facilities such as sports and institute and research. So this is the campus. We started journey with the groundbreaking or a Bhumi Pujan with inviting all society and community to the planting. That's how we started. About 1,500 trees were planted in the very first day. You can see the enthusiasm. Site is under construction. This is the facade of the campus. Right? Site is still on, and lotuses are blooming there. This is the experience that you get from the site today. The construction is on. The birds and lot of other life is thriving on this site today as we speak. The community is celebrating this wonderful peace in Diwali time with 2,000 candles while the site is still on. The team, executing team, really enjoys the site and contributes more to it. More of the facade. And the real facade just hides behind. This is the overall 95% completion. It's just ready to get operational. Some equipments are still being installed as we speak. So that's the first. I spoke less of a facade. I apologize for that, but the impact and the transformation through this is net positive in terms of energy consumption in both process side and building side. Back to where we started, what transformation did it do? So transforming 1,000 tons of a waste every day into a green energy and many other byproducts at the end, and for the community, give back the sports facility and institute in addition to a project brief. Now, skins. So this is more holistic approach that facade is important, but for us now we have to really think more holistically and sustainability. King Faisal, this is the healthcare campus in Saudi that I had a privilege to work on. Again, the connecting with big urban context, the project is just here at the right corner. We looked at opportunities to really integrate at larger scale rather than just think about a building. So we work with city authorities to transform the entire surrounding area with the project. As you can see, we do a lot of this analysis. I think all of us do that, so I won't speak much about the analysis on how we create the building form and the overall envelope design. Lot of detailing goes into it. Lot. And we do back and forth. And every skin, every facade orientation really has to be dealt based on the orientation, and we really do a lot of thinking about it. What technologies we have used for this particular project is listed on the side. How we really treat modular panelize and how the shading is being transformed with these baffle panels. We detail those things. So various systems have been introduced depending on what it does for the performance as well as the aesthetics. So it's a real dynamic scheme with a lot of detailing and masrabias and layered systems that reflect upon the culture of Saudi as well as does the wonderful job for performance and the functions that it houses. More details. We go into really working through materials and making sure that we think about it. And construction methodology. When we start drawing sketches, we start looking at and thinking about how do we really build all this and what are the efficiencies. So working with experts, contractors, facade consultants, and the system providers, we really get engaged with them. So we look at options on construction methodology, do mock-ups, and so forth, right? And a lot of layered masrabias have been introduced here, and different variations. And also we create a more iconic aspect through some layered lighting and geometry. And we looked at many different geometries and their colors and their impact. Then we have these roofs, gardens. So we created wonderful canopies that cover over those and some of the modeling for that in terms of lighting and so forth. Those gardens have been really integrated into overall facade and green roofs. And this is one of the final image. Al Mafraq in Abu Dhabi. Again, a very large campus, initial sketch, some analysis of CFD, because all this is very important as you define and form the building and the building towers and so forth. Look at a lot of solar analysis, lot of spandrel and vision panel and so forth, and we look at lot of glass properties in options, light level analysis, atrium skylight and what it does in terms of its aperture and light quality and the glare and so forth. And then we look at the screening and light shelves at various different sections and what it does in terms of a performance and comfort. And this is the final product. This is the atrium that I just showed the analysis of. This is a project in India, India's largest aquarium that we just completed, and our Prime Minister just inaugurated and put this to public. The facade here is very unique. It's designed as a shell, seashell, and we looked at many materials here for the skin, and finally we worked with concrete. This is the final outcome of that facade. Some of the installation and mock-ups and so forth. This is during construction. It's a two-dimensionally curved exposed concrete. And some of the detailing, how floor-wise and panel-wise it's being designed. Carnegie Mellon in Pittsburgh. This was a unique project, and we had to just add a wing into 100-year-old heritage building on the campus, Carnegie Mellon in Pittsburgh. Now you can see on the left corner, the top one is just extension, the balance building is existing. The reason why I thought of this case study, it's important that you have to respect the heritage and the materiality and overall language while introducing the new program to the, so we did a lot of sketches. So the old building on the right and on the left, just the red line is the addition to that block. So you can see the old and new together here. And the only facade we were having is just one side, where we had to move the exhaust duct for the fume hoods. So we integrated that into the facade. We created a wonderful landscaped bioswale terraces there in terms of overall skin solution. This is the final. You can see the old and new together. So every time you have to keep seeking the right solution in the context. This is ITC in Bangalore. Again, lot of analysis. When we use what form of a building, we look at the solar gain. So number 6 is what we used, where it's the lowest solar gain for the building form, right? And then natural ventilation. We looked at the options to really create a stack effects to do the natural ventilation, some of the other analysis. At the campus level, at the building level, at the skin level. And for the passive ventilation for the tower, Bangalore weather is wonderful, so we wanted to make sure that we do right thing for the project. Some of the models and section studies, and this is the final skin. And the system is varying in terms of a module and its shading and orientation, and a lot of green vegetation has been introduced for a passive cool breeze, and enough of a green covers across the tower. I think this is the last one, so bear with me. This is another ITC, Calcutta skin, entire campus that we master planned and designed. Again, the same philosophy that you start with program and then you really morph the entire architecture into a meaningful composition, looking at the performance aspect. Shadow analysis for the entire campus, and then detailing to the facade, integrating a lot of vertical green walls as well as the photovoltaic panels and so forth. Some of the final rendered image. JSW, which is right here in BKC. The site is unique shape, and we designed around that. This is the cross section. We introduced the cavity wall, passive ventilated stack cavity wall here about 10, 11 years before. And wonderful atrium space. We did a lot of analysis of atrium and other envelope systems in terms of outside air load and its impact, some of the atrium lighting analysis, and the building layers in the skin with different material and architecture. This is the final product, as you can see. I will not spend time much. This is another project in Troy, New York. Again, historical context, 100-year-old campus, and we had to put a building there. So we looked at the old and married with the new construction there. A lot of unique systems have been introduced. The skylight atrium with freighted system there. The final image along the quad. So you can see the old architecture and the new architecture really doing a wonderful integration there. This is the old and this is the new. Last slide. So 10 metrics, the metrics that I touched upon: integration, sustainability, aesthetic aspects driven by the context, performance is key and should not compromise the quality of architecture. So that's what we look for. Again, on the sustainability and so forth, I'd like to remind that it's all about connecting with big. Look for new challenge. Don't go with the client's brief. Just try to add value on top of what client is asking for a larger good. Thank you all.
Well,
I hope
presentation like that deserves a bigger round of applause. Visually very, very stunning. I've seen very few presentations that are as engaging as this from a visual perspective. And we have...
I don't know what's the call. I mean, I can take questions.
Maybe one or two questions, if the audience has any. Questions, anyone?
That's easy for me. Either I did good or maybe I didn't do at all good, not having questions. But
okay. But I would like to just add a comment on the sustainability aspect that you said. And I love the fact that you had objective numbers given on the carbon footprint on the first the waste project that you demonstrated. I think that's really, really commendable. And again, going with the theme of sustainability, it is architecture like this and the whole thought process between sustainability and spirituality that really was an eye-opener for me personally. So thank you. Thank you so much.
Thank you, everyone.
Thank you. So from architecture, we'll move on to a product presentation, and I'd like to call upon T.S. Aditya, who's the Associate Vice President Sales at Fundamax India. He will talk on fire behavior and unique facade applications. Again, fire is something which is a very pressing topic in all architecture, and we need better materials for us to be able to resist fire in case it does occur. So he'll talk on fire classification, flashover potentials, material classification based on fire behavior for facades, and kinematic facades and passive architectural elements. So Aditya.
Good morning, one and all. Is my voice audible? Yeah, thanks. It's good to meet you all after a long time. Thanks to Zak. I would start off with a small video, and after that, we can go on to the presentation.
Change. Change is our constant. A journey over the last 130 years. We are rooted in change. Change is our way. And we are doing it again. We are changing. We think freely. We think ahead. We are Fundamax. We live perfection. We love design. We respect individuality. We complete what nature gives us. And we know where our journey is taking us. We are open for new ideas, for inspiration, for tomorrow. Open for you. And open for you to create. Fundamax. Change.
So, fire is a very important topic. As we are all aware, we have seen some unfortunate incidents that have occurred in the past. It's very important to understand probably what should be the criteria for material selection and what could be the installation systems. Apart from that, I'll also show you some interesting applications of facades as well. So Coming to fire, I'll not brief too much about it because I'm sure that most of you will be aware. It's an exothermic process. It's a rapid oxidation process which emits heat, light, and other byproducts. So something like rusting and all is slow oxidation, so it does not qualify under the process of fire. So when you talk about fire, we have seen in a lot of instances, we talk about fire-rated materials. We talk about class A, class B, class C. But yes, fire can also be classified based on the object or the material it gets in touch with. So suppose if it is getting in touch with a material which is something like a wood, paper, or a fabric, then it is classified as class A fire. And here you can see what are the what is the way you can extinguish this fire. So similarly, B is for flammable liquids, C is for fires which are involving live electrical equipment, D is for metals and metal alloys, and when fire comes in contact with our kitchen items, which is usually filled with animal fats and probably vegetable oils, so the kind of fire that occurs is the kind of fire is class K. So to understand how a material can be classified on action of fire, we need to understand this graph, which is very important, which is a graph between temperature and time. So any material now might be at a certain phase, but in general the process is that there's an ignition first. Once there's ignition, then it goes to a growing fire stage, and between the growing fire stage and the fully developed fire, you have something called flashover potential. After that, the cooling phase starts. But when you talk about a product which is A1, A1 is something which is completely non-combustible, which means that no component of the material actually catches ignition. So it is completely non-combustible. When you talk about A2, for example, let us say glass fiber. Glass fibers are connected with each other using adhesives. So they can thermally degrade to some extent, but major component of the material remains intact. For example, we have something called M-look, where we have a decor paper on top and bottom, and it has a fiber mineral core. So the decor paper can get burnt, but the fiber mineral core remains intact. So this falls into the category of A2. Then you have something which is B. B class is, now the material goes under the ignition phase. It goes into the growing fire phase, but it will not go into the fully developed fire. So what it means is that if you apply a point of contact of flame to this specific material, it burns. It burns, but it has a tendency to retard the flame. So generally, class B products fall into the category of flame retardant products. Then you have C, D, and F. As you go in the ascending order, what you can notice is that the time period required for the fire to go from growing fire to fully developed fire, crossing the flashover potential stage, is very rapid. So as you go from C to F, these are products which are generally not preferred by most of the architects and facade consultants. We have a lot of classifications when it comes to fire. We have seen European classifications, we have seen British standards, we have seen ASTM standards. So just to be, I will not go into too much depth on the subject, but yes, if you look at especially class A2 and class B, we follow EN 13823 code, which specifies how it can be classified into this specific category. When the similar kind of thing, when you look at the British standards, we follow BS 476 part 6 and 7. Our national building code is also in sync with BS 476 part 7. So whatever is class B equivalent in British standards falls under class 0. So this is how you can compare. A1 is non-combustible as per British standards. A2 in European standards is limited combustibility. And B is 0, C is 1 and 2, D is 3, and E is 4. Now, American standards are slightly different. If you look at the American standards, they talk something about flame spread index. It's the amount of fire by the length of fire. Now, when you talk about length of fire, what does it mean? Fire can spread both horizontally and vertically. Generally, vertically it is spread because of a natural phenomenon. Horizontally, fire is spread because of the material property. So it is very important to understand what is the flame spread index in order to categorize a certain product, whether it is class A, B, or C as per ASTM standards. Now, when I talk about in European standards, whether you take class A1, A2, or B, they still fall under class A. Because when you look at, for example, when you look at a high pressure laminate, generally most of the high pressure laminates fall under class B. But yes, there are certain, Fundamax is also into fiber mineral core, which categorized as class A2. The flame spread index varies between 10 to 15. So whatever is classified generally in A1, A2, B, usually it may change based on material to material, but usually falls under class A of the ASTM standards. So now comes the important thing. How do we select materials? How do we shortlist materials? Generally, what are the materials available? Probably architects will definitely have a lot of knowledge on this subject, but I will just brief about what are the different materials generally are available in the used for the facade, and how are they different from each other. So when you talk about aluminum, as you know, aluminum is a superconductor of heat. They also reflect high reflectivity compared to iron or GI. It melts at around 600 to 660 degrees centigrade. Now, a solid aluminum panel, we have seen that it is being used in a lot of facades, which generally categorizes in the class A. To be more precise, it falls in the category of A1. When you talk about ACP, ACP is nothing but you have two thin aluminum sheets with the insulating material. If the insulating material is polyethylene, then it is 100% combustible. It falls under the class D category. But if the insulating material has a combination of fiber mineral core and a little quantity of polyethylene, it may qualify into a flame retardant category, which is class B. But if it is completely with fiber mineral core with two thin sheets of aluminum, then it may classify under class A2, which is generally what we refer as fire-rated ACP. So in ACP also you have A2, B, and D. So it's very important to understand and check for the fire certifications before the selection of any material. Now you have stone, and again stone, you have lots of stone, which is pretty famous. And even now it is a big hit in the Indian market because of its own charm. Now when you look at granite, granite is also a very commonly used product. And we have seen in certain cases where it has not performed well due to fire, because it can explode and disintegrate in case of a heavy fire. And in most of the cases, fire generally occurs because of some kind of short circuiting which happens. We have a lot of combustible materials inside. When you talk about the exterior, I'll brief that in my next slide, which will give you an idea. After selection of the right material, how important it is to get it installed with the right system, because even if your material is completely non-combustible, if the installation system permits rear ventilation, which allows the air to circulate very fast, then the fire can spread just like that. So coming back to the point, limestone can also easily crumble in case of ordinary fire, but sandstone is something different. Sandstone here is this it has a very compact composition, and then it can withstand fire to a great extent, but they all more or less fall under the category of class A and rather A1. Zinc, again, if it is a solid zinc panel, it falls under class A1. If it is a zinc composite panel, it may fall under the class C. So this is how the classification of materials is like. And as I've seen in the video during my presentation, change is something which is constant. We have to completely evolve and innovate ourselves so that we acclimatize to the requirements of the architect. We have been in the market from quite long, but we were always focusing on class B product, which is a flame retardant product. Then recently, this is the new development. We have launched something called M-Look, which has a fiber mineral core. It has 14 different layers of glass fiber, 12 gray-dyed glass flea with 2 overlay glass flea with plain color, so that the gray at the bottom does not, the shade does not come on the top decor paper. So this is how the composition is, and this falls in the category of A2. So I have already briefed about what are the categories in HPL. Any facade, generally to make it more energy efficient, we adopt a system called a rain screen facade or a rear ventilated facade. Now, when you talk about a rain screen facade, I know most of you will be aware, there are 2-3 basic parameters. There should be a cavity between the final finished panel and the wall. It should be at least more than 2 centimeters. And there should be a vent on top and bottom. And the framework should be vertical, so that there is continuous circulation of air where the hot air enters into the cavity. Due to low density, it rises up and it comes out. So this process not only increases the energy efficiency of building, but it has other advantages as well. So when you talk about it increases the life of the building, it acts as a bracing, and it can cover all the cracks. It avoids diffusion of water vapor, whatever moist thing that you see on the wall. Because of continuous circulation of hot air, your facade remains healthy, it's able to breathe, and it reduces the decibel level to a great extent. And you can further increase the energy efficiency and thermal efficiency using certain kind of glass wool as well. And it acts like a thermal bridge and ensures ambient temperature in the building. So now, we have discussed on various standards, but as I've already mentioned, it is as per BS 476 Part 7, and this is what NBC 2017 also states. ASTM E84 standard, as I mentioned, our spoke index is somewhere between 10 to 15 for a HPL. And it falls under class 0, which is equivalent to EN. If you look at the class, European standards, it falls under class B. And ASTM standards, it falls under class A. So now, product, definitely we have understood that there are a lot of products now. There are different classifications. There are different standards. We understood which product falls under which category. Coming to the fixing and installation system. Now it's very important to understand how the system should be done in such a way that if there is a fire breakage somewhere, then how do we arrest the fire from spreading to other parts of the building? This is the basic thing. When we follow a principle of rear ventilated facade system, there is circulation of air and it allows the fire to spread very rapidly vertically. It's a natural phenomenon. So now, until and unless you compartmentalize various areas and then you use something called fire seal, whenever you have an opening in a dead wall, and let us say it might be for a window, until and unless you use proper fire seal, you seal the compartment and arrest the fire from spreading to the other areas, then having even a A-class material will not make much sense. So there are a lot of companies which are into it. I'm sure even Firestop is here today. So that's how it is. So until and unless we compartmentalize it and arrest fire and do not allow it to spread, it will not work in our favor. These are some of the interesting projects, as the topic is, impact because due to fire and also some various facade applications. I would like to share you some interesting installations which has been done by Fundamax. Here you can see the panels are perforated, and this is I can proudly call this a kinetic facade. The panels are suspended on stainless steel ropes. It's a 700 mm by 700 mm panel. They keep moving with the wind. Either a set of 2 panels or a set of 3 panels are interconnected. Because of continuous wind flow, they keep moving. Generally, you see this in aluminum fins, where nowadays you're getting a lot of products which are very thin, which keep moving. You get the wavy pattern. You can get a similar kind of pattern in Fundamax. And this is a school building in Bangalore, where we have done a very unique application. The facade looks very unique. It's an Indian project. We can integrate a HPL panel with glass. We can make it a semi-unitized system. It can also be done at the factory and directly installed at site. So that is what we have done here. You can see the gray color, whatever opaque material you see, that is a HPL, and what you see, which is transparent, that is glass. This is a station in Czech Republic. It is done completely on MS structure using stainless steel rivets. It's an interesting application. It gives a different kind of perspective view. And MLOOK, as I mentioned, which is a class A2 material, there are certain advantages of this material. One thing is that more than 22 meters high, as per general European norms, you're not supposed to use a B-class material. So you'll have to use an A2 class material. And especially if you have let us say, two twin towers facing each other, connecting with a bridge, probably the face of the building which is facing one another, that can be done with MLOOK, and other parts B-class can be used as long as the height is not more than 22 meters. If the height exceeds 22 meters, you have to use something which is A-class material. So coming to Fundamax, just a quick this thing about Fundamax. We are an Austrian company. Inception is in 1890. It was started in the form of a sawmill by Carl Funder. 2007, we have started our operations in India. We are a 14-year-old company in India. We have executed close to 15,000 projects. We are into complete system selling, and we operate through our authorized channel partners. We have 44 channel partners across India, and we ensure that we take care of technical compliances. We do complete BOQ, shop drawings, structural analysis. But of course, it has to be vetted by a structural consultant. But we have the capability to make the basic analysis and give it to our architects and end customers. So we have our manufacturing facility in Austria. We have our corporate office in Bangalore, where we are equipped with more than 60,000 square meters of stock at any point of time. So, last but not the least, we have a lot of variety of shades. I don't talk generally about the aesthetic part in the front during the beginning of the presentation, because it completely dilutes the subject. We have a lot of options, a lot of shades. So depending on the color theme, the color palette, the pattern, and we try to get ourselves acclimatized and work closely with the architects. So these are some of the applications. These are some of the Indian project pictures. As you can see, these are some louvers. And that is a semi-automated facade, manually operated facade in Ahmedabad, the one that you see on the rightmost corner. We have done some parametric kind of facades as well. And we have different finishes. So we have used something which is very glossy here. And this is for a school building where they wanted some protection so that the kids don't, jump over the railing. So it was a perforated panel. We have designed it. It has a lot of perforation. We have designed it so that it can take around 3 kPa wind load. So these are some of the projects we have executed in the last 2-3 years. I hope the presentation was informative, and thank you all for your time.
Continue that applause, because he said thank you when the counter struck 1 second. So thank you so much.
Thank you.
Fundamax has a booth outside, so just in case you all want to know more of the products, please pay them a visit. I would like to call upon the next speaker for today, Gautam Bhasin, who is a consultant and a very good friend. He's been in Hong Kong for a very long time. You can come on stage, Gautam. And he will talk on addressing the cost conundrum, cost-centric design decisions, smart tools for cost-optimized solutions, and value engineering versus value optimization. The third pointer should be very interesting. Do we have the presentation loaded? Okay. So
I can sing a song if there's no presentation. Yeah, it's real. I'm back on the stage after a very long time. Slightly overwhelmed, to be honest, to seeing so many familiar faces in the flesh. And I think kudos to Zak for pulling this off after some justifiable delays over 2 specific dates. And special credits to Ahad and his team for sort of dealing with one very difficult speaker who sort of pushed and pushed and pushed and finally gave a presentation this morning. I think last 2 years have been very difficult and challenging, to say the least, on a personal front, on a professional front. And I think we all have our stories. Everybody under this roof will have their own stories about how we've dealt with the last 2 years, with our own personal grief, challenges, business-wise, personal life, etc. But I think one thing that we all did, I think most of us at least did, is to basically hit the brakes and think for a while that, how can we change what we're doing? I mean, that basically gave us an opportunity to take a pause and rethink and restructure the way we actually approach business, the way we approach design. And I think all of us have had opportunities to watch that one movie that's been on our list, read that one book. A lot of us attended webinars, a lot of us attended or took online courses. So I think we basically utilized that time of crisis even very productively. One of the books that I read through the pandemic, which I still haven't finished because things suddenly got very busy, was this wonderful book, which it's called Form Follows Finance. It's a writing by Carol Willis, published in 1995. And I think it's less of a book, it's more of an extended case study, more of a research paper. And after having gone through the book 3/4 of the way, I actually realized that there's 3 overarching principles that the book states. The first one is that the buildings that we choose to occupy, choose to live in, choose to do our business in, choose to shop in, choose to entertain ourselves in, are spaces, but then buildings by themselves are business. People actually build them as a business. The second one is that spaces, we tend to get philosophical about spaces, the quality of spaces, etc., which is all in its fair position. But space is also a commodity. With the kind of competition we see in the market, the developer world, we see that there's a lot of competition, and space, depending on where you are, becomes a commodity for consumption. And then third, which I guess is almost a no-brainer, that location and image has a value. So effectively, the way your building looks and where it's located, it generates its own value, and that then feeds back into the space that you're trying to generate as a commodity, which gives its value, and then obviously it generates better business as well. Now, having said that, I think last 3 years have been very challenging, and what I'm going to address today is how did we utilize those 3 years, or last 2 years rather, to rethink the way we do what we do, the way we decide, the way we design, the way we approach design, the way we approach engineering. And I have 3 examples or tools that we worked on that basically made the decision making of how finance impacts buildings, essentially. So in a utopian situation, when you approach buildings, there's user aspirations, me as a buyer or me as a tenant, what do I seek from my buildings, that then informs the developer's brief, which then translates to design and engineering solutions, where people like us come on board and then develop solutions, and then that actually leads to a built outcome. Fairly linear process. Sometimes it keeps back informing the previous party of what needs to be done, and then eventually becomes a built outcome. What's very interesting, which almost has been in existence as an external pressure on this entire process, but more so in the last 2 years, is the way markets behave, is the way budgets become very, very dynamic. Suddenly, things start drying up, and you have to start reacting to that, and then that actually involves the developer's brief, and the developer's brief becomes very dynamic, and then it stops being a linear process. So I think what we thought was important was to actually have some kind of a circular interaction where we keep these 3 things front and center of the table with everybody sitting around, and then that actually informs all our work together. So rather than it being a linear process where you have to keep going back and forth, that actually stretches your design time, stretches your construction time, we can actually keep ample visibility to it, bang in the middle, and then that sort of starts informing all our work in more of a circular fashion. So having said the context, I'll go through 3 examples where we sort of tried to bring a little more smartness to cost-based decision-making, where we try and handhold clients through certain decisions, where we try and ease those decisions. Rather than having options that we have to go back and work on, we try and create some clever tools which actually allow clients to take decisions with ample optioneering that's actually available inside a room with all the stakeholders sitting around. The first tool that we worked on, it's generally, cost is a very static process where you start with design, you provide a cost for it. Oh, it's too high. What do we do next? Okay, option 1, we can change this. Here's the new cost. Yeah, still okay, but then still not meeting the budget. Option 3, option 4, option 5, option so on. We go up to option 12, 13, 14, 15. So one thing that we did to sort of shorten and squeeze the process is to try and create a level of dynamic tool which actually helps take decisions as you move through the process, but in a much shorter time where all the options are baked into one simple tool that actually allows you to make quick changes, and that reflects on where the final cost is. So the first starting point to that is obviously having an understanding of what is the apportionment of your overall cost across the facade. Just a generic diagram, not related to any project, living, dead, or otherwise, just a disclaimer. So understanding of where your money is going on your building, obviously in primary facades, which are your living spaces, your workspaces, which are your occupiable, habitable spaces or tenantable spaces, comes first. And then you have certain other areas, which could be your mechanical floors, could be your lobbies, could be your crowns, so on and so forth. So identifying where the options are needed, which will actually make a bigger dent in the cost of the project, is very critical. So that's your first port of call. And then what we do as a next step, which could be a highly evolved Excel for that matter, but it could be something even more than that, is to basically keep baking options that are possible, which could actually start with the highest aspirations of what the architect has envisioned, all the way down to something that can be very basic, not compromising too much on the built quality, which could be architectural and technical, but then it actually has all the optioneering built into it. So starting from choosing all the options that you can bake into a system options, into your infill options, and then that dynamically operates what the total cost would be, and then that actually gives client visibility on how the cost is reacting to each of those decisions. And the wonderful thing is we've actually tested with a few clients with all the material samples laid on the table, saying, hey, what if I use that? Okay, that would be the cost. What if I use this glass? That would be the cost. What if I use this system? That would be the cost. Now, what that does in a very iterative fashion, rather than having to go back and forth, trying to generate costs again and then trying to get to a client face-to-face, which tends to stretch a lot, is basically giving you an idea of where the base scheme starts, and then how every material decision or how every option decision changes that cost dynamically. So moving from a base scheme, and again, numbers are hypothetical, not having to do with any project, dead, living, or alive. It basically moves from a base scheme with a small change. When you change the screen material, change your glass source, it moves down further when you start looking at less complex glass processing. But then some places, architects would want to have a say, which the clients agree with, saying, okay, this is a touch and feel area, we may want to have a better material here. So cost rises up, but justifiably so, because that's an area they may want to invest all the money or part of the money that they've saved this far back into it. And then you keep dropping further unless you come close to a comfort point where the client says, okay, I think we are good here to start with. We can close this design stage with it and then move forward to the next one. Now, obviously that looks at material options, system options. But employers, clients, developers, they often are at a handicap, and justifiably so, where they can't really visualize what those options really mean, right? Materials, you can see, okay, yeah, this is what I'm getting. A building that was using that material looks like this, so all great. But when it comes to design modifications, sometimes, oh, curtain wall's too expensive, can you put windows here? But what will my building look like? Fine, architect will go back, do some renders, a week down the line, those renders will get shared, we'll come back to the same table. So is there a way to actually make that decision-making more adaptive, more quick, more faster, probably in form of a tool that can actually help visualize, not in form of fine renders, but at least from an experiential point of view, okay, this is what will, if I make this choice or make this decision, this is what the change will look like on the building. So essentially it's about what you see is what you get as a tool. So this is almost a version 2.0 of what I just showed you, where essentially you have a built floor plate. You can identify rooms in the order of priority, where you may have a living room, master bedroom, where you may want to put a better experience from inside out, which also starts defining what you want to do on the facade on the outside. So in essence, step one would involve a selection of system parameters where you choose your system, what kind of finish goes on it, what kind of infill goes on it, what kind of glass, where are you sourcing it from. Step two is where you start choosing selection, where you start selecting parameters for each of the rooms, each of the bedrooms. So let's say bedroom 2, which is a guest bedroom, not the most critical area, because if I'm investing in a very expensive house, I might want my bedroom to have the best experience, where I could just open the window up, while a guest bedroom could have a slightly smaller window. Even individual features like fins or external shades can be customized, where you can actually have drop-down menu What that does effectively is gives you a total cost per square meter in a very dynamic form, but parallelly on another screen, there's something interesting that's happening. On a parallel screen, you have a half-presentable 3D model that's actually updating itself with each of the each of the selections you make. So you start with a very, very basic facade where you have horizontal windows, punch windows sitting on a meter-plus sill. Then you also have a cost scale on the right that actually keeps moving up and down. And with every decision you make, you start introducing tall sliding windows with railing behind it, and you can have multiple interior views as well of each of the room. So not just the building on the outside, but what it looks like from the inside. And then the cost scale obviously starts moving up and down with that. Suddenly, you may want to have better aspirations that you want to introduce a curtain wall in your living room or master bedrooms that then starts reflecting what the cost is like. At this point, we still have external surfaces or external walls painted. And then we decide to start add cladding to it, and then again with cladding, various materials, multiple options, where do they sit from a cost standpoint? That starts reflecting back into the cost scale. So this is, again, highly customizable of where you can go with this and what are the parameters that you would like to see, whether it's visual, whether it's a cost, per square meter rate, or the entire building cost, etc. That all can be customized within that. The third component, the last component of my presentation is about engineering. Like we draw, we detail, but at the same time we also engineer from a structural point of view. How do we actually, how does our system actually deal with all the external forces, wind loads, barrier loads, so on and so forth. That also is a very static and linear process where you have an engineer basically working out on one single configuration at a time. Something changes, he has to rework on that. Something changes, he has to rework on that. So if there is a method or a way to actually look at automating that process to an extent where you can actually look at multiple options in a much, much short span of time. And I'll illustrate it with a simple example of a curtain wall, which is basically on a fully glazed envelope that we see on a typical, on typical office buildings, typical residential buildings nowadays as well, where we have some key design parameters, and then there are some key optimization parameters. Obviously, when we are designing, we are trying to make the solution as optimum as possible. So with optimization parameter, we'll look at this leanest aluminum consumption that our building can have, and the least glass wastage optimization that we can have. Now, with glass wastage optimization, I think there'll be many experts in the room from the glass industry who know how it's done. We do it as well, and they probably do it better than us. But when it comes to the optimum structural size, the optimum aluminum consumption that can actually help you get the structural performance that you want, those are the parameters that you need to look at. So you start with the floor-to-floor height, wind pressure, which is defined by the footprint of the building and the height of the building. And the system zone, which is essentially how far out can your curtain wall go from your slab edge. The ones that are highlighted in yellow are typically set, so they are non-negotiable, non-changeable, depending on which city you're building in, depending on what kind of building you're building. But there are certain areas which are negotiable, and that actually is a conversation between the developer, architect, and the consultant, which actually involves vision to wall ratio, so how tall is your vision and how tall is your spandrel, the total panel width, what is your module size, the stack height, how far up the stack joint sits from the finished floor level, and finally the frame size, which is on the diagram on the right. So with the constants sitting where they are, you have you generate multiple conditions that then need to be engineered. Let's say you have two vision to wall ratio alternatives. You may have like 3 or 4 panel width alternatives. You may have a stack height configuration in 2 choices or 3 choices, and then you might have 3 or 4 different frame sizes. With each of these permutations, the number of options that you need to generate from an engineering perspective to reach that optimum point will be running in hundreds. And that's sort of impractical to sort of get one person to constantly rerun. And that sort of puts you in a position where you basically just think, okay, that just seems right. Let's run that. If it works, let's go with it. So what we did basically is to take all the variable alternatives here and see if that can actually be built into an algorithm that helps you achieve what we call as the optimum cross-sectional area in a facade. So with alternatives, and this is basically a screenshot of the tool that we created. Material properties can be modified depending on what alloy are you using, what aluminum alloy you're using, and then you have design attributes like wind load, factor of safety, mullion spacing, which means your module width, and then the flow-to-flow height, which more or less remains constant. But at the planning stages where things may still be moving a little bit, you can actually come back with a better answer at this stage. And then you have a stack joint height, which you can play around with as well. And essentially, all of these values can be changed, and you hit run, and essentially what it gives you is an optimum mullion depth to cross-sectional area ratio. So in this case, you have wind load of 3 kPa, a mullion spacing of 1.2 meters, flow-to-flow height of 3.6, and stack joint just sits a little above your flow level, and you get 160 mm depth of your system and about 1464 mm square as the cross-sectional area. The beauty of the tool is that you suddenly start seeing how dynamic it is. So the minute you change the wind load to 4 kPa, which may not happen, you may only want to play with your module sizes, that's where it starts generating dynamically what will be your optimum mullion depth, with the mullion width again fixed, and you get a depth of 175 mm and a 16-15 millimeter square as a cross-sectional area, and that is where it sits at an optimum. Anything deeper or anything shallower, you start consuming more aluminum. Again, retaining wind load at 4, and this is my last example, retaining wind load at 4 and increasing the mullion spacing to 1.5, you suddenly start seeing a spike where you may start needing more cladding zone, which may or may not be possible on the project. But then again, if you start reducing it to sit within the cladding zone limits, you suddenly have a higher aluminum consumption, which then can be discussed as a solution. So here we've gone up to 190 and a 1747 millimeter square just to deal with an enlarged module and also a higher wind load. And with that, I'll close my presentation. Thank you.
Well, thank you, Gautam. Any questions for him? Today's audience is very enlightened. So, you have a question? Give me a mic.
On your modeling of analysis of the option, the parameters are changed and you have that visual as well as the other aspects of that option. Is there an option where you also see the performance variation and the behind that can be seen when you change something, whether it's performing well in terms of energy or a heating load and so on and so forth? Do you have extended that aspect in your system?
We share a brain. That's work in progress.
Okay. That would be very helpful.
Yeah. It's certainly the next step that we want to take, where effectively you may not be able to get a very high level information from it, but at least the basic levels of how the building reacts from an energy standpoint, from a daylight standpoint, and all that can be run concurrently. Any other questions?
Okay, I can just, I have a question. Actually, it's more of a comment, I would say, than a question. You've demonstrated brilliantly through all these cost models, potential savings that you can give by just, pure, I would say, value engineering, not on the material side, the optimization of material side, but, working on sizes and working on some of the other contexts that you just mentioned. One of the challenges, and I think I can speak on behalf of all the material suppliers that are in this room today, the challenge that we are facing right now is the exponential rise and increase in costs of materials post-award of that project. And if you can just share some insights, if something like this has happened on any of the project that you worked on, where the work is awarded, but now for suppliers like us, it's no longer feasible to work on those because the costs have gone up to a level where it runs into, it erodes all the profits and gets us into losses. Is there any sort of instance that you've come across? And I think this is a very characteristic of the post-pandemic era with, imports have become almost infeasible. even local supplies, there's this big gap between supply and demand. Do you have any experience to share on that?
I think it's happening on every project, but can we take this over a coffee instead of me answering?
I said that's why it's not a question, it's just a comment. So
You almost got me with that.
I have a question. Yeah, here.
Yeah.
This tool that you have displayed, is it something of a software in a beta stage, or some part of it is ready for,
So the versions that you saw are actually being applied on projects as we speak. We've done internal testings on it just to basically verify. So even the kind of outputs that we get through the software, it's basically a computer program. So it's garbage in, garbage out. You give the wrong parameters on one end, you will get something unusable on the other end. So we've even gone to the extent of actually testing whether that complies or whether that works or not. So these are actually in use.
So is it available for the public at large, or is it only for your in-house?
It's currently in-house. I'll be out of business if...
Okay, thank you.
you can put an MRP on that.
With GST.
All right, thanks Gautam. Thank you so much. Please give a big round of applause to Gautam. And with that, we'll move on to another very interesting product presentation. This is on tensile fabrics for facades from a company called Serge Ferrari. And I have behind me Arun Madappallath, who's the general manager for South Asia, and he will enlighten us about his product. One second.
So, good morning, everyone. It's really wonderful to be back on stage after a long time. Thank you, Zak, again, and our cooperation continue with Zak. It's a good platform to present and educate the product range, especially on the facade material. Okay. So just topics which I'll be covering today. I'll go to the, so about Serge Ferrari Group. So Serge Ferrari Group, it's a group of company who develops, design and manufacture innovative composite membrane for different applications, lightweight architectural and exterior landscaping applications. So we are primarily into 4 market segments: solar protection, tensile architecture, modular structure, furniture marine, with solution combined durability, safety, and design parameters. It's a group of company. We have factories in different parts of the world. The headquarters is based in France, in Lyon, La Trédoupan, where we do the weaving, PVC coating, PVC extrusion, logistics, etc. And we have acquired a new company, which is Vizerac. It's a big group of company who manufactures durable material. It's PTFE material, fiberglass PTFE materials. And then we have other locations as well, manufacturing the yarns and the other PVC extrusion, etc. We have also acquired a company in Taiwan, FIT, which also produce glass yarn and PTFE material. So basically the 4 markets: tensile architecture. In the tensile architecture, I'll be covering the facade application. But beside that, we have tensile roof, shading structures, acoustic, etc. Then we go to the modular structures. We have solar protection range of fabrics, beside furniture and yachting range of fabrics as well. So tensile facade, it's a new style of architecture. Why fabric being used as a facade, and what are the benefits of fabric if you use fabric as a facade? It can be used for a renovation application as well, and the mesh and tensile facade system for curtain wall fabric. Okay, so natural materials which exist in nature, like soil, grass, bamboo, wood, and stone, but now new materials which are metal, polymer, and fabric materials now coming into the facade business. This is a translucent mesh which is made in Germany, a new architectural skin representation. And of course, opaque membrane can also be used as a facade application, a flat film shading for the complete envelope of the building, and high translucent materials as well for the lighting and architectural applications. So performance, so freedom of shape, this is very important. We can create 3-dimensional modeling and 3D envelopes with this facade, textile facade system, because it's a flexible material. Yeah, this is an interesting project which we have completed in Coimbatore. It's a PSG college, wherein part of the building facade was used with such Ferrari range of fabrics with a three-dimensional design. So different possibility of three-dimensional structures possible. This is an Airbus project in France. Again, you can see here, this is a double system where you have a glass curtain wall as well as fabric as the external facade. It gives a combination for the building. So you can see the architect idea was to provide a geometric pattern, providing the green leaf effect, wherein the fabric curtain wall and the trees which are growing outside the building can harmoniously with the surrounding plants. And the good part is that the external view, okay? So during the day, the people outside cannot see inside, but we will have a good visibility towards outside, and at the same time, natural light will come inside. And during night, it has the other way it works. You will see the enlightened building and inside of the building, but from the outside. Okay, so it's 6,000 square meters of fabric has been used. It's designed by Schwimbeer and Kendall, Munich, Germany. It's a very beautiful project in China, Shanghai Pavilion. Just a three-dimensional facade renderings, how the schematic design has been developed, and proceed further. Then they make the structure, the design of the complete structure, steel element of the project. Then they do the membrane analysis, and then they do the patterning of the membrane, how it has to be cut and how it has to be welded to make the complete project. So you can see panels can be erected after the complete engineering. So in the sun, it gives you a opaque feel, metal feeling, but during the night, the building is visible outside when it is illuminated. Again, few examples. It's a Spain project in Spain. Okay, the echoes the background of the mountain during the daytime, and during the night, when it is lighted, it looks really architecturally beautiful. Another project in Munich, three-dimensional 3D shape. This is project in Jakarta. So shapes can be created. This is another project designed by architect Dinesh Verma from Ace Group of Architects in Bangalore, Ishavi Boutique Hotel in Mysore, wherein the facade was completely used with fabric. This is a project in Germany. So the idea is to show the creativity of the material and architectural developments. So this is a project. Basically, it's a PTFE fiberglass fabric, and by Versadag, and this has been awarded with the prize of Bill Boten NRW 2020 award in Germany. And another interesting project, it's a 246-meter height tower, ThyssenKrupp test tower in Germany, 246-meter height, and the whole building is wrapped completely with fabric. And the 22,000 square meters of fabric has been used. A mesh fabric has been covered with the whole building. It's a very interesting project and challenging project as well. Okay, colors, you can have dynamism. You can beautify the building with the different colors done by, for project in, Cortes project. So the entire project looks beautiful after the facade addition to the building. Again, a glass building in Spain, covered partially with the fabric on the front side, where the sun is hitting. Another sports hall. Now with lighting. So with lighting, we can beautify the building. This is the day, this is a project in Netherlands. The daytime, you can see the building wrapped with fabric, and during the night, you can give different lighting solutions, LED lighting solutions for the project to beautify the project. in a sports hall in Angola, daytime, and during night you can see the beauty of the project. You can give different colors lighting as well in the project. And outside visibility is still not blocking. This is a restaurant in Bali. This is in Konzo. Again, the LED lighting effect of the building to showcase. This is a beautiful project in Brazil, a stadium project. The whole facade and the roof of the project is done with fabric, Verzerac PTFE fabric. And the day effect, and during the night you can see how the building is enlightened during the night. Then printing possibility is there in the fabric. So different adaptive printing can be done. You can see the printing on the facades. Different style of printing can be done. And this also, the building is completely wrapped with fabric with a beautiful printing element on it. This is in France, in Lyon, the fabric facade, printed fabric facade. Again in Houston, multi-story car park, enlightened with the printing and the facade. This is the Shavi Boutique Hotel in Mysore, which I was talking before. Another advantage is that we can do the projection on this fabric. This was a marriage function, and during the marriage functions, they do projection on the fabric. Other applications, we have sliding panels. We have louvers, horizontal louvers possible with the fabric. Yes, then vertical louvers as well. And different, with different shapes or different design possible as well with the facade membrane. And movable, retractable, movable sliding panels also possible with fabric. So thermal comfort and energy saving, this is a key point. So you can have a blind inside the fabric, but classic interior way, wherein the heat will be blocked to a certain extent. But if you put a membrane outside the building with more than 400 mm gap, you can reduce the U value like anything, and G tot, the glass plus total exterior coming inside is only 0.515%. That means we are blocking the heat completely, almost 85% of the heat is blocked externally, and only with 15% of the heat is coming inside with the glazing type D. So with that, you can save energy. And we have a tool also for that. The tool is called Saltison tool, wherein you can select the location. So here I have done an exercise selecting a location of Delhi, and the building you can select either office, hospital, or school. I have selected office, and glazing percentage, you can select 40% or 80%, and the glazing type of glazing, I have selected type C, and the fabric which is used, which is the FT381, front side view 381, and the color of the fabric. If you select the fabric, any of the fabric, the whole color range will come. You can select the color of the fabric and installation. If it is a blind, it can come, you will get internal and external, but since it's a facade fabric, it's an external fabric, so you will get an option of installation exterior. Then you can confirm the inputs, and automatically it gives you the reduction in annual energy per year for the building. So in this case, the analysis, you can see that 48.4% of the energy is reduced for running the air condition. You can see you have a comparison without fabric and with fabric. What is the value you are saving in terms of energy? It's an interesting tool, and you will get all the inputs. You can get the detailed report also on that, on the annual energy savings, as well as monthly energy savings. and then the operative temperature, and the final report of the analysis. You will get that the reduction in annual energy of the building. It's a very interesting tool. It is open to everyone, and we can send this tool to everyone. And a case study on the renovation of a project, wherein the membrane was used, and we have analyzed the cost of energy saving during the years, and it has been found that this building has, we have a saving of $60,000 per year, and the total cost of the project has been recovered in 3 years. So this was before putting the fabric and after putting today, how the building look like. Architecturally, it gives a better appearance, as well as it has given a good energy saving as well. Okay, and then another project in Spain. Again, before and after, the energy saving was more than 50% of energy was saved during the, once you renovate with the fabric mesh. So you can see the temperature changes from 51 to 34 degrees once you put the fabric. So it's a big difference in temperature as well. Another project, again, we have a saving of energy. You can see that initially 68,000 was the consumption and the cost, and now it has reduced to 33,000. So very good savings in energy as well. Then glare control. Okay, you can see the building. You can see the glare is not coming inside. It is controlled when we use a mesh fabric outside. A similar case. The view, it doesn't block the view, and at the same time it blocks the glares, and the lights comes inside. So renovation case studies, we have many case studies. This is the building style center that has been renovated with the fabric facade, and you can see, with the fabric you can do the complete renovation of the building. So before and after. So few projects are done. So and of course no Faraday cage effect because of it's a mesh fabric compared with the mesh plates. FT381 does not shield electronics models, ensuring smooth communication as well. And wind noise. This is also a case study we have done with the fabric facade, the renovation of the building done out of 40 years of use and with a lot of noise. But when some fabric was put, the loud noise in the wind is not generating when we use the mesh fabric. So longevity, okay. Impact resistance to the building. It's a pre-contained technology fabric. So it passed from 0.5 kg to 50 kg. And at the same time, on the wind analysis and dynamic wind test has been done on 2.5 meter by 2.5 meter panel. And you can see number of wind cycle, and it passed up to on different cycles, different tensile strength. Antifungus, okay. It's no microorganism development in the fabric after use as well, and we have a detergent for cleaning the membrane. Okay, so solar transmission, solar absorption, and it's 100% of the solid solar energy, and we can guide which color is better for better thermal performance in terms of your projects. So the total benefits is transparent, controls glare, natural light come inside, design as well as privacy, because we spend 90% of our time in the building, and you can see we have a very good solution as a secondary membrane as a fabric for your projects. So many projects comparison. This is a micro perforated fabric comparing with the macro perforated materials. You can see the visibility is much better when you have the micro perforated material. So you can see the outside visibility is much better. Okay. Then we have tensioning system. So this is a key part because we have the fabric, but we should have the system to do the complete projects. So a company so we have different possibilities is there, free-form structures with steel or with framed and monolithic frame system. But we have tied up with one company called Façade Textile company who manufactures the complete system. And they have appointed one of our partners, Shah Decor, as the distributor of this system. So these systems are available, and we can make panel size up to 60 square meter panel size profile systems. Different profile systems are there. And they have also come up with a new system, which is called Solar Skin Lineup, which is really a good configuration system developed by FTI, and which can be used for PTFE, PVC, PTFE material as well. So they have 12 configuration of the systems they have today. So, and interesting is that you can go to their website and download the system and how the configuration has been done. Everything is well detailed, explained in their website how to get the details done. Okay, then the few reference projects done by using FTI systems all over the world. Okay, and this is, I think I can play the video here. One small video on the Saffron project, multi-story car park. Actually, this is not a printed fabric. It's a fabric welded with white color fabric. Sorry, I will take another 5 more minutes. To be frank, I didn't look at the time correctly. Okay, so just want to give you an explanation on the range of fabric we have. We have PVC coated fabric as well as PTFE coated fabrics. FT381, 17 colors available. All fire compliance is there. Then 371, which is mainly used for printing applications. Then we have a new material called STFE material, which has got more than 55% light transmission comes inside. It's not a mesh membrane. It's a plain membrane with a special coating. And then we have Versatag material of 21% openness factor and 52% openness factor. Of course, there are different fire standards. Aditya has clearly explained what all the fire properties of different materials. So we comply different fire standards for different type of materials. Yeah, and we have reports and warranty of all the fabrics. So I'll just run through this. Just want to show you a few projects. In India, this is FIFA Stadium. Dubai Expo, we have done a lot of projects for the Dubai Expo. And India project references, which is key. PSG College Coimbatore, which I have told you, 3,000 square meters of fabric has been used to cover the part of the building other than the glass. Actually, this is covered in the wall, not on the glass front. Then Eva Mall, Vadodara. This is done by McCoy, wherein fabric facade has been used. This was done 5 years back, and you can see the day-night effect of the building. And of course, Y Boutique Hotel Mysore, day and night effect. And KIT University recently completed by Shadeko, and Tensa Fab from Bhubaneswar. Very nice project, and you can see the visibility towards outside the building. And this is Bosch in Coimbatore, done by Shadeflex. And yeah, the current project, ongoing project, Nagpur Metro, which is under construction. And the Hyderabad Metro we have done with a plain membrane. Yeah, that's all. Thank you very much. I hope it was informative. And we have a booth outside the hall. So please visit us, and we can give you more and more information on the product. Thank you.
Yep. Well, thank you, Arun, for this nice presentation. And as he said, there is his booth outside, so please go and have a look there in case you want more information. We'll break for tea now. It's 11:45 in my watch, 20 minutes sharp, please. So 12:05 we will restart. We are running slightly late on schedule, so let's try and assemble as quick as we can. you to please come and settle quickly. So after that nice coffee break and good discussions on increase in prices, I hope all of you got it from developers. We'll move on to the next. We will move on to session 2 of today. Very interesting session. We have some presentations followed by a panel discussion. And to kickstart session 2, I would like to call upon stage none other than Rajan Govind, who's the director at BES Consultants. Very ubiquitous figure in the world of facade consultancy. Rajan has been working in Singapore, then he shifted to Mumbai, and it's my pleasure to announce that he has just completed 10 years in Mumbai as BES Facade. So I think he deserves a round of applause for that. A part of a lot of beautiful constructions in this part of the world and as well as all over the country. Rajan today will talk on building facade procurement insights, the approach to procurement, the tender documentation versus the outcome, construction design approaches, and impact of cost and value. So over to you, Rajan.
Morning, all of you. Thank you, Tariq. Thank you for sponsors and organizers, Zak. My great pleasure to be here. I hope you all had a good coffee break, so we have some good interaction. If any questions, you can ask. It's not very big presentation. I only have a few slides. I can keep it very short and simple. So just a one-page slide about facades. We work on facades. We are very passionate about anything on a facade, geometry, any interesting things, we do it. Sorry. So I tried to capture something on about procurement. The few speakers before me have spoken about cost. I think post-pandemic, we all know we are living in a cost escalation era. There is so much thing is going on. So I would touch base something on procurement insights, not just a cost, something about procurement, maybe a message to developers or owners or industry. Facade procurement, we all know, is different. So it's not just furniture or interior fit-up. It's very different. And facade is dynamically changing, unlike other industries where steel, concrete things, there is escalation, but it's not much. It's predictable. But facade, we're relying on so much material, imported material. There are many things. So it's dynamically changing. I would say procurement is generally done in many different approaches, irrespective of which client is doing, whether corporate or developer. But basically, they do these three different approach. We all know design and build, which is the work is given to contractors. He has the expertise to deliver the project based on his knowledge. And we have a typical contracting works, which is a little bit of design brief is done by the developer through some specialists or experts. They do some concept drawings, a specification, and then a client team is easy to manage the procurement based on some design brief. And then we have another approach is fully developed detailed design is done extensively at the pre-construction stage, where a lot of significant work has been done. There's not much work after the work award. So 3 different approach. Wherever in the world we are, is basically these are the approaches. There are procurement, it is not just financing things. There are aspects which can have a greater impact on procurement. Sometimes procurement is underestimated. There are a lot of values given for engineers, architects, maybe a site people, but there's not much focus given to procurement. Procurement at the end is going to define the delivery and outcome of the project. So there are challenges the procurement team manages dealing with the owners, clients in terms of finances, and then the design team. So the procurement team, though they are not all the way through the project, but they play a key role on a lot of decision making. We could see potentially there are things which is challenges to the procurement. As we all know, there's a balance between what is available and what you want to achieve it. Materials, procurement team, maybe they have a mix of team, not everybody could be engineer, there's some financials or accounting people, cost consultants, so for them to understand the technicality is sometimes they hear from somebody else, they need a support. So there are challenges from the team. And then at the end, they have to be balancing from cost and something durable, long-lasting. So if you have a budget, there's no compromise on a quality or long-lasting, rather you can build something within the budget. Procurement documentation. When we say about procurement, you need to have a very good design brief. It is very difficult if you have just a piece of one drawing sheet and go to the contractor, I want to build like this, because it's not a model making. So if the model maker can do from your simple 3D images. But for a contractor, there are a lot of engineering goes behind, so it's highly challenging if there is no proper procurement documentation. Though it works for a simple job, a standard job, maybe the contractor has been doing for ages, he knows what it is, so you don't need a lot of designs. But if something different, there should be a good procurement document will have a greater impact on the project. And that's procurement design itself is going to drive the project. I would say the procurement design is one thing, but the time when we will do the design is the most important thing. On the facade, as the facade industry we know is quite design intensive works we do it. So it's not a standard product, each project is different. So there are a lot of pre-construction design is going on. The design is only works if you do the design on time. If you do the design on somewhere of the downstream of the project, is going to put a lot of challenges on delivery. So from my knowledge, from the consultant point of view, as we involve from early stage, we see the importance of doing early designs. If you put some cost to the project duration, if you do the initial stage, anything you do design, you're free to do whatever it is. There's no major great impact. And if you do all the way, the design at the end of the project is going to cost. Timeline, compromise on a quality, there are many aspects. So there's always a good to have some design so make the life for contractors much easy, because contractor comes in at the middle of the project, especially the facade contractor. So the design are involved like architects, consultant, expertise like us. So they have a responsibility to give the proper good resolved design, not just to throwing things to the contractor, you deal with it. So there's no point you make 200, 300 drawings, but it doesn't work, and nobody can do it. So the drawing goes into trash. Then the contractor comes in, it's all a new R&D starting. So it's not a good approach. So if you have a detailed engineering design, there's a huge benefit on it costs less. And the more detailed design should be doing, which is better for the contractor. So the contractor, there is no need to blame the contractor. Contractor has a less time to work. He's coming somewhere, maybe last 12 months of the project, and he has to finish it. So there's a lot of pressure from the contractor. So as we are lucky to be involved on the day one, so as we have a responsibility to resolve the detail on the table, not at the site. Excuse me. Not just a typical standard library detail. Someone has to go on detailed project. In here, we are not building the blocks of one block copy to 10 blocks. So the facades, we are talking about a bespoke system, different project, different detail. Each one has a different complexity. So one has to understand and make sure he is giving a solution for various different solutions. Complexities, whenever we see something different, we know is going to create a lot of complexity detail. If somebody want to know the detail at the refuge is different, and we often see in the building construction, they show something in the drawing and something at the site. In this picture, you can see there is a column here. I don't know, yeah, there was a column here supposed to be, but when you go to the site, there was no concrete column. These are the works the contractor most probably doing at the end of the project. If something changed here, there will be a compromise on a quality, and he has to suffer with the bad quality. And then we go to the construction stage. So we have done with the design. We are going to the construction stage, where still the design is happening, but it is not starting from the scratch. Something is built there, where the contractor is taking, adapting, and then following the designs. So this is generally 3 different approaches is done here. Contractor design, is purely relying on a contractor, so he may have expertise. He's doing the same thing for many years. He knows it's going to work. He's relying on contractors. And you have a design which is little bit of consultant expertise is there, or sometimes is get peer reviewed. Or there is another detailed approaches. There is driven in the pre-construction design stage. There is not much happening at the construction stage. So the contractor comes in, he's going to adapt the design. So that's a different approach. And if you put the timeline here, so whatever we do at the project starting stage, you have a better control. Everything is going to be smoother. When you do the middle of the project, it's too difficult. So there is no time to do R&D, whether this work or that work. So you're doing R&D with the contractor at the construction stage. There is no time to test something. Whatever you're testing at the site is going to cost time, money, and quality compromise. And there is design finalization will get extended. There is no time for contractor to go fabricate and do. So he will be just for 3 months doing only the designs. So cost driver for the thing, it is not just, most of the consumption is like facade material is going to cost 70–80%. There is nothing else. Maybe as a non-technical finance people will think of it. So it is not just a material. Material we could see maybe 40–50% approximately. But there are a lot of huge value addition is done from the contractor side. But sometimes if you see the material cost is though significant, but if I see the quality control is just a very little effort, it has a great impact. So it often ignored and then say we have a great design, good material, a grade A material, everything is good, but at the end if it goes to the site is purely fabricated, there's no system, means it's not worth investment. So there are a lot of hidden components in the cost. As I said, it is not just a material, glass and aluminum and extrusion and other things. There are a lot of things which make a contractor from one contractor different from other contractors. The skills and capabilities, what setup they have, what is the knowledge they have. Do they have a knowledge taken from one project is going to another project? If there is no system, the knowledge is lost. If somebody worked for that project, he goes somewhere, the knowledge is lost. So is there a system the contractor is having to gather the knowledge? And is there a system he's adapting from quality control from the design to implementation stage? There are a few slides. So it is not everything is the same. So from the procurement, if it's only a finance people, they may think, I have done all this scrutinization, I have done pre-qualification, Excel sheet, everything, but I don't see a difference. He's quoting something, the other contractor is quoting something. I can just go with whoever is the lowest. So I'm not saying the highest will not guarantee will give a better quality, but not everything is the same. So someone has to go in detail why it is different. If someone has a fabricator factory, he has to put investment. If you have a good factory, obviously the deliverables will be better. So we can see it is not the same. So it is a supply chain, not just a contractor. Facade has so many components, glass, aluminum, extrusion, screws, nuts, everything is there. So we have to see how it get manufactured. Someone will say, I don't really care how it get manufactured, but I know the end product will be better. It cannot be better. If your facility is not good, there is no system, the glass will look, both glass will look the same. But you will only realize the face after 2–3 years. So it's not everything is same. So if there is no system, you will have a leakage at the site. Nobody can notice. It goes under the carpet. So if you have a monsoon, and this building is going to a lot of maintenance, and it is going to spoil the reputation. Easily, now these days we have a social media. If anything leaks, it goes to the media. We all know this building is leaked, so the valuation is going down. So it's not going to cost more. It is just this contractor is doing better, the other contractor is not doing better. Same, so we are paying for good work and we may get this work. So it's a site quality. So we have been seeing, especially this seal and detail whenever we go to the project, especially the project, we do investigation of existing project, we will only see hardly like a tissue paper sealant. So they don't put a sealant. So it's all just filled with a backer rod. We just put a finger, it will get break. So you have a better quality control. So it's going to cost a little bit more. So we have been seeing this on almost all the sites. So how you organize this, that's what delivering the project. It is not just you have a nice factory, everything is fine, but is not going into the building finally, then it's not good. So I know a lot of our own home, I don't see windows in my home without any scratches. So this is a poor state. We want to get what you see on the left, but this is what we get, because fabrication, handling at the sites, no control at the site, housekeeping, there are so many things. It is not just sometimes contractor responsibility. So there's no control at the site. So this is just my second last slide. At the end, the procurement process need to have as a holistic process, not just looking the numbers. The team procurement has a great role to play. They're the one is deciding and maybe advising the owners or investor. Maybe you can award to this contractor. He's economical, reasonable. So there are a lot of decision making is happening with the procurement. So they should have a holistic approach, get the input from the experts and do their own evaluations in detail, not just a financial evaluation, do the technical evaluation, not just, no point in just seeing the brochures, you have a 200 projects is done, but see deeper inside, how do they work? Thank you. So I finished in advance.
Thank you. Thank you, Rajan. Any questions for Rajan? I'm not going to ask you the same thing I asked Gautam, so I'll spare you the blushes.
Okay.
Any questions? No. Good. So, thank you. Give a big round of applause to Rajan once again. From Facade Consultancy, we'll move again to a product, and I would like to call upon stage Arvind Kumar, it's an interesting designation, Communication and Business Development. And I totally know why his company has given him this designation, because he is a great communicator and a great speaker and one of the nicest guys you'll come across. And he is from Technal, who is a presenting sponsor, so I think the applause will have to be louder because of all the money they've given for this. So, Arvind, over to you for high-performance facade and fenestration solutions.
Thank you, Tariq, for this nice introduction. Good morning. We just had coffee, you know. Good morning. It's afternoon already. I'm just checking you. All right, so it gives me great pleasure to be in flesh with all of you. One thing I can be very proud of is that nobody can switch off your cameras. All of your attention is on me, so I'm going to hopefully communicate the message which we want to tell in the next 20 minutes. So we're going to just trying to talk about a little bit of Technal and the presence in India. I would like to touch base a little bit upon the high-performance solutions we provide here in this market, and how do we future-proof your business with Technal. Firstly, Technal is part of the Hydro brand. Hydro is one of the world's largest single-source aluminum company with more than 114 years of experience, with 35,000 employees in 150 locations, producing bauxite to hydroelectric power to primary metal and extrusions. The extrusions business is where we belong, and in India, we have a very strong industrial investment of 350 crore rupees with our own vertically integrated extrusion plant with 500 employees, with 15,500 metric tons of aluminum production, with powder coating, anodizing, and PVDF facilities. Along the extrusion business line, we belong to the building systems division of Hydro Extrusions. And you must have come across some of these brands in this market, starting with Domal, Sapa, Vicona, and Technal. All of these brands put together, we bring over 240 years of experience in the business of architectural aluminum systems. The brand which we are promoting and marketing and communicating in this part of the world, from Middle East to India to Southeast Asia, is Technal, a brand which has been in this market for more than 60 years, headquartered in Toulouse, south of France. And something which we are very proud of is we are collaborating with architects and consultants at very early stage, making us one of their preferred choice in architectural aluminum systems. The kind of products we make are sliders, windows, doors, facades, but also fire-rated aluminum windows, doors, and facade, bullet and blast-proof windows, doors, and facades, pergolas, and recently we have launched also our seamless handrail systems. All of these products are tried and tested for 3 years before they come to the marketplace, so that you as an end user and a customer have a peace of mind working with a product which is tried and tested for several years before coming into use. In India, we've been here for more than 25 years. We have more than 62 authorized textile metal builders, or as we call aluminum and glass subcontractors. We've executed more than 1,000 projects. We're a team of 30, 11,000 square feet of warehouse space. Also, closely working together with the Middle East team and the Southeast Asian team, which my colleague Guru mentioned earlier. We're a team of 200 people supporting this Indian market. The kind of project services we do starts right from the concept stage, where we work very closely with the architects to identify the right systems for the market. And in today's age of digitalization, we're also supporting architects and consultants with our BIM services. We have our own BIM object configurator, which is configured right straight on Revit, or it can work on SketchUp, or you can seamlessly produce LOD 300 files for windows, doors, and facades at your own convenience and at the sizes of openings which you have in your particular project. After the design stage, we work very closely with the stakeholders of the business to improve the right costing for the product, for the project. We work very closely with our metal builder partners to make sure that the right price points are defined. And as we go towards the project award stage, a lot of discussions about value engineering, and some of the speakers before me already spoke about it. Instead of cost cutting, or as we call it, as killing the project with discounts, we try to see how we can engineer value by giving better solutions which can help improve the project performance and not just cost cutting. And as the project moves on to the construction stage, we have our own engineers who are visiting the fabrication facility, making sure that they are producing the products at the right quality. And once the products are getting installed at the site, our team is there to supervise and ensure that the products are installed as per the technical recommended guidelines. With that, I segue into my topic for today, high-performance facade and fenestration solutions. The conventional theme around this topic would be thermal performance, heat gain, etc., etc. But I want to talk more on the possibilities and the impact which we can create by choosing and early engaging with a facade system supplier like Technal. I want to start with this interesting project called the Address Skyviews, which is 264-meter tall building. And in this particular project, we had to deal with 12 different angles on the facade. We had to deal with a very specific concealed balcony door, which the client wanted. And instead of going and developing multiple ties, we kind of optimized the mullion design to just 6 different angularities, and this was able to take on all these 12 faceted angles. The architect was very particular that he did not want to see any frames on the balcony doors, so we developed a very special system with a concealed step glass which behaves and works seamlessly with the unitized facade system. This product was tested for more than 3.5 kPa wind pressure, 600 Pascal air and water tightness, giving it the full complete performance protection. Another interesting project, the Burj Vista, which is just behind this particular project, is 255 floors tall. The cultural requirement of this particular project was to have more earthier elements, so the architect wanted to use GFRC panels, and instead of isolating the GFRC system and the unitized system, we went ahead and developed a unitized system which can host the GFRC panels, so fully fabricated at the factory. and also areas where vision glazing was required. We married the GFRC panels and the glazing panels together in one system, completely fabricated and produced, assembled in the factory and brought to the site, helping in the faster construction. We also had inclined facade elements on the facade, which we dealt with a very special, unique stick curtain wall system with chamfered angles to mimic the shape and the angularity defined by the architect. Another interesting project which we have done is the NPP Twisted Tower in Doha. In this particular project, we had to deal with a very unique building geometry. And if we had used the same principles of sky views, we had to develop probably more than 60 different dies to take on the shape of this particular building. So what we did instead, we analyzed the possibility of coal bending. And with coal bending, we were able to take this huge panel of 1.5 meter by 4.5 meters. We were able to bend it to take the shape of the facade panel. And it's amazing how flexible aluminum and glass is, and the whole process involved was quite entertaining, and we were able to take on the building geometry quite seamlessly. These are some of the progress projects. And of course, the architect wanted to enhance the performance of the building by incorporating shading devices, which are then connected to this cold bent facade panels without having any problems on fatigue and so on. Coming to mode of fabrication, mode of contractual agreement, we heard Rajan speak about design and build project. One of the projects which you see here on this particular screen is the Dubai Uptown Tower. It's on the same model of design and build, where the main contractor took on the responsibility of fabricating the panels and installing as well. So early engaging with Technal, we were able to define the details for the facade system, and the product was tested for 3.5 kPa, 600 Pascal air and water, both static and dynamic. And because of the close engagement and partnership with all the stakeholders of the project, you can see the progress of the tower is simply fantastic. As the slabs are going up, the facade is catching up. And this is actually realized by the client in terms of payback, because he's already starting to get back his money faster than waiting for the structure to complete and then the panel to be erected. A lot of time is saved, a lot of quality is also under control. Coming to our experience and our working methodology in India, we bring all this expertise from Middle East and try to use this in one of the recent projects, which is the Ascendas International Tech Park in Karadi in Pune. The architect was very particular about incorporating detailed shading fins in order to enhance the thermal performance and to reduce the heat gains of the building. The facade consultant on this project was RSM, and together with the metal builder Glazium, they worked on different strategies of how to work on the supply chain of this element, because these are 500 mm deep fins, extruded solid aluminum fins. So once the supply chain was sorted, then Technal had to be involved on how to integrate these huge deep fins onto the facade panels. So we went with a female-female European unitized system, which is punctually hosted onto the facade without disturbing the integrity of the system. All these systems are with connect connections, so it's very easy to fabricate, very fast to assemble and to install at site. The wind pressure on the facade was 1.5 kPa, but later we were also told that this 1.5 kPa was also need to apply on the lateral road for the fins as well. So that means we had to make sure these connection points are seamless. And at the same time, the architect did not want to see ugly screws visible on these kind of fixations, because they are exactly quite evidently visible from inside the building. So we went with concealed fixations to help define these kind of fixations onto the facade. The project was tested, and in the first go, it passed. And the air tightness requirement was 300 Pascal, and the infiltration rate was about 112 meter cube per hour. And we achieved 19 meter cube per hour. Extremely high performance, and this helps directly on the cooling loads of the project because of the high air tightness, very low air infiltration rates. 600 Pascal water, and plus minus 10 mm seismic movements. The stakeholders involved in the project from Capital Land to DSP and LNW extremely happy with the progress. More than 20,000 square meters of facade already supplied and getting installed, and there's another package of 20,000 square meters underway by Glacium Facades, and the same stakeholder team is involved in that as well. Talking about performance in terms of cost, we also saw Rajan talking about customization of material, customization of system sizes. Mass customization is a unique way of helping to bring the cost down. In this particular project, Mashe Softi, the architect, he wanted to go for trapezoidal windows. And to have an operable trapezoidal windows is quite challenging, but because of a previous experience working on such similar systems, we were able to offer him this particular product. And because it was mass customized, we were able to replicate this in multiple floors without having any impact on new development of dies or new procurement of accessories. Faster fabrication and higher quality also has a less impact on the program. This is a project in Bhopal, a Tier 2, Tier 3 city, where we are discussing about 11,000 square meters of facade. The architect initially decided to go with the stick curtain wall system, but when we were able to bring a valuable option as a unitized system, and here again, Gautam spoke about material optimization. If you're able to get a better quality, faster production and installation, why go with the stick curtain wall system with all your external access and bonding at site, where you can do all of this at your factory, at your convenience. So 65 mm by 120 is a very nice module to have, and this can easily replicate or replace stick curtain wall system in the future. So we as Technal have developed various modules to help improve the construction fraternity to adopt to unitized systems rather than depend on stick curtain wall systems. So this is a 65 mm by 140. So when you have a wind pressure requirement of, let's say, 2 kPa, and the movements are about plus minus 6.5 mm, the 65 by 140 works fantastic. So if you have a project which has about G plus 8, G plus 7, again, why go for a stick curtain wall system when you can get savings on cost, savings on time with this kind of a smart, economic, unitized system. This is Max Square Noida, where the wind pressure requirement was about 2.4 kPa. So then we went with the 65 by 160. So we retain the same modules of unitized facade. Just by adapting the depth of the mullion, you're able to kind of tailor fit into different kinds of project typologies and project requirements, whilst maintaining the quality, whilst maintaining the speed of construction and faster turnaround time for your clients to move in to encash from the asset. Flexibility in design is also quite important when you have multiple elements of cladding and external decorative elements coming in. This is the IICC Center in New Delhi. Again, the time was of essence. They wanted to build something very fast. They wanted to be adaptable to various other cladding components. We used here our male-female system, 90 by 180. We were able to achieve the time constraints of the particular project. Talking about thermally efficient facade systems, this is the Atal Bhavan project. It's India's second government net positive building. And here they wanted to go for a thermally efficient facade product. And since the movement and the requirements were quite less, we didn't have to go with the 90 mm module, but go with the 75 mm module, more cost effective, thermally broken because we had polyamide edges, glass holders all around, which helped them to achieve the U value which they required. And such a small building which have traditionally been built on stick curtain wall system can now be built on unitized system with the same cost aspiration benefits which you can get from a normal stick curtain wall system, at the same time getting the better quality output. This is the Viettel headquarters in Vietnam. It's a LEED Gold building using Technal unitized system with Brise Soleil. I'm not going to talk more about this project because Anupama is going to talk about this. I won't steal your thunder, ma'am. But again, a great example of how even a small low-rise project can be highly efficient in terms of performance. Coming to my last topic, how do we future-proof your business with technology? We all understand that urbanization is happening. By 2050, we expect more than 7 out of 10 people living in urban city centers, which means the city fabric is going to go high-rise, is going to go tall. But as buildings go tall, the performance requirements of these buildings is also going to become higher and higher and higher. Take Bombay, for example. The kind of performances required may be 2.5 to 3 kPa, 600 Pascal water. Traditionally, your outlook is to go for a lift and slide system, which could be quite expensive. But Technal, we have launched a very new system called the Performance 70, which is a standard inline system with a very nice 35 mm slim module, but you're able to achieve 3 kPa design wind pressure, 4.5 kPa ultimate wind pressure, 600 Pascal water tightness, and 300 Pascal air. Perfect fit, perfect product for Mumbai skylines with a very aggressive price point. So we're able to push the barriers in terms of performance without having a lot of impact on cost. If one thing the pandemic has taught us is to have our connection to outdoors, and that is important, a feature which a building should offer you today. I was reading one of the advertisements by one of the big developers here is that a window can add acres to your room. So quite a nice ad which they put in. And that's what we try to do with our new launch product, which is the Lumial GA Minimalist product, which can offer very slim sightlines of 27 mm only. Unlike the other minimal slim sliders in the market, here we have tested this to the maximum 390 Pascal water, 300 Pascal in air, and 3 kPa wind pressure and 4.5 ultimate wind pressure. All of them tested as per the ASTM standards. But most importantly, the product offers extremely clean connections all around, completely concealed in all the 4 sides. And as you can see, it's completely flush from indoor to outdoor, so giving you that connection of space from inside to outside. The product today is available locally in the market, and you're able to achieve up to 3 meters in height and 2 meters in width per panel. You can take up to 200 kgs of glass weight per sash. Also available in multiple configurations. You have 2-shutter, 3-shutter, 4-shutter, and even 5-shutter. So you can go up to 10-meter clear opening with this kind of products by integrating pocket walls. So you can actually take the sliders all the way inside, giving you really large panoramic openings and giving you that connection to the outdoor space. The last and the most important topic, future-proofing for me, is sustainability. As Hydro, we are committed to reduce our carbon footprint by 30% by 2030. That's about 4 million tons of CO2 committed reduction by our group as Hydro, which equals to about 1.2 million cars' annual emission of CO2. But we can't do this just by optimizing our process. So to help in this process, we have developed a very new alloy called Sercal, which I want to introduce you today.
Have you noticed? The climate is changing. The environment is changing. Public opinion is changing. And so politicians are changing their opinions, and laws and regulations are changing as well. In short, the world's becoming greener. This represents an opportunity for your business. You see, in order for the world to become greener, we need a lot of new materials. Materials that can be used over and over. Lighter and more durable materials. Greener materials that you can provide to your customers, which we know they are willing to pay more for. So, if your business is becoming greener, there's a high chance that you should use aluminium. Aluminium is part of a sustainable future. But there's a hitch. Not all aluminium is the same. Chinese aluminium has on average a carbon footprint of up to 20 kilograms of CO2. Even the average aluminium around the world has a fairly high footprint. Our aluminium is different. With our greener aluminium brands, Reduxa and Sercal, we keep on pushing the boundaries for low carbon aluminium. Let's take a closer look at what makes our greener aluminium special. Hydro Reduxa is our product range of certified low-carbon aluminium with a maximum carbon footprint of 4 kilograms of CO2. Through the use of renewable energy and modern technology, we can produce cleaner aluminium than ever before. Hydro Circal, on the other hand, is made of recycled consumer scrap. Using recycled aluminium drastically reduces waste, saves natural resources, and decreases the need for virgin material, and ultimately, CO2 emissions. A lot. So whether your business is making cars, buildings, electronics, packaging, scaffolding, bikes, or a million other aluminium applications, our greener brands, Circal and Reduxa, can support you on your way to a greener future and help your business adapt to this changing world. Become future-proof today. Use Hydro, Circal and Reduxa.
So today, as architects, you have the opportunity to have lesser impact on the facade by using post-consumer recycled content. This is an oil company's headquarters in Kuwait, and we heard Jayesh earlier talking about having that commitment, the social responsibility. As an oil company, they decided their facade is going to use low-carbon aluminum, and they've used the low-carbon aluminum here for the windows, doors, and facade, therefore saving about 756 tons of CO2. You need one olive tree to live 80 years to offset 1 ton of CO2. So you imagine the amount of contribution you as stakeholders can do by using certified post-consumer recycled content. And today, Technal is able to offer their windows, doors, and facades from India with Circal. So that brings a close to my presentation. As these numerous amount of projects are getting shown, we have tried to use all our principles, our ethos, our thought processes of having high-performance facades on our projects. And we strongly believe that together, interaction with you as stakeholders, we can further improve our product portfolio, which are the need of the hour for this market, and also work together to improve the carbon footprint of this country and become the most sustainable and energy efficient construction industry in this part of the world. So with that, I thank you very much for the opportunity. And if you have any questions, please feel free to reach out to my colleague Guru and me. We are available here today, and we have a nice booth to have an interaction. Thank you very much.
Thank you. Thank you, Arvind. You are 4 minutes, 45 seconds over. Your invoice will be generated shortly. Just a quick question. On the Hamad project, you said that you use coal bend instead of regular extruded dies. Did it add much to the timeline of the project? Because coal bend is not the quickest of ways to install a facade.
So technically speaking, it was the first few rounds which took time, but once you got the proof of concept ready, it was a much more easier process.
Would it be faster than what you would have if you were extruding?
It is extruded normally. Okay. It is a straight profile, but it is bent post-extrusion. So the process is the same, but as you mentioned, the first few trials of coal bending takes time, but once you have the proof of concept ready, it's easy, smooth going.
All right, thank you. Thanks, Arvind, once more. And with that, we'll move on to architecture again, and it's my great pleasure to call on stage Anupama Sharma, who's the Managing Director of Gensler India, and she will talk on designing environmentally responsive and smart facades. Two of the case studies, one which Arvind briefly showed you all, which is the Vital Headquarters building in Hanoi, Vietnam, and the Alembic office building in Bangalore. So two very interesting case studies coming up. And it's called Sustainable Facades. That works as well.
Okay. Good afternoon, everyone. Pleasure to be here. Arvind, that was an amazing presentation. I think I will hit you up on a couple of questions after my presentation, perhaps. Aluminum is supposed to be a material that has the highest embodied carbon footprint in its manufacture and the entire life cycle. So I'm really interested to know what the details of the process is that you're following. Also interesting to know that you were involved with our Vietel project. So any questions on that, I'm going to redirect all the facade questions to you. Perfect. Okay, so with that, get started. I'm going to talk a little bit about Gensler and Gensler's take on sustainability. and then we'll get into our, the project case studies that I have for today's presentation. So Gensler is amongst the front forerunners in sustainable design thought leadership. And we embrace environmental stewardship on all of our projects and design efforts. We were involved in the very first LEED pilot project back in 1998, and this was the Armstrong World Headquarters. And since then, we have delivered more than 1,400 LEED certified projects the world over and counting. Our 2019 portfolio, for example, was designed to save over 16 million metric tons of carbon dioxide emissions and perform 42% better than average. And outlined here is our vision for 2030. At the 2019 UN Climate Action Summit, we challenged the industry to reach net zero. We made a commitment that within a decade, we will eliminate all net emissions associated with our work. We take this commitment seriously and have been working passionately towards that goal. Our 2019 buildings portfolio has delivered energy savings equivalent to powering 1.9 million homes for an entire year. So as part of our sustainable strategy, we provide turnkey solutions from strategy and planning to implementation. Our integrated sustainability delivery model provides complete sustainable design, LEED strategy, LEED documentation for existing buildings, new construction, commercial interiors, and neighborhood development. And Gensler's unique portfolio optimization, along with our expert consulting service, with that expertise, we bring together the information and solutions that our projects need and our clients require. And the end result is really better utilization of both owned and leased space, operating cost savings, stronger sustainability messaging, and improved employee productivity. So cutting costs is always important, as we all know, and really drives innovation, and driving innovation leverages cost. So our optimization analysis helps deliver a customized sustainability action plan with the highest return on investment. And the typical result is reduced operating expenses, increased asset value, heightened brand positioning, and increased occupant comfort. So coming on to facades. So facades, as we all know, is the outer skin of a building. Facades being the outer envelope of buildings, Facades being the outer envelope of buildings are very much like the skin on our bodies. They need to breathe, they need to be watertight, they need to insulate, they need to enable daylight penetration, they need to mitigate pollution and glare, and so on. In today's context, climate change, sustainability, and wellness are some of the key parameters that drive design decisions. And in this context, materiality and selection of appropriate facade systems becomes extremely important. So showcased here on the slide is our project in Pittsburgh. It's called the PNC Plaza. This is an 800,000 square foot building in Pittsburgh, and it incorporates the development of a complex, breathable facade and integration of a solar chimney. So this allows the building to operate in a passive, natural ventilation mode more than 40% of the time. The exterior facade here includes operable windows that open automatically, thus allowing outside air into the tower, and creating a thermal buffer between the exterior and the interior walls. And the solar chimney, which is really a vertical shaft leading to a rooftop solar connection panel system, creates an updraft that draws cool outside air through the building skin, up and across each floor, and then out of the building. So with this breathable facade and solar chimney, the building can ventilate 100% of the workspaces for 40% of the year without expending any fan energy. And this is a sort of a successful project example where we have actually innovated the facade system to incorporate natural ventilation. And interestingly, this was done in the United States, where there's a lot of phobia about outside air being polluted air, et cetera, and a heavy reliance on mechanical systems. So as architects and proponents of facade systems, we would like to strongly advocate that we keep our pulse on relevant technologies and processes that take us closer to systems that are environmentally sustainable in the long run. They have a minimal carbon footprint, and also look at ways to address some of the key challenges faced by the construction industry today, especially the facade industry in terms of quality, scheduling, fabrication, and installation. And with that said, I will be presenting 2 project case studies today. The first is the Alembic City project at Whitefield in Bangalore, and the second is the Viettel headquarters building in Hanoi. So starting with the Alembic City project. So this building is in White Plains, Bangalore. It's on Hope Farm Road. And that's the project site. The project has 2 metro stations adjoining it. And the metro connectivity enables additional FSI, as we all know, and also low carbon footprint with less pressure on parking. So the advantage is really the reduced car parking mandate, which comes down to about 75 square meters per car, as opposed to the typical 50. And the overall master plan, this is just a schematic depiction. The overall master plan was developed by a master planner based out of Europe, Mr. Shyam Khandekar. And this includes a central green, as shown on the sketch, with 6 office buildings overlooking the green, and with vehicular and pedestrian systems, bicycle paths, etc., worked out on the site. And Gensler's scope for this project was really 1 building, and this is the building highlighted in the star right on the top of the master plan. It was a single building in single-phase construction at 8,000 square feet superstructure area, and the total height of 65 meters. The total parking count for this was 1,300 cars, and we had 3 basements to accommodate the same. So the sketch here is really depicting the ground floor, again, very, very schematic. The ground floor was proposed in 2 sections, the east, which is a retail and cafe, and the west section, which has the lobby, the core, the gym, and some back-of-house areas. And a central opening between the 2, really allowing the connect to the central park and the central green, which was part of the master plan in the back. So this building really brought up the front of the master plan and was supposed to create sort of a gateway to the overall master plan. And that's a view of the site, an aerial view. This is more of a ground view. And then coming to the massing. So the massing diagram that's depicted in the center of the slide is really the one that was finally adopted for the project. The lower 2 floors here depict the lobby areas in the amenities, the sketch that I had just spoken to, with an opening in the center, again allowing for that green access connect to the back. And this is followed by the lower stack, which is the volume you see at the bottom, the 6 levels at the bottom. There's an intermediate floor that comes at the top of this with a terrace garden, and then an upper stack, which is the setback areas forming the upper levels of the building, for a total of 12 floors. And this is what the building was proposed as. Finally, this was what the client liked and what he selected for the project. And shown here are the different floor plans. Again, the ground floor showing the lobby amenity areas with the central opening, the lower stack floors, which is the bottom left, the intermediate floor with the terrace garden, and then the upper stack, which is a reduced footprint forming the remaining 12 floors of the building. And these are the grids that we experimented with, 9 by 13, 11 by 11, and 11 by 13. And finally, settle on the 11 by 11. This gave us, I think it was the most efficient, not only in terms of internal layout, but also in terms of the parking layout. So the total number of parkings that were possible were 8 cars versus 6 in the 9 by 13. And the 11 by 13 was not adopted because it was not efficient at the upper levels. And this is a view of the entry, so the lobby level, ground floor entry into the building. That's a view of the interior lobby. So we had white marble on the walls of the lobby. We had granite on the floor, and then copper on the ceiling, underside of the ceiling on the inside. And a little bit on the facade typology. So the facade used on the project is a unitized curtain wall system. It has Z-shaped louvers at the terrace, frameless glass railings, and unitized glazing with fins at the ground floor. The facade also utilizes equitone terracotta panels, extruded anodized aluminum mullion and frames, and laminated and treated teak wood exterior ceilings, which is what we see on the underside, where we see the Alembic City written on the underside of the ceiling. And we had white aluminum horizontal panels as well on the facade. So the horizontal bands on the facade is white aluminum. And the glass used here as part of the DGU system, so it is a DGU, is low E clear tempered glass with a U value of 1.6 watt per meter square Kelvin. And the building is a pre-certified LEED Gold for core and shell. And this is just a little more detail showing the south facade. So this, on the south and west facades, we made use of the terracotta panels to maintain the 60-40 ratio, so the solid to glass ratio. We use horizontal bands to cast shadow and high-performance insulated DGU to reduce the UV solar heat gain on the interior. And the solid panels also work as operable panels to allow for natural ventilation. So the equitone terracotta panels are actually openable panels, and they allow in natural fresh air into the building interiors as well. And in addition, we had these windows at each floor that are spaced 10 meters apart. And the openings are in the form of operable panels at a height of about 1.2 to 1.5 meters from the floor. And of course, for fire safety, continuous smoke seal flashing is provided at each floor. And that's the west facade, so very similar, same building vocabulary and detailing. And that's just showing the equitone panel on the top part of the section and the DGU glass at the bottom. And that's the building. So this building is currently under construction and is pre-certified LEED Gold. Okay. Moving on to the next case study. So the next one is the Vietel headquarters. This is the headquarters building for Vietel in Vietnam, in Hanoi. So Vietel has a new home in Hanoi. It has taken the opportunity to create a progressive, sensitive, and sustainable working environment for its employees. The headquarters of Vietnam's largest telecom provider is presented as a sloping disc-like building that rises gently from the ground. So the total levels here are 8 with the rooftop. The total height is 36 meters, and the total built-up area is 23,710 square meters for this project. So this slide really talks about the massing strategy that revolved around defining an overall theme for the project that was unique, that fit well within the site constraints, and made a statement within the city fabric of Hanoi as the headquarters for Vietel. So step one was really defining the building outline, and we settled for a circular building outline. Step two was about placemaking. So, creating an inner event plaza. Step three was really defining the building mass, and we settled at 8 floors plus roof. Step 4 was giving it the push. So lowering one side of the building to create the sloping disc effect and to gain maximum lake exposure. So there was a lake right in front of the building. So to gain maximum lake exposure, the maximum slope being 21.8 degrees and the minimum being 13.8 degrees. Step 5 was about access, so creating a cross-access link, cutting through the building, through the center of the building, as well as cutting through the center of that plaza that was created for placemaking. Step 6 was about terracing, so creating outdoor terraces facing the lake. Step 7 was giving a lift to the project, enhancing the public spaces and the interconnectivity between the inner and outside outdoor landscape areas. And step 8 was really then landscaping the building, enhancing the building's physical presence with well thought out and user-friendly landscape. So how do spaces become places? More than an exploration in form, the Vietel building really pushes forward the ideals of open and collaborative working and environmental responsibility. The building was designed inside out through a rigorous process that paid attention to the user experience. Open floor plates over 8 floors are interconnected through a network of lifts and stairs and escalators that encourage chance meetings and spontaneous interactions amongst colleagues. So this is a very important theme that Gensler is really trying to push forward in all of its workplace environments, where we want to encourage collaboration, we want to encourage spontaneity, meetings, etc., because we really believe that that leads to a lot of collaborative working and innovative ideas sort of coming forth versus people working in silos in their on their floors in their cubicles. So we are trying to create open floor space in the offices to really encourage interaction, atriums and open staircases, etc. So we're really high on that and pushing that through all of our designs. And coming back to this, the headquarters' distinctive green roof really is an extension of the adjacent lake and the park and brings to life a multi-pronged approach to environmental sustainability. So the entire project was sort of draped in green to make it environmentally sustainable. And beyond lowering the cooling load and impacting the microclimate positively, the roof also forms an integral part of the rainwater harvesting system. So it's not just bringing down the cooling load, it's not just creating green space and an extension of the lake ecosystem, but also part of a rainwater harvesting system. And in a soft landscape replacement strategy, Gensler adopted a sensitive approach by adopting native plants and species in the landscape to create a more resilient ecosystem. And then creating a vibrant communal space. So the design strategy really revolved around creating vibrant communal spaces and a vibrant public realm, looking at every opportunity the building and the landscape offers to create meaningful communal space, be it the front landscape plaza, so the area in green in front of the building, which defines the approach to the building, or the enclosed outdoor event space and arena, which is in the center, the open air amphitheater. There's one shown up north in green, that's the open air amphitheater, or the terrace gardens, which is shown in the bottom right image again, the different terrace gardens that were created to create overall a vibrant communal space. And then a healthy work environment. So the open floor plates also were tuned to an ideal depth to allow daylight penetration into all the working areas of the building. And in addition to the floor depth being kept to a minimal to maximize daylight, skylights were also provided in the green roof overhead to draw natural light into some of the shared spaces and the wing areas of the building. So with the help of all of this natural lighting, we were able to substantially reduce the use of artificial lighting in the project, and closely integrated the landscape external areas with the interiors to really create a healthy workplace environment. That's just a view of the interiors of the building, some of the public areas showing the impact of the natural daylight coming in. and another view through the atrium of the building, showing how the skylights are bringing in light into the interiors of the building. So really lighting up the space and activating the interiors. And facades, of course, Arvind can speak to this in much more detail than I. But facade typology here, again, is essentially an aluminum curtain wall system, unitized. And the system comprises of an exterior panel and an inner panel. Now, naturally, with all of this glass on the building and the skylights, there was a lot of daylight that was coming in. And with daylight coming in is the side effect of heat and glare also coming inside the building. So to mitigate the heat and glare, we adopted a system of horizontal louvers on the building facade. And these louvers were proposed as tightly packed striations on the facade, and they not only helped mitigate the heat and glare coming in, but also formed part of the building aesthetic, defining the outside of the facade as horizontal striations to really take away from the sort of monotonous glass facade look that otherwise the building would have carried. And the glass used was also part of a DGU system, low E, clear tempered glass. So creating a resilient headquarters using biophilic urbanism, Vietel building makes a strong statement about its commitment to collaboration and employee well-being. It is an example of sustainability and urban biodiversity in the city of Hanoi. And as part of a green resilience strategy for the building, we adopted the following approach. One was giving the building a green ring. So you see on the inside, there's a continuous green ring, which is essentially the green roof, contiguous green roof on the building. A green cascade, which is the image to the second image, which shows the green cascading terraces that were adopted as part of the green strategy for the building. And then a green foundation. So the entire building itself sits on a green foundation, which was the lush landscape that was created as an extension of the lake ecosystem as well, and sort of defines the approach into the building. And then the planting and biodiversity strategy was really focused on creating thematic gardens, bioswales, wetland areas to attract birds and butterflies. So overall, well-balanced, biodiverse approach. And then the water management strategy, which closely integrated with the landscape and the green roof, was the rainwater harvesting and water management strategy. We had clearly defined catchment areas, rain gardens and swales connected to rainwater harvesting tanks, and this was supported with a pumping and filtration system to really complete the entire loop there for water management on the site. So this is LEED Gold certified building, and we were able to get 62 out of the 110 points for LEED Gold certification. So for energy and atmosphere, we got 18 out of 33. For integrated design, 1 out of 1. Water efficiency was 10 out of 11. Location and transportation was 11 out of 16. Sustainable sites was 5 out of 10. Materials, 3 out of 13. Indoor air quality, 6 out of 16. And for innovation, we got pretty high points. We got 4 on 6, which is really unusual. But yeah, certainly, clearly it's an innovative project. And then regional priority, 4 out of 4. And I think this is my last slide. So that is really the project. It's been highly acclaimed in the media and the news. It's been a successful project. And I don't know if Arvind would like to add a few words on the facade, some more details on the facade. If you'd like to share, Arvind, that'll be great. Okay. Right. Yeah, okay. The brise solaire is what he's saying is the one thing I didn't touch on, but he did, so yes. All right, so that is it, and I think that's the end of my presentation. This slide should actually say thank you, it doesn't, so I'll stop on this one. Thanks. 'Cause 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 '
Thank you, Anupama. I don't know if anyone has any question for her. Okay, I think you want to settle fast. All right, so we'll move forward. Very, very interesting case studies, by the way. I have to commend you for that. And we'll move on to the first panel discussion for the day. And to moderate this, I would like to call upon K.R. Suresh, who's probably one of the most experienced moderators of panel discussion. He's been doing this for several years. Where are you, Suresh? Oh, come, you can come on stage. The topic is very interesting. It's influence of design in the performance of building envelopes. How can design impact the parameters for performance of a modern facade? What are the benefits of considering passive design strategies, strategizing sustainable design through local material procurement, and what is net zero carbon, and can this global trend be implemented in India? So taking the whole, I would say, theme of this morning in terms of sustainability and what can designers, builders, material suppliers do to enable a building to be more sustainable than what it was set out to be. I would like to, you want me to call the panelists? I would like to call on the panelists on stage one by one. First, we'll start with Vaishali Solanki, and I think an applause would do just to encourage them, who's the design director at Hiten Sethi Architects and Partners. Another architect, Apurva Sharma, from Architect Hafiz Contractor. Rishikesh H, who's the principal architect at Architect Rishikesh. Amar Tendulkar, who's the chief of design and sustainability at Mahindra Life Spaces. I think you can just occupy the spaces. Yashodhan Tere, who's the head of design and chief architect at the Wadhwa Group. And to complete the mix, we have a facade consultant, Upendra Valinchkar, the founder and CEO of Aluvision Facade. How are you? So I'll leave this in Suresh's good hands now.
Thank you. Luckily, I have a chair also to talk as a moderator. So, friends, today, you know, what we are talking of is basically not about just performance. We are talking about, after all this sequence of lectures and, you know, good buildings and ideas and all that, we're just coming up with two developers here. One is Amar and one is Yashodhan. They're going to be developers. And we have three architects who are designing for these developers. And you have a facade consultant who's going to help in the process of making the building more perform and make the building LEED certified and all that stuff. So first is, what we're trying to do is we're trying to form two strategies. One strategy is a developer having a good team of consultants and also a good team of facade contractors and, you know, all the other material suppliers. Everybody is excellent. But what is happening is the value engineering is done after the tender. Like what we discussed in the morning, there were a lot of processes which everybody came up with, but this is one strategy, and the second strategy is going to be, you have the best consultants, you have the best contractor, but the value engineering is done before the tender. Only two strategies. So we have only two developers here, so I can't have more strategies other than this. So now, and we have three architects who are going to basically talk about support them or go against them. Architects. And Upen is the common goal. He can do whatever he wants. He can jump anywhere as a facade consultant. So there's no problem. Okay, so let us just start this process and then we just continue, and we have an audience also supporting the whole, you know, the theme. So as a developer, you know, how do you consider performance? What do you look at in performance of a building? When the architect designs it, what is the brief you give them? So anybody can answer that. And you can take up any strategy.
Hello.
What is the strategy you're taking, Yashodhan?
Hello. Am I audible? Yeah, hi. Thanks, Suresh. So, I think we all know facade is an integral part of the building, and that's the first thing what you see. It's a first glance, it's the iconic structure when you see it's a facade which strikes you.
Right.
The second most important thing that it is an interface between the outside and the inside. So whatever we're going to conceive is immediately going to impact the living conditions inside. So most of us, we've been talking about inside-out planning. So it's a very critical aspect. When you're talking about the performance, I think we all are moving towards the fact that the buildings have to be more energy conscious. That we have to consume the energy and ensure that the design takes care of a lot of strategies on the passive side, rather than getting engaged on the active design strategies. So it is very important that the building which is getting conceived is going to perform well and eventually affect and benefit the end user, which is going to be inside. So you're talking about the design brief. I think it starts with the fact that we need to understand for whom we are building. It's very important that the designs are client-centric, and it's conceived with the fact that it's taking care of all the environmental aspects. Just to take this point a little forward, that when do a facade consultant need to be on board, because that's always a kind of a dilemma.
Right.
I think the way the design progresses with the help of the design architect and the other key consultants, facade is something which can't be think in isolation. It can't be taken or initiated at a later stage. It has to happen on day one. Because when you're conceiving a facade, there are a lot of environmental aspects and climatological aspects you take into account. But you can't have a facade consultant at the end of the schematic design, where the design architect has already kind of locked the orientation of the building, has kind of concluded on the floor plate. Then what is the contribution of a consultant, a facade consultant on the orientation?
Right.
Also, at times, the project gives an opportunity to create a cluster of buildings, which the architect, with the help of the facade consultant, can nicely orient the building. The interior spaces, the courtyards can be created, which effectively improvises the passive design conditions. So I think that's as far as the pre-construction stage of the project. You talked about value engineering. I have a question that why the value engineering need to be done once the solution is there on board. It has to be as a part of the design process. The idea here is we need to be more comprehensive in creating a design. So the key consultants have to be participating in the design process, and the design has to evolve so that it becomes a reinforced design. And then at a later stage, when you're bringing the contractor on board, then the other nitty-gritties can be looked into.
Right. So you become the developer who basically takes care of design and performance and budget before the tender is floated. That's what
Absolutely, absolutely.
So Amar can be the devil then. Cost cutting.
Yeah. No, but I'll put a little different aspect to what you have said. I'll give you a couple of examples of my previous projects. One, there is a project in Mahindra that we are doing, Luminaire. It's one of the tallest building in the Gurgaon, about 150 meters tall. And the another project in my previous company, which I did, is Omkar 1973 Worli, and another is, these two are the residential project, tall residential buildings, and Rishikesh has done Samit Business Bay for us, which is again in Andheri. And fortunately, Keshwani is here, who has done 1973, and Kamlesh is here, who has done, along with Rishikesh, the Samit Business Bay. So I want to tell you, it's architect's dream, which he wants to present into the facade. Whatever we plan, the dream which comes true, it's into the facade. The 3D is what we see. So architects want to show off, what he can do, what he can add to the skyline, how he can present his dream, how he can make the impression on the society, through its facade. But what's most important again is who is going to use that facade. So in most of the tall buildings world over, high-rise buildings, you will not see the balconies. You will not see the kind of terraces which are coming. There are very few terraces, whether you go to New York, whether you go to Chicago. Now 1973, Altamonte or our Luminaire building, which is in Gurgaon, these are the residential buildings. And the difference between the commercial building and the residential building, this commercial building has got, certain limited kind of users. They use the facade. Who are those? Those are the maintenance staff, those are the office going professionals, of certain age group and certain class of the education. So there is a kind of a way that they can treat that facade, open the facade, again the kind of internal environment which is a kind of a control environment. Whereas in a residential facade, particularly in this tall building, and when we do the decks, there are multiple aspects that we play. Who are our clients? Who are our people? Those they are going to use the facades. They start from the kids. They are the housemates. They are the senior citizens or the senior people. Those they live in the homes. They are the housewives and the kind of a master of the home. So these facades have to cater to all these classes in a kind of a seamless, friendly way. So that is another main aspect which is very important from the developer's perspective, that how do we make these facades seamlessly friendly, maintenance friendly, user friendly, and again in the cost, after considering all these things. And then you have got the challenges when you have again got the facades which have got the balconies. And then in the high-rise building, that how do you do the balconies? Again, when in the top class building that you look at the facades which are transparent, the glass balconies, because yesterday's world of doing the concrete parapets have gone. So there are multiple aspects of facade that come into the picture as the developer. Then when we have to satisfy ultimately the customer, architect, and again the maintenance guys.
Right. But do you face the challenges of budget in these cases? Like, what Yashodham was saying is, you freeze the budget before you float the tender, so that you have a
So the business case, so I'll tell you, the business studies are always done at the inception of the project. Right. And then there are certain kind of, I can say, the certain sacks or the certain brackets of the budget that we put for, this will go into the construction cost. Out of the construction cost, this will go into the facade. And it depends on the premiumness of the project, that the quality of the facade has been kind of designed. I mean, the building which Anupama had shown, it has got the kind of brise soleil. So I mean, and we all know the example of the Shanghai Finance Center. When the facade itself has kind of recovered the cost of the entire building over 8 years. So again, it depends on whether the building is for the captive use or if there is building for the sale. When the building is for the captive use, I mean, you can do the high performance facade and then you can recover the cost of the overall building itself in about kind of a decade's time or something. When it's the building is for the sale, the different business case has been kind of but ultimately it's been kept in mind who is your client, at what price the building is going to sell, where the brand image of the company we have to take. So these are the three parameters which are very important. And yes, we are in a business, so ultimately the cost counts.
So Rishikesh, do you get the same brief from the developer?
See, when we start the designing of any project, performance of any element is a bioproduct. Performance of any element is a bioproduct. So the creative aspect has to be, only when our creative aspect goes into the whole designing, then it is also governed by the local rules, then the sale perspective. The builder will have his own thought process. If I do this, I may not be able to sell this. There are so many things. You are part of my couple of projects, correct? You see how the reactions are there from the builders with the current pandemic, Right. There are so many things are there. It is not just one thing. Everybody wants the look to be good, but you have to pay for it.
True. So you need to keep the budget, that's what you're saying. And you need to recover the cost based on the design.
Yes, yes. And if you are able to do a good facade with a minimal cost, then that is a very good thing for the builder. We are talking about builder kind of projects now. Right. Because we are sitting with two builders, right. Correct? This is not a a corporate park or something like an Apple building or any other right. Infosys or something like that, where the right. budget is not a constraint. Here we have got per square feet. The whole costing of the facade is done on per square feet. True. From the day one, the talk is like that. How much are you going to spend on my facade?
Right.
Then what can an architect do? In this one, you have to give a beautiful facade with features that are there, that are maintenance. They don't want the maintenance to go to the society. Then everything comes into picture. There are very practical aspects that we need to see.
So So there are a lot of things which you need to consider before you even start.
Yeah, there are a lot of projects what we are doing in Pali Hill, Bandra and all that for very big builders. They are selling the flats at around 50 crores and all that. But then when we try to put even granite also on the facade, then there's a big discussion happen, whether do you want to do it, you know, dry cladding, whether do you want to do it. Yeah, there are multiple things per cost. Then there are so many things that we need to see before we give any kind of, you know, completion of the whole facade and give it to the BOQ person or give it to the facade consultant. That is the whole thing.
Right. So Apurva, what do you think about this? Is it the same criteria which a client gives you?
So I would say there are about 3 types of clients. One is the typical builder.
So you added one now.
Yeah, so the usual builders, and they are right at their own part, wherein they are looking at the ROI and what's kind of selling and what's not. But I think the second category would be the same developers building corporate parks for MNCs who have the requirement of a sustainable building, wherein they're doing it maybe not by choice, but it's required for the business to run.
Right.
And the third category would be people who are very, very conscious of what they're building. So the third is the most rare and the most cherished clientele, I would say. But like you said, not everyone is Infosys or Manipal or, you know, clients like that who are very, very conscious of what they're building.
True.
But having said that, being architects, I think it's our responsibility to bring that paradigm shift in the regular developers also, right? So, like Yashodhan mentioned, that it need not be a very, very expensive solution. But I think with the way we plan the facade and the, you know, let's say the shading elements, or let's say the orientation of the building, or, you know, designing the facade based on the orientation, let's say kind of having a difference in the north, south, east, west facades, we could do that. But I think the mindset has to change that, you know, if you're adding shading elements, it's going to be expensive, or you're going to, you know, so I think we all have to educate ourselves and do that little bit extra. I think that's only going to help us create a sustainable future.
You mean before you give the concept to the client, you need to be conscious of your budget in terms of...
Yes.
So do you need any support? Do you check with the contractors, or do you check with the consultants, or how do you get that?
So again, you know, for the only for the high-rise buildings is when we have a facade consultant. The regular 30-storied buildings, 35-storied buildings, most of the times do not have a facade consultant. And like you rightly said, I think it's extremely important to have not just facade consultant, but the contractor at the right point in time, because otherwise, like someone mentioned, I think in the previous presentation, that it doesn't become value engineering. It actually becomes diluting the specs. It becomes diluting the design. It's not value engineering anymore.
Because you already marketed the project.
Exactly, exactly. Thank God for ERA. Otherwise, you know, you would show something and then build something else.
He's got a point for you.
One thing I want to add.
I want to speak up. Okay, we'll tell Vaishali to speak about...
Yeah, sure.
Yeah, Vaishali.
I can just start with a phrase that well begin always wins half the battle. So, you know, instead of like starting just for the sales point and go ahead and, you know, so rather we do a complete study as architects. Like there is a nice awareness which is developed in general. So even when we start any project, our project is with all the passive, you know, architecture in our head, where we take, you know, it's not only the location or the shading devices or everything, we take care of all the aspects and then we present it to the client. So the client automatically is very much in, you know, sync with the whole flow, and then that's the way we take it ahead, you know. Like,
is that the case?
And we, globally, everybody is going towards, you know, this. So there is a huge awareness, and I think we all architects are being very responsible towards the whole thing.
So I mean, I just want to say two things. As a client, as a builder, you know, we always say, all our consultants, that whatever you save, you know, that is the fees that we pay to the consultants. That's the first thing. But second very important thing is there is a phrase which says that, it's how we convince the client to spend more money. And that is very important. So I mean, you or Rishikesh, Rishikesh says, no, client ka hamesha constraint rehta hai, ye cost cut karo, wo cost cut karo. I'm telling you about the philosophy, or, when I work as
they work on per square feet.
We work on per square feet. In India, in Mumbai, we will work on per square inch also. No, but jokes apart, I am saying that when I work as all my, whether it's my MD, whether it's my marketing team, they are all my internal client. And how do we convince our, boss, ये facade कर दो, ये window लगा दो, ये glass लगा दो, आपको rate 2,000 रुपया square feet ज़्यादा मिलेगा. And that is the way I think your boss also convinces, no? So that's what all we have to learn. Ultimately what we want to do, we have to be confident about it, and we have to say confidently, yes, this is the thing that we want to do, this is the thing that we want to deliver, and this is what will add the value to the entire building. And as a developer, you can add, value to your customer, then the customer will pay more. If we are successful in doing that, yes, we can deliver something which is a quality product.
I just want to correct if I'm wrong. So in general also, all our projects are going, there are some market standards which are, we have to follow. So there are some regulations which we follow, which automatically make our building move towards, and also an demand, like a market demand for LEED certifications or any other accelerators like Griha, or, there are certain mandates which we generally follow to achieve, so the cost is already been so why do we take it back and then, I think we move towards these regulations and the market demands, and we do the structures as per that.
Corporates also are doing this because of the LEED certificate and all. They are forced to do it.
So you're saying that if LEED was not there, Griha was not there,
1000%.
it would have been a different building altogether.
Very few of them will have really done it. See, I've seen what Anupama ji has, done the presentation. All these things are done by force, correct? We are getting into now EV kind of vehicles now, electrical, because the petrol and diesel prices are going up. Nobody is going to, do it by will.
But then you need a charging station for that. That is the problem.
No, but jokes apart, but unless you are forced to. See, right now we are doing corporate parks in Trivandrum and in South India, where we see that the LEED certificate dominates the whole thing. Why? Why are we doing LEED certificates? Is there something that corporate is getting back?
But then you get from the client a premium because of that.
Yes, exactly. Only when you are forced to, then you do it.
So it is not a conscious decision to get into more...
no, not all. Not all.
Into our conscious. It is automatically developed in our conscious where we start our project.
See, we are very, our clientele is not like, Norman Foster or Gensler or something like that. Let's be practical. Our clientele is, very good builders who are making projects of more than 15 crores per flat and all that. They want to give a good product. At the same time, they are conscious about maintenance. They are conscious about the building should stand for 30 years, 40 years and all that. See, people have used ACP. Now aluminum they are coming to. Correct. There is a change.
So there's a
shift, change.
Basically.
There's a shift. That is what is needed. And price. People were earlier conscious about putting aluminum, putting ACP also. Now because of fire and so many things, we are coming to aluminum. Now people don't put ACP. That is what is going to be there.
But is it changing the whole, architectural intent also?
100%.
Are you all changing the way you're designing?
Yes, very much. Okay. Very much.
The way we take it, it's right from the onset of the project. From the beginning, we are working towards it. So
see,
earlier what presentations we would give, and the way the approach of the design is totally changed.
See, we have got many projects where he will share with me, facades and all where we are making for one of his projects, where the balconies were also determined by the marketing people, where we should put the balcony, where, you get the good price. These are all so many elements, whether, the other kind of architects, MNCs that are there, whether they come to know about this kind of things, I have got my doubt.
So it's a sale point, basically.
Sale point of view. That's a practical approach.
Right. So I want to mention something here, Suresh. So we are seeing that, the design, the discussion is revolving around the fact that, see, the business is governed by a ticket size.
Right.
You know, I mean, that's what the whole thing is all about. So to reinforce the point which I made in the initial part of the speech, that why the consultant needs to be on board. Apurva mentioned about the specs getting diluted over the time.
Right.
See, what happens that the design progresses through concept to SD to DD and, you know, different stages.
Right.
And the cost which is considered at the beginning, the facade cost, is basis some rule of thumb if the consultant is not there on board. See, there has to be something schematic at a concept, at an idea level, which has to be there on the paper to consider that rule of thumb. Because then what happens, in midway of the project, the core and shell is already built, so where are you going to cut the corners?
Right.
You know, it's the areas like lighting design, areas like landscape, areas like facade which gets the hit. True. So if you have the right expertise on day one, see, Mr. Ramar talked about the client. You got to know whom you are building. That in a way is going to define the specifications. Having said that, the building has to perform. There is no two ways about it. But it is extremely important to put that right number at the beginning so that there is not much deviation. And at the later end of the project, when we start talking about CTC, the cost to complete,
right,
that shouldn't go haywire. If that goes haywire, then there is a trouble. Then you talk about, you know, she also mentioned about shading devices getting cut. But if the shading device is going to bring tangible benefits into the energy consumption, then why not?
So you're saying it should not be an aesthetic benefit, it should be a tangible benefit in terms of the performance of that sunshade, whatever you're doing.
Certainly, because
so it should be,
see, you are creating an element. See, these elements are also used by the design architect to articulate the building.
Right.
So there is science also behind it.
Right.
You know, we've been working closely on our project,
right,
and we're taking care of all the surrounding aspects. And you know, in that linear facade, you don't have shading devices across the length.
True.
We're picking up certain spots basis the analysis which has been done.
True.
So that is how, you know, even you treat the facades differently. From a human eye level, more
that
than
builds up the
facades,
performance.
you're not going to see it in one go.
True.
So change the facades. As you know, try and use different specs. Right. That's how you'll be able to come at a right figure. And then there'll be a lesser debate on cost cutting, and you know, we'll be at the right number.
That becomes a benchmark.
It becomes a benchmark, yeah.
Upendra, what do you say about it? Are you involved initially?
Yes. Generally, few projects we get involved, and few projects we came a bit late. As many panelists has put their point, so there are one point I would like to add is awareness. We are running because awareness is less. So that awareness will make the people understand what is the importance of adding these shades, sunshades, or the using a high performance glasses,
right,
or a right product. What is longevity of the product? Many projects we had seen the inferior materials has been used just to cut down the cost. And after say 5 to 10 years, they are replacing. That is the huge cost they are paying after 4 or 5 years. But that initial thought is missing. Why anybody is putting so many...
So do you think the cost cutting, it's because of a cost cutting which is done after the contract is awarded or before?
No, before, during the process also many times.
So you keep on cutting the material spec.
Yeah, material specs. Like this pandemic situation, many projects we came across, people are trying to, you know, say, array, this situation, material prices are rise up, so we'll. So
right,
I would say rather than overall keeping the intent as a aesthetic, so more importance has been given to aesthetic than the performance of the facade. Many times it's lacking that what is the performance or the glass, performance glass add value to the project, and what are the tangible benefits we are getting over a period of time.
Right.
And there is a little, this is my feeling as a consultant, there is a bias attitude. When there is a corporate, as rightly said, there is a regulation, so we follow.
Right.
If there is not corporate, I'm not going to use it, so why I should spend money? But
So as a consultant, is building the performance of the facade, is it to do with only energy or is it to do with maintenance also?
Yeah, it's
Are you looking at both ways?
Overall, like it's energy saving, it's maintenance free, it's user friendly, as has been discussed. So
right,
it should perform as a sustainable thing. So,
right. So to all the architects, how do you choose a material? I'm just saying, it's a statement where I'm saying that, if the material is going to perform over the next 30 years, there's no problem at all for the client. But if that material doesn't perform in the next 3 years, that means you have a problem. As a developer, I'm saying, I'm not talking to the developers now, I'm just talking to the architects. How do you choose a material?
Definitely the first criteria is the look. Look has to be
good. As an architect, right.
Look has to be good. First thing.
Okay.
Second thing, I'd prefer a local material. Yeah, like, granite and all that. That makes the building combo of, making a fusion of both the things.
Right.
And then terracotta and all that kind of things work. But at the same time, the patience has to be there from the client side also. You got it? That's little bit, we need to work on, we need to educate them just to, use these materials and all that. That's the challenge. Once that is done, then most of the things are done. But somehow I think, when we are doing for big premium projects, that comes very easily because you have got very good,
cash.
Yeah, very good, yeah. That's exactly what you said. Okay. That's very important. The look is primary.
No, so for you, look is primary, but then your team is there who can help you with other things. See, as an architect, I understand. You have an image in mind. As a developer, they want to sell it for a price. And as a consultant fraternity, all the consultant and the contractor needs to make it happen. The way you want it.
See, consider the material I have used Korean also on the facade. I have used GRC, FRP and all that. Sometimes, sometimes if they fail, if the company what we choose fails, then we have a problem.
No, but that is something which is to do with the cost-cutting part. The value engineering part where you appoint a contractor who is basically maybe a labor contractor who installs for you.
Now, if you see GRC also, sometimes, when you use the full facade on GRC, you get cracks on top of it.
That's a quality control.
No, but the blame comes on the architect also.
Why should it come on the architect? Your concept is approved.
Yeah, no.
Client has liked your concept.
Like choosing the material where you said, where the material, like GRC is used many places, correct, on the facade and all.
Right.
But many times, the execution or whatever, there are multiple reasons of it. If it goes wrong anywhere, then the question comes definitely.
No, but I feel that architects should not be blamed for that, first of all. It's a consultant's, if they've done anything wrong in the design or a contractor.
I think anything goes wrong, even if I appoint a facade, if he does wrong, then the blame comes to architect only.
No,
I've not come across. I think, most of us will agree on that, all architects, correct? We all appoint,
so we need to change the way you think then.
There are many projects. See, I'll tell you, without naming the client, I'm doing one 250 meters tower in Hyderabad, where all the big, I've got Sterling and the best, MEP consultant.
Right.
If the drawings are not delivered, they will not ask him because they are appointed under us.
Then you have taken the responsibility.
Yeah,
so then you have to be blamed.
No, it is like, for a facade material also, indirectly you are taking the responsibility.
Right.
You got it. The responsibility is there.
The point is no consultant can debate with an architect for the material.
Yeah, but when you are, the client leave it to the architect. Okay, wherever you put the finger, we'll go with that. But sometimes when choosing the material, if the company that we choose, consider there are 10 companies for any material, that company fails, then we fail.
So then you have a consultant who gives you the spec for that.
Yeah, I agree. Like, there are, plus and minus.
So
we all have to take equal blame.
I would say, I would say that the clients are pretty, I would say it is our responsibility, and I would say while aesthetics are important, the technical specification is even more important, and to be educated and to research on the material is even more important before proposing something. So if the client is kind of questioning why the GRC failed, I am sure there would have been some lacuna in the facade. Could be detailing and execution, but I would say it could be even the properties of the material, because at a lot of times what happens is we are liking something and we are saying that it could be done in a particular way. But till the time you do not know the properties of the material, you do not get into the depth of the detailing,
right,
any material will fail.
So that's the reason you have a consultant who will propose that. See, what I'm saying is if you have a consultant on board beforehand, during the massing stage, where you're doing the massing, your budget gets cleared initially, and your details get cleared initially, and your material gets cleared initially. And you have options for it.
So there is one more thing also which plays very important. It's a, it's a material where you are going to apply. The material, let's say, whether it's a GRC or whether it's any external paneling or any internal material as well. I mean, you apply to the building which is 10-story and you apply to the building which is 70-story. The person who is applying that material, the labor who is applying that material, has also to be trained how to apply that material. Otherwise, that material is going to get failed.
True.
And when we do this 250 meters building, there are training programs which happen for those laborers to work at that height and how to apply that material. So it's not only about the material, it's about, understanding the properties, application, and again selecting the right contractor who has that capacity to do that, deliver kind of a
and the understanding,
project. Understanding and deliver that kind of a project.
Doesn't have control.
Obviously, you should not have control because you have a consultant for that.
No, Rishikesh, there somewhere I'm not saying disagree, but somewhere, we have to be vocal, saying that whether you are doing it right or whether you are not doing it right, and then we should say that it's not right to do that.
No, plus I feel is, when you're doing something different, you need to have a research also on that. Like the contractor should be good enough to understand the product, rather than a client appointing a contractor and saying, kar do. Ye udhar ho gaya, to idhar bhi kar lo. So that is something which
most
happens.
of the time I have seen that how much faith of the client that as an architect you have won. So, it's then upon us, as an architect, whether it's an internal architect or external architect or an external consultant. Right. So that's the most important thing.
I'll give you an example of one renovation. We were doing a headquarters of one of the largest leading corporates of the country. And they cherished the headquarters. We'd done it many, many years ago, and they wanted to refurbish the facade. Okay. And it was a travertine facade. And
in Worli, I believe.
Haji?
I said in Worli, I believe.
Worli. And the promoter wanted to replicate the exact same facade. Right? And it was an old structure. So it could not take the fresh new load of a dry clad new travertine with that particular thickness.
Okay.
So there went in a lot of research and detailing, wherein what we came up with was a sandwich travertine panel, like travertine panel with aluminum honeycombing. So a lot of times there'll have to be an innovative solution, and that will only come when you have an in-depth knowledge of the material, and at the same time you're wanting to create the look you want. So, I don't think structural strength, weight, all that, or even cost should not come in the way. I think we'll have to find a solution to make it.
It's an approach which you need to
take.
Suresh, when we're talking about use of materials on the facade, I personally feel that the building needs to be more sensitive towards the climate. Every material has a different tendency to behave in a particular manner. So that is one aspect. So, whether we are suggesting GRC on the facade, whether we are suggesting expanded metal sheets on the facade, I think we need to understand that how they're going to react to the building. We've been using form liners, and we have one of the developers who have used directly 5 years back. AHC was the architect on the job. So it's something we believe that facade needs to have a treatment which is inherent. You should try and, of course, image is definitely something which every developer is sensitive about.
True.
But having said that, are you creating something which is going to be really difficult for the client to maintain in the long run, especially in residential buildings, where once the buildings are commissioned, we are out of the project.
True.
So generally the CAM, the common area maintenance, is it going to be a white elephant for them? Or, you have options like directly as a product. So, you use a form liner and you just need to paint it over the years. Or, you have wonderful patterns. So it's just one product per se. But of course, there would be many such examples would be there.
Right.
You're creating podium level car parks with, so much of intricate mesh. How it's going to react over the months? It's going to get cluttered with all this dust on it. Is it going to maintain regularly? Right. So I think we need to be a little more sensitive on that aspect, while definitely ensuring how the material will behave technically within the Indian context. I think that's equally important.
And region-wide.
Because you mentioned about the maintenance as one of the aspects of the performance.
True.
In addition to the energy,
Because I believe that it's not only the performance of that material. That can be done during the design stage. After that, what?
Exactly.
You need to think
what
of
after that?
afterwards.
You know, how one is going to maintain that.
Right.
You know, it's something which is very important.
Right. Because Kamlesh is going to have the next session where he's going to talk of that. So I think we're just
Dust
getting
is
the
a-
context to that.
Dust is a primary thing what we face, as a problem. You do any building or anything, you've got a dust that plays a very important role in deciding. See, you give niches, you give anything. The first thing the internal architect of the, company or the client itself, they always come up with this kind of, "Arey, iske upar dhool baith jayega."
Right.
You got it. This is what is there, the maintenance point of view
Right.
is very, very important for residential projects. We are not talking of commercial one. Commercial one, okay, sometimes they do maintenance or most of the buildings are not that maintained. What we are talking of, not the BKC ones, the other ones, they are not that maintained.
But that's also money.
Yeah, exactly.
End of the day. Vaishali?
Exactly. So the facade, the dust in Indian climate is very, very critical to handle it.
The pollution and...
The pollution, yeah, it sits on it.
True.
Yeah.
And moisture.
Moisture.
Yeah.
If you don't maintain, then you have to spend little more.
Yeah.
True, as architects, we have restrictions to use parametric shapes and all over here because
Right.
of the core reason being the dust settlements.
I think actually it's the sale model which matters a lot. As sir was mentioning, you have a building in BKC, we are going to hold that building. We have a capacity to maintain it.
Right.
But if you are talking of a building where gentry is like 300, 500,000 square feet of offices, it's an outright, it's a sale model for us. So you need to ensure that you're inducing elements and even the cleaning mechanism in such a way that it's easily getting operated by the condominium which is going to form later on. Otherwise, it's a big mismatch. It's a big mismatch otherwise.
No, see, very rarely out of 100 projects, one project you can do it of a BKC kind of scale.
True.
See, we are doing almost around 20 projects in any, at any point of time for commercial or more than that.
Right.
But where does, the maintenance and all that kind of criteria doesn't come. We are making 100 square meters per office, 200 square meters per office. They sell at a very,
not a premium rate.
3 or 4 crores. So let's be practical about it. Maintenance and all, they will not put all that kind of gondolas and all that. They'll hire it some person, they'll come yearly once or twice and do that.
Right.
See, I totally believe in being a very practical approach because see, we are hardcore commercial architects. So we know what the client is asking for.
But are you getting the brief initially? Or it is just changing over the time? Before the building is complete, it becomes small offices and, different...
See, we are doing a premium building where you are also part of it in Bandra,
Right.
where we are selling at 55,000 rupees per square feet.
Right.
Correct? So there, okay, we are forcing the client and he's getting money for the facade. He's getting money for the look. Yeah, he spends. It's like give and take. It's give and take. Nobody will do it from his pocket.
Right.
Only the corporates. Yeah, see, it's nobody's money.
True.
Correct. When it comes to individuals, they will count the money.
Yeah.
At the same point, if we are not thought of regular maintenance or at the design stage, how we are going to maintain that, how we are going to replace the glass or...
You mean provision. Already you need to give the provision.
All that needs to be thought of. And I would say a building where we know, okay, if it is a small office or a small building and that facade treatment should be thought of that keeping thought in mind that it is not going to be maintained. So the material selection should be like that. If you see Bombay Skyline, many of the buildings look so shabby. Say initial few years it will look beautiful.
Right.
But after that it will look like a shit.
So right choice of materials and right detailing.
Choice of, yeah. That is very much important, I feel, considering this.
True. And as architects, how does passive design strategies, how do you implement it in your design? Do you...
So we, right from the inception, from the beginning only, we do all those analysis and shadow analysis and everything. And so from the study, we come to know where our elevation facade should have what material to be used and all. In that, there are some areas where aesthetics rule, where we want to take the massing with something which we don't want to, then we use shading devices and even plantations and a lot of aspects which we count in. Like one of our projects which we are doing right now in Panvel Municipal Corporation, where there's a complete glass structure, but we have created a nice skin over it, which is reducing the complete solar radiation inside. Also, even inside, there are compact spaces. Being Mumbai, there are certain schools or whatever which we are working on, they're very compact, So how do we derive the natural ventilations, and internally how do we create courtyards? All that actually, frankly, it help us designing it much better, because understanding the basic parameters of designing it really helps us having a more improvised design rather.
So do you keep a constant check on it in terms of, how efficient the building is over time? Like is there something which is for the developers? Do you keep a constant check on the performance of the building?
See, when you're talking about passive design, the easiest way to achieve a passive design is cross ventilation.
Right.
Now, if I may say so, that the architects face a bit of a challenge from the developer while creating opportunities to induce passive design. I'll give an example. Suppose if you're creating a floor plate of smaller offices, it's generally a doubly loaded corridor, and your offices sticking next to each other, maybe with a core in the center, fire escape stick is on the either end.
Right.
Now, the obvious way to bring the air inside is like you'll have to spread two offices and create an opening. There's always numbers on which we work. FSI to RERA carpet. There are efficiency index which have to be met, because that derives your bottom line of the project. So within a floor plate, it's difficult for them to create, avenues for the air to move around. Otherwise, how are you going to bring down the, ambient temperature? Especially if you have opportunities where there's a complex of 3-4 towers, that actually helps them,
then
because it creates courtyards and things like that.
Right.
Compared to commercial building, I personally feel residential building definitely gives more opportunities to create cross-ventilation avenues, because you actually start from micro to micro kind of a design. You come from out to in, floor plate to apartment, and then in each apartment, especially we at our group, we emphasis on the cross-ventilation aspect.
Right.
Because, in Indian context, you keep your windows open.
Right.
So that is, I think, a very, very important aspect. But in commercial, it does get a bit challenging because of the numbers which we enforce upon them, that you have to be in that range.
Right.
So
you're saying residential is easier to maintain rather than commercial?
To create passive design, yeah.
Yeah, I think, Suresh, we all spoke about, the maintenance-friendly facade and whatnot, in terms of. But I think now the time has come that we do not look at only about the maintenance or the sustainability. We are looking, the next generation is going to look towards the facade which performs, facade which generates the energy, facade which is biophilic, facade which is sustainable.
Right.
So I am seeing some projects in the world which are going, where the facade has been used to generate the energies, in the morning time facade, kind of puts the energy in the battery bank, and in the evening the facade restores that energy into. So I think the time has changed, and we all have to go towards that change. Now even the cars are going towards, whether the car's entire envelope can generate its own energy and can run.
True.
So I think we are still talking about the times where, how do we maintain the facade, what are the things that, but I think now we should look towards the new materials, new technologies, and we should look the buildings which can be future-proof, and the facade is the kind of means to, because facade, we all say the floor plate is X. Facade generally for the normal building is about 7X, 8X kind of a things. So if that 8X can generate the energy for the building, we all have seen that how the PV cells, solar panels, all those things can be, in a different technology-wise can wrap around the facade and the building. So I think we have to look at the facade in a very different way at this stage, rather than just looking at, the problem-solving kind of a scenario, that what we can give it for the next generation.
So you're saying as a developer, you'll invest that money in terms of new technologies. That's what you're
Definitely.
So you
because
can recover
that
it
is
at a
what,
later
see,
stage.
that is what we are going to leave for the next generation. As he has said, if you are going to put the eyesores, in the, or the kind of a skyline which are not maintenance friendly, and then after a few years they look kind of a, dirty, ugly kind of a, pencils which look.
Right.
So I am doing something not good for the next generation. I think I want my building as an architect, to kind of a sustainable, what I have given to the next generation. Tomorrow my children, my grandchildren, next generation should say, see, this is the building that has been delivered by this architect or this developer, and this is adding the value to the entire society or the community. I think that should be our aim at this stage.
This says it really. So globally, if you see, maximum countries have declared a year to go, net zero. So I think India is progressing, and we are moving very close to that.
That is the approach we need to take. I think the alarm is rung. I think we can have the audience ask questions to any of the panelists. To the developer or the architect or the facade consultant, anybody. Any questions? Yeah.
Hi, I'm an architect, and the question that I always face is, how do you convince a client which is very practical? I think, we heard that there are 3 types of clients, but I think there's only one type of client and different types of architects. This is what I think. Because, we provide a lot of glass on the facade, so we create a problem. Then we provide brise-soleil, so we add cost to find a solution. Then we need to somehow make it sustainable. So you add another bit of cost, and then you go to the client and say, hey, your building is certified, and you're going to get great number of points. So in Indian context, I think we need to educate our clients in order to sort of, have that approach which is sustainable. And that can probably help in longer run. And I would probably like, some of the views from the panelists as to what they think about it.
So architects, right?
Can I take this in a short way?
Yeah.
Wearing an architect's hat, when you go for a presentation and convince a client, there are 3 ways that we do the presentation and 3 answers that we expect from the client. Yes, no, and wow. And we have to aim for the 3rd one. That's the thing. And then if you get that the 3rd thing, that means the client is convinced.
And I think if you convince the client in terms of a data, I think that will help. And the benefits what they get in terms of branding. So I think that is what they get as a benefit. And as an architect, you sell it.
I'll also like to add that you rightly mentioned that there was an era when it was just glass-clad buildings, and owing to the climate condition that we are in, we have to have the louvers and extra shading elements, and then kind of increase the cost, and then justify why it is going to be, that's going to get them the LEED certification, and then hence let's increase the cost. But right now we are talking about an informed design, which is going to be, the facade design has a great potential. In terms of the percentage of solid to glass, in terms of the daylighting that comes in terms of what is the thermal comfort that we have. And I believe a lot of us have started working towards that. So it's not that we are creating a east-west oriented building wherein you've got glare all the time and then putting sunshades. So as long as the design is practical and kind of convinces someone, I think it will fly through, is what I would say.
Also, I feel...
Also if we have new softwares which are helping us to get that, give that data and explain our study to the client before approaching the elevation.
And you also have consultants
so
for
the
that.
BIM modeling and everything, they absolutely help us to convey the right, and give the right direction to the client, what we should.
But Suresh, I feel that, I'm here, it's me. So it's not the client who keeps just popping up in the presentation meetings. I think the client's team is equally engaged with the design architect, the entire team of consultants.
Yeah, it's a collaboration.
It's a collaborative effort to begin with. And also at times we try and push it to, see there is a research which happens even at the client's end. And we try and share those thoughts and inputs with our design architect, facade consultants. And then it's an informed decision which is taken. So it's not that, that there is a presentation, the client comes, say yes, no, or wow, and then it just goes back. But there is a process, and it's always better that client is being made part of this process to avoid surprises at the later stage. Sure. So there's always a track which happens, there's a reasoning which is checked, And then, yes, we know that, yes, we are heading on the right path.
Right.
So then I really don't see that in that
It's
case
a
there is
problem.
any issue.
And most difficult is when the client says, wow, but reduce the cost to half.
Just one thing I want to add to that question is that there are 3 types of architects, correct? They are not one type of architect, correct? One who the architect who gets the work on basis of municipal connections or getting the work done and all that, correct? The second is that there are who are good planners who are here. Third is that who do great facades. So we come in that category. When we show the facade, we get the money out of it because there are 100 brains and 100 investors are there who put their money into that. So they pick the architect. So the architects are not given the wow factor. What Amar has said is that it's not just on the basis of the glass what we put. They also get from their inner voice, wow, this work is good. Then only that work goes to the architect.
Great. I think we'll end the session now, and we'll have the.
Kamlesh has taken the mic. He wanted to ask something. Let's hear from
Very
him.
one question?
Very quick one to all the developers and so key stakeholders in any project, key stakeholders in anything that is being, so anything which is invested, so whether it is design, whether it is project. My question is, one is, you are experts in your field. Developers are good at making buildings, architects are good at design. Why do you all need to get into, when you have consultants, when you have architects, why do you get into that you should put 4 screws and 2 nut bolts? Why don't you leave it to the experts in the field? And how much role do you play in that? Because we see a lot of developers getting into it. As you know, we will buy the material, we will buy the glass, we will buy the screw, we will buy the sealant, we will buy everything. Why don't we do what we are good at?
It's a good question. It's a practical question.
That is a full panel discussion in itself.
Yeah.
So the silence.
No,
silence.
I have got a
quick answer maybe.
No, quick answer.
We can discuss during lunch.
No, I'll tell you. I'll give the answer in just one sentence. I think, Kamlesh, you need to wear the, developer shoes and, ask this question to yourself, that if you give the facade to someone else, would you give him everything turnkey or would you buy everything yourself?
It would be, I will leave it to the expert. If I have trusted an expert, I will leave it to the expert.
Yeah.
That's the answer.
The answer says the moment you get into all this, that means you don't trust.
No.
So you don't trust your architect, you don't trust yourself,
I am telling you,
you don't trust your consultant.
Next time you
so
do your
you need to
office,
trust,
Next time you do your corporate office,
I'm saying,
and leave the job entirely to the architect.
Amar, I'm saying that when you trust, when you put in so much of trust in the client, why don't you trust? Or why don't you choose the right partner? The question here is, the ending is, choose a right partner,
I fully agree.
This is what I am trying to tell.
No, I fully agree with you. So, you remember when we did 45 meters suspended glazing. That trust, with that trust, everything was done, the way the experts, Rajan is also here, you are also here, we have all changed our kind of probably the shoes now, but I think it was done kind of seamlessly, as complete trust has been put on the contractor, complete trust in put on the consultant and the architect, and it was a kind of a team which has delivered that kind of a job. But now what has happened with the kind of rules, regulations, export, all those things kind of changing. Client has started, let the expert do the job in which they are expert in. Your job as a fabricator or as a glazing kind of a company, it's not, your expertise is not in the importing the material. Your expertise is not in the kind of doing the trading or the kind of things which you are not manufacturing negotiations. The client is saying, let me handle that part. Let me provide you all that support and you do the job which you are in expert in. And do that, meticulously rather than putting your energies into the job you are not expert in. So that's where the things change. It's not that if you are saying you want to do the Hilti fastener, somebody will say, or the Fisher fastener, somebody will say, no, use the local material. But if that Hilti fastener you are not manufacturing, let client procure it.
Okay, I
So
hate
Kamlesh,
to be.
you need to talk about it in your panel discussion.
I hate to be Arnab Goswami here, but the nation wants to go for lunch, and we'll have to stop. Unfortunately, this was extremely interesting. Suresh, I don't know if you want to conclude, but we're out of time. Okay, we are out of time. I'm sorry about that, but really interesting panel discussion. Please give them all a big round of applause, all the panelists, and to Suresh for doing a wonderful job as always. Very interesting topic, very controversial topic, but yes, we'll need some conclusions on this. Hopefully in practice, then in theory.
Now, Kamlesh will do that in the next session.
All right. We will break for lunch. The only request is we do not have time, so I would request all of you to assemble back in 30 minutes. Just run out, otherwise you'll not get your plates. And 2:45 is when we will restart. Thank you. I'm sorry? Oh, lunch is served there. Lunch is towards the back, yes.
Imagination is a gift. It enables you to dream, to fly, to reach new places, anticipate what will happen. Those who spend their time imagining are the ones who change things. They create, they inspire.
there's a slight change in the schedule, so we will start with Arjun Malik first, who's the principal architect at Malik Architecture. It's a very interesting presentation on form follows life, the equilibrium of place, where he will review the fundamental interdependencies between nature and architecture, something that should be extremely interesting and invigorating to note. Can the rigor of placemaking extend to the development of the interface between architecture and the environment, and exploring strategies and materials that respond to habitats and building types? So I would like to call upon stage Arjun with a big round of applause. That intensity doesn't prove you've just had lunch. So over to you.
Thank you. This is the...
That's your controller.
Okay, is there a pointer as well?
Yes. Is there a pointer here?
No, it's not. I just switched something off, I think. Ah,
yeah.
That's right.
Cool.
Okay, fine. Let's go back there. Good afternoon. I appreciate the fact that you guys are still awake after lunch. It's great to be here. Thank you for inviting me. It's the first time in 2 years that I haven't been talking to a screen. It's really nice to be back in front of all of you. I think a lot of the discussions that revolve around the topic of the facade have, in a way, become disengaged from the core processes of architecture, right? And I just went to the dictionary because we know what a facade is, and I looked at the two primary definitions. And I think the one that we're more accustomed to is the first definition, right, which is the topic of conversation here. But I'm more interested in the second one because I think the way we've been treating this subject is almost completely disconnected from architecture, has pushed us more towards number two than, number one is maybe irrelevant at least to the conversation that I'm about to have with you guys right now. So if one was to first even take the word facade, and I'm very kind of particular about nomenclatures because you may say it's just about the meaning of a word, but if you're able to take the word facade, put it to the side and start to look at a more meaningful interpretation that could be an interface, that could be a threshold, right? You start to understand the interchange between the built environment and nature in very, very different ways. And perhaps you start to think about the way built environments interact with nature as not simply divided by a line which is inside and outside. And once you accept that facade design, and I use the word facade again, so forgive me for that, whilst it may be considered a separate design or engineering discipline, it ultimately falls under the umbrella, right, of architecture. Our mediation, right, the mediation of humanity with nature. And if we're looking at a symbiosis or a balance with this planet, there are, it's kind of a matrix we've put together. It's not conclusive, it's not deterministic, but if we start to look at the the social, the regional, the structural, the functional aspects of architecture, it fundamentally extends outwards to every component of architecture, irrespective of the collaborators who are part of the process. So what I'm going to do is run you through one or two small-scale works just to set a datum, right? And then see how we can take some of those ideas and expand them into taller buildings, larger projects. In trying to first and foremost ascertain that are these divides between different disciplines as clear as they're made out to be, or do they finally unify, right? This is a small project in Jaipur that we recently completed. It's not very large. It's about 10 or 12,000 square feet. It's a private residence for a friend. We know the climate of Jaipur, right? We know it's hot, it's dry, it gets cold in the winter, the sun can be quite extreme, right? Convection works, cross-ventilation works, verandas work, shading works, right? Is there a way to take all of the lessons that our traditional placemaking and architecture, which has been, it's an accumulated intelligence from centuries, to learn lessons and perhaps evolve techniques, right, that would allow us to coexist with the environment, because that's the fundamental basis. We're talking about thermal comfort, we're talking about glare control, we're talking about adequate natural lighting, we're talking about good views, right? And all of it can actually be accomplished without resorting to mechanical systems. If you simply consider that you have to design a project without electricity, which means no lighting, no pumps, no all the mechanical systems, no air conditioning, etc. How would you design a project? And then when you kind of, fall short of certain parameters, you can consider these as plugins. Perhaps it's a better way to look at things than simply saying, okay, I'm going to build a glass box, and I'm going to put a triple laminated glass, and now I'm going to pump in air conditioning. And essentially, you hand your project over completely to engineers, right? So working in Jaipur, we had one simple constraint. It's close to a village, it's close to a quarry. We have decades, centuries of experience, right, of craftspeople who work stone with their hands. The quarry is nearby, the materials available. Can we simply look at a project that uses fundamentally only one material? No frames, no infills, no multiple agencies on site. You simply build in blocks of stone, which means you go back to the quarry, you understand how stone is mined, you understand how stone can be split to retain its grains, and every single component of a basement plus 3-level house has fundamentally been designed in stone, right? And the strange thing is, because it's in Jaipur, it's actually cheaper than a concrete frame structure with brick infill, stone facing, internal plastering, internal paint, and everything from your cavity walls to your floor systems, which are either flat vaults or traditional vaults, or the compression openings or the steps, everything has been done in solid stone. And of course, when you get into stone and you truly understand the material, you understand how varied, how rich it can be in its expression. So here, structure and facade essentially become one, right? But the moment you get into a natural material, right, the intelligence and the rigor with which you approach a project has to change. That's only one of the walls. There are 8 such walls in the project where each stone has been mapped, laid out, and then installed, right? Even a stone piece, you know the size of a brick, but what is the size of a stone? You can get them in 16-foot lengths, you can get them in 1-foot lengths. It's determined by the number of people who can manage a piece of stone without any further mechanical assistance. And the way it responds to the sun. So we're talking about a traditional way of making, we're talking about a traditional material, we're talking about ways to engage with the environment, but with the right tools, with the right attitude, right, with the right hardware and the right engineering, you can suddenly start to give this material new life. So completely shaded patio systems with sliding folding stone screens, right, deep insulated walls, and you can actually see how those screens open up, right, to kind of mitigate. This is fundamental in India, right? We tend to live our life with cross ventilation and shade, so if you're able to protect from sun and rain and also, modulate the privacy conditions of a project, it can actually work quite well for the people living in there. I'm just going to run through some snippets of the house so we can start to get on to how we can perhaps take these ideas. You can see, first of all, there is no interior or exterior. They kind of start to blur into the other. So the kind of determined or finite face that separates what we would normally call conditioned environment from the exterior, those boundaries have completely been broken down. So you start to create levels of thermal comfort, not just with the insulation of the walls, but you start to create through courtyards, through verandas, through patios. So by the time you get to the interior, you can actually live here in the summer just maybe with a couple of windows open and a fan on. Yeah, you can look at them. We had the choice between water jet cutting and hand cutting, and it's a strange phenomena. Anywhere else in the world, the thought of hand cutting a screen would be so absurd and so expensive, right? But we aren't a fully industrialized technology yet, right? We are We're still a country that relies on craftspeople, on making by hand. So we can actually do these things at very economical costs, which is something that I believe from people all over the world would be, itching to get these opportunities. And we're trying to kind of run off into industrialized solutions and factory-made systems whilst we have all this sitting at our doorstep. And if we don't use it and we don't mobilize it, it's going to be lost very soon. And as far as we talk about aesthetics, we talk about ornamentation, we talk about iconic, right? If you simply respect the sun, it will take care of all your aesthetics. It will make magic if you just let the environment be, if you are sympathetic to it, right? I'm going to quickly jump over to something similar in a slightly more urban context. This is South Extension in Delhi, right? And what this diagram illustrates is, to the left, we have the slightly older urban condition. And this actually exists on either side of our site, where on the left you had a ground, one, and a barsati, right? The barsati was quite active to get your winter sun, to sleep out in the hot months, greater setbacks, gardens, etc., right? A way of, shall we say, establishing a certain sympathetic community environment. Now, on the right of our plot, we have the building form as prescribed by the new urban bylaws, which is stilts, more FSI, less setbacks, taller buildings, cut off the light, cut off the air, make all these things hang on to the street, right? Now, no client wants to sacrifice area. They want their FSI, they want their luxury. But I think if you begin to understand people, and in this case, we had a very sympathetic client, this wonderful lady. I don't know if she'll be happy me mentioning her name, but I will say it's Manali Singh. She was very closely connected with her environment, which means even in the earlier house, I'd often see her on a balcony talking to the person across the street. She genuinely believed in open living, whilst also wanting that kind of retreat into the, into your interior environment. So is it possible to kind of find a balance between the pre-existing and current urban archetypes, and also start to look at both a interior and a exterior way of living, right? I think one of the most difficult things here is that they prescribe that 8-foot or 9-foot stilt, where you have to deal with your cars, right? Now, it's the most absurd way of encountering what you would call a house or a bungalow. You have no garden, you have no volume, you have no light. By taking away less than 3% of the available FSI, we were able to scoop out spaces on the ground floor, which completely opened up the ground to the street, to the landscape, and then allowed these voids to actually cut through the house. In a way, this house becomes both a thermal and a social condenser in terms of the way it scoops into the basement, takes a courtyard up through, right, which becomes a thermal control device. The way the hot air rises becomes a kind of convection shaft. And yeah, that's how to the left is the street, and that's the back of the house, and that's how the street kind of flows through, goes into the basement. You start to modulate courtyards, buffer spaces, verandas, using some of the techniques you saw in the house in Rajasthan, right? And the kind of interspersing of solids and voids. And that's the way the guy kind of, floats over the ground. Certain parts of the public areas open up onto the street where they had very, very nice trees. In the corner, you can see again, you can completely manipulate the way this organism behaves, right, with beautifully crafted but very, very simple technology, right? You can control the light, you can control the privacy, you can control your views, and more importantly, there is no fixed image to the house. It constantly keeps mutating with the time of day and the kind of life that you're living inside it. And that's the ground floor area. It's got nice open 18-foot height, stretches into the basement. There's a kind of porosity here. So I think Delhi, they're more square yard people than square meter people. And this plot is about 500 square yards, and the Delhi guys are very much, oh, ye kitne square yard ka plot hai? And they keep coming in and saying, oh, it's a beautiful big plot. It must be at least, 1,000, 1,200 square yards. And they can't believe it's 500 because it's just a question of being able to open up that space. And this is why I said when you raise this word facade, I don't even know, where the facade is in this. I mean, some of them are just raw concrete structural walls. Some of them are sliding folding screens. Yes, I do admit that there is a Gwalior mint stone dry facing on the exterior of certain parts. But you can also understand how the project starts to turn into an organism, which, this is the south face, and you can see how slender fissures where the house starts to close off and, deep recesses or slender shafts of light, right? How you let light come in from the top. And yeah, this helps mitigate. I've always had that feeling that Delhi houses have this horrible kind of closed feel in the winter, and you get very, very nice sunlight. And that's how the individual bedroom balconies can actually be manipulated, opened up and closed, and the quality of light that comes into the space. So now we're going to basically question whether one can take, because my question would be that, okay, it's okay to have all this fun on a low-rise project, and there's no real wind speeds, and there's no great engineering, and you can meddle around with it. But what happens when you start to get into a dense urban environment like Bombay? And this is 19th Road. It's about a 10,000 square foot plot with its narrow face to the west overlooking the sea, right? And we've always talked about, I still think that Kanchenjunga is probably the finest, tall residential building that I've seen in India, and we've constantly been wondering, will we get the opportunity to start to work with something that really takes the idea of low-rise typologies of, connection to the ground and landscape and all the elements of passive design that we have fundamentally been trained for as architects, right? The sun, the rain. Can we actually extend this vertically into a taller structure? So it's not really high-rise, it's about, 60 meters tall. But again, the ability to let the street breathe, because our streets have been destroyed, the bungalows have been removed, the high-rises have come. Can we first let air, light, and landscape permeate the lower levels, and then can we find a way to carry it vertically into the building, right? It's divided into a few shared amenities. It's got a couple of single-level apartments, 2 3-level apartments, a single 2-level apartment, and then a multi-purpose space on top. So it's kind of a set of intertwined dwelling units, right, that really starts to respond to its environment. I think we're all familiar with what happens to all of these large glazed structures, especially the ones facing the west. So, you have these panoramic views, and you have these, they call them verandas or balconies, but they're 5 feet deep. So, come 2:30 in the afternoon, the blinds go down, the sun is streaming in, you can't control the heat, you can't use your balconies most of the time with high wind speeds, you can't shade yourself from the rain, right? So is there a system, right, where we can actually engage the building to be able to work indoor, outdoor, perennially? So we've worked between 2 and 3 meters on the west facade, right, is where these patios, multi-level balconies, etc., start to weave through the building, and they've been equipped with a set of fixed and sliding folding terracotta-colored aluminum screens. They haven't got the OC yet, so you can see the flexible parts still haven't been installed, only the fixed areas, but it creates a completely mutating west face, which people can control from the inside in a very similar way to what you saw on the 2 previous homes. And also structurally to be able to move the lines to start to get you skylight. So an apartment at the 3rd level would still have a skylight, which gives you the sense that you have the sky over your head and not this kind of set of pancakes crushing down on you. And the other thing it truly does, right, it's still not complete, so the multi-purpose space on top needs to get finished. The sliding folding screens need to get in there. But what this has done is it's surrounded by a bunch of buildings. It's right next to Rustomjee Paramount. And every residential building in the area is defined by these horizontal floor lines. So in a way, you can look at a building, and within 5 or 10 seconds, you suss the building out. You know all that it's about. It's got the typical glazing. It's got the floor bands. Some may have a couple of projecting louvers. But this actually engages you in a way that you can stare at this for a while and you start to wonder, right? You begin to wonder what its anatomy actually is. What is its purpose? What's happening inside, right? This is the north face, Now, these windows have been perfectly calibrated, right, as a projection of life and space on the interior. This is not an abstract compositional issue. The client said, let's put these gigantic windows, in the courtyard where you have 2 and 3 levels, and we resisted it. We put something large at the eye level, which give you all the light and the views that you want. You intersperse a few smaller ones where you're moving up certain spaces, you can get glimpses to the outside, a nice quality of light coming into the interior, right? And multiple layers of texture. We've always grown up, at least the previous generation, working with these Havelis. We are always used to nice thick walls which give you kind of shade, insulation, deep recessed windows. Now, we don't have that possibility in Bombay because you can't give up the FSI. So each window has a very slender, 1.5 foot aluminum extrusion. Now, as the light conditions change and you start to move around this building, there's a kind of optical illusion. You can't tell if it's a thick wall into which you've recessed or it's something that you very delicately, projected outside. So in a way, it's reflecting the mechanisms and strategies of low-rise architecture for the environment. Can I take 2 minutes more, or should I? Yeah? So I'm going to quickly run through some pictures. It's not yet complete. They've moved into the house, but I think another month or so it should be sorted out. So the ground level engages differently. The parts that disappear into the sky start to behave in a particular way. That's just rough quota, dry fixed. We're having some serious problems with that. My friend Suresh knows about it, so yeah, we're going to find a way. But now it's the interior space, right, that you start to sense the quality of light. It's interesting because the first discussions, and they're a very, very large Marwari family, and as expected, the first discussions on this project actually started with this hotel. It had just opened at the time they commissioned the project, and they said, look, we love the Marriott lobby, and we love the marbles and the veneers and all that other stuff that I don't really want to talk about, right? But today, when people come to their house, they are talking about the fact that they do not need to put a single blind down in their public areas because there is no glare. They don't have to switch a single light on until after sunset, right? They don't have to switch their ACs on until they decide to sleep at night because everything is cross-ventilated, shaded. Not just through the building construction, but the patios, the verandas, the in-between spaces, right? I've been there recently a couple of times, and it's always open with the fans on. There's a beautiful breeze flowing through, right? There's a wonderful poetry where some of the screening systems have also been taken into the interior to provide internal shading and privacy. And it becomes a very interesting exercise in being able to live in a way where you are still, you're connected to the cycles of the sun, you're connected to the cycles of the environment. You learn to live sympathetically with the environment. And these are the individual decks. They haven't got the sliding folding screens on, but you can shade yourself. You can sit there in the rain because you've got the screening system in there, right? A quick one, and then I'll wind up. A project in Andheri, part of a client's, a larger campus. This was an old industrial building which they wanted to retrofit and, bring in new tenants for offices. And they said, look, can we do something with this facade? And it's very, very constrained because they would not let you expand the windows. They would not let you break the walls to drop the windows down. They would not let you touch any of the horizontal or vertical part of the walls, right? So what we essentially did was we mapped the facade in a way that we could understand the 3 levels. And we simply inverted its anatomy, right, to be able to use the existing levels because you had no more than 75 or 100 mil outside the furthermost line to work with, right, to essentially create something quite, in a way, it's both heavy and light because it's worked with the translucent insulated polycarbonate. Using the window systems and the different levels, we've actually been able to scoop windows out and chamfer them. And we've simply changed the material on the base. We find this is something very effective because the way architecture, material, and light are perceived at the eye level and something that floats in the sky, right? It does create the possibilities of working with them differently, giving the sense of flotation. Yeah, you can see the transformation from what it was to what it currently is. Yeah, I think I'll stop there. Just to kind of sum it up, I think it's all about an attitude, right? We have to be careful about handing over the controls purely to engineers. I think it's an attitude, it's a way of thinking where you bring everyone into a process and you fundamentally recognize architecture at its basic fundamental purpose, right, of creating sympathetic habitats for people. Once you are aligned with that, you find a lot of these terms like iconic and it looks this way and it looks that way. If you deal with the context, if you deal with the core principles, the answers, I think, will present themselves through the correct process. Thank you.
Well, thank you so much, Arjun. Do you have any questions for him? Okay, I don't have a question, but I have to commend him for the almost poetic narrative of all the projects that this was beyond outstanding. I don't know if you all observed, but there was not a single piece of text in his presentation. It was all photographs, and the way he went about describing it, it was something really, really excellent. Thank you so much. And another comment is again, goes towards sustainability, but also the fact the first project in Jaipur that he showed, where there is so much of support being given to local communities and to use the products, be there, be topical, and just make sure that whatever is around you is probably some of the best things that you can get your hands on. It's just how you perceive it and how you use them. So thank you so much. We will move on to the next presentation for today. And I would like to call upon stage Ahmed Sumair, who is the director at Savia Facades. He's a veteran in facade engineering, and he knows his subject really well. I can vouch for that. He will talk on facade lighting, integration, and challenges. Thank you.
Hi, everyone. I think it's a wonderful gathering around maybe around 2 years. So I'm going to talk about the lighting, facade lighting, integration, and the importance of lighting design. So darkness flees with the light. I think I need a remote, no? Sorry. So darkness flees with the light, and the light is the life. To see any object in a universe, to visualize, everybody have a vision, but without light you can't visualize and experience the object properties physically, the colors in every aspect. And light also have its colors, which gives beautification, aesthetic views to every object. So here, let's talk architecture in the sign of light. So here is my topic. So we have three segments: importance of the facade architectural lighting, then integration, and what is the future business and challenges for integration, as well as respect to commercial and integration also. So here, importance of the lighting facade first. So civilization is always associated with lighting. When we go back and see in every segment also, like automobile, architectural, and other fields, light has played a key role for a safety, for a security, for enhancement of each and every element of architecture and different areas. So it's completely associated with the civilization. The earlier, the old transportation were with some mashal, some torch, light and all. So day by day it's increasing, and it's coming up with some signature lighting for each segment. If you see the automobile also, like every brand have their own unique lighting element attached to it. Here would like to share like a generic history about lighting. So in 300 BC, it was with the beeswax and some oil in China were supposed to use for a lighting. Then in 5000 BC, the fireflies used to capture in a jar for a lighting purpose. Then in 19th century, Sir Swan and Edison has invented bulb electricity, and they together form a company for mass production. Then in 19th century, the official LED research has been published. Then in 2000, you can see all over the globe, there are different elements in different sectors. The LED already incorporated and lighting has updated. Now this is I can say evolution in the lighting. So in the like a diya in first, then we have a bulb, then fluorescent lamps, and now in 21st century is a LED. So these are some examples to understand things. So now the nature also has taught the lighting moods to us, and there are different timing, due to the sun path. It makes people to learn, to act, to adopt the nature in architectural point of view. So when sunrise, people were calm and they can do, they relax. In the morning also, we'll start for walking here and there. Then in the afternoon, everybody is aggressive, and also these are the moods, these are the color, temperature, which also available in artificial lighting. So here are example like the warm lighting, the neutral, cool and cold temperature, and the angles to make them highlight, make them beautify, to make them enhance the particular feature. So let's back in a time when there is no artificial lighting, how architects and the designers utilize the sun path analysis to make their architecture in a beautiful form. So these are some examples like from 2500 BC, the Isfu temple, where the architecture has designed in such a way, the natural light has come inside, and it's a beautiful play with the punches, with the orientation of windows, placement and orientation of the building with the sun path analysis. So light was there that time also. The way of using, the way of enhancing the features, architectural features in a different way. So this is one more like Pantheon, the Roman architecture, where we have a circular opening in a dome, and with the planetary alignment, you will see the sunlight is walking in a theoretical theater in way. So there is a day, special day on 21st April, where you properly see one porch is illuminated with the sunlight. So light has been read and analyzed in a very detailed way when there is no artificial lighting. There are some more examples like with Notre Dame Le Corbusier building, where you can see some windows in a staggered form with the different sizes, with the different alignment, and Church of the Light, where the symbol of cross, and there is no artificial lighting, but you can see the interior is well illuminated with the natural light. Then in the modern architecture also, World of Institute of Arab in Paris, then there is one resort in Saudi Arabia also, where you can see the natural mountain they have carving in such a way, they are allowing a natural light to come inside, and there are some punches which is cladded with the modern glazing curtain wall and all. It's a dark, and they have the light one. So the natural light in a daytime, this is also like one kind of a lighting design without using artificial lighting. Then what happens to architecture at night falls? So there are some images like for urban lighting design. If you see in 1992 and 2009, so in 20 years, there is a like good amount of progress in urban lighting. So you can see this area, especially like 92 and 2009. So urban lighting is already a step ahead, and it's progressing in a very good form, where we have our general utilization and other services which we are enjoying in the light. Similarly, when it comes to the facade, if we see the major metro cities, still I can feel like we are in dark respect to the other countries. So let's see the high rises from the globally. If you see Shanghai, then there is a different lighting schemes, different patterns already executed, then Kuwait, Sydney, then Singapore also, and the New York. So this is the main reason, the importance, it's not only the beautification, it enhances the architectural features in the night, and it's a direct and indirect monetization also. So if it is a commercial and we have a beautiful lighting, then the footfall will increase, and there will be a signature for a particular location, particular building. It will be a landmark if we have a beautiful lighting in the night. So here I'm going to talk about our current projects we are doing. So it's a King Crown Infinity in Vietnam, then Mahavir Gateway in Hyderabad, Vensa again in Hyderabad, and we have one mixed-use development in Sunbay Crystal in Vietnam again. So the King Crown Infinity, it's a mixed-use development. We have a very high-end retail and the service apartment and hotel. So here we adopt our concept, the storyline is when night falls slowly, the intensity of lighting will increase. It will be, it is not too much sharp, it will be subtle and slowly go up. So here we have made some sketches in the concept stage for a client. So client, the brief what we got from the architect team and client is they want something unique. They want to come and stand out differently in the market, and they want to attract the more footfalls. As the Vietnam already has been executed such a wonderful project with the lighting design and the geometry as well. So they want something unique, they want some different ideas and interactive also. So this is what we have done. So it's completely a media facade, integrated transparent film in the glass, and the podium, the commercial also is integrated. The scheme has been integrated in the same way. When the lighting design intent and the illumination happen on the commercial area, the same intent, same story will go till the terrace. Then the different pattern, here one more thing I would like to add. How can I go back? Sorry. Yeah. So one more thing, for special occasions like a New Year and all, we come up with a drone show. You can see the world map, and also it's a completely drone concept, especially on New Year's, Chinese New Year's and all. Then here some different patterns, like there are a million of patterns we are going to present on a facade there. It is a completely programmed and connected with the BMS. And this, and one more thing, they want like how we are making interactive. So there is a kiosk in a commercial area. The Saturday, Friday, Saturday and Sunday, the people can block the schedule, they can come, they can enroll, and they can play what they want to see. So there are around like 250 design patterns we have already programmed, and they can see and they can enjoy their own lighting design, their own preference. So these are some concepts, and media panel where it can be generate the revenue also, and the entrance also they want something unique. Apart from the facade lighting, they want to have like a kinetic lighting. Then we come up with some different concept for them, like dupatta, how dupattas fly in the air and all. So we generated some renders with the balls, hanging balls, with the illuminated hanging balls. And then again, one more challenge come for us, like there is a wind pressure of 1.7 kPa, and it's completely open. And then how this very delicate and very slimmest cables and the lighting fixture is going to be sustained in terms of structural point of view. Then we have added one more complete glass box to save this. Then some interior landscape area we have done, which is going to complement to the facade lighting. So this is the second one, Mahavir Gateway. So this is a commercial, is a mixed-use development again, the office tower. Then we have 3 floors of retail, and we analyze. And this is near to the ORR from when you come from airport to the city. You can see this building from a distance around like 6-7 kilometers you can see. So they claim like a 50,000 eyes going to be see every day to this building. So these are 3 segments where the person who was walking nearby, so this podium they can easily visualize that we have the drive who are driving from airport to a city, then the neighbor and aeroplane view or neighbor high-rise towers also they can see. So it's a very subtle lighting. Then we have some uplighters for zinc cladding we are using in especially on those walls. And railing is illuminated with this area especially. So these are some more options, concept. Then for a facade also like 3-4 options we have done for them. So is every alternate floor we have linear LED bars. Then every floor on cladding panel we are grazing the horizontal band. And there are some architectural vertical staggered features which is we are highlighting with the linear bars, especially this area. So multiple design patterns staggeredly on, off, we are playing in that. We are fixing detail how we are integrating into facade and all. So these are projector mapping, especially for occasions like Diwali, New Year's, on festival too. There's one more in Vietnam we are doing is a mixed-use development, 3,000 keys hotel, then service apartment, and we have a huge casino. It's the first casino in Vietnam they are claiming. So we inspired from the Golden Dragon, and we try to come up some unique concept on a fascia completely like a golden sand and sparkling golden sand. And these are the fixture details like typical uplighter. Then we have multiple 100 of pixel lights installing on a facade to create this kind of patterns. This is other with the same fixtures, the intent is different. Some more concept. The rear side we have a very subtle lighting. Similarly to the same concept we have adopted in the landscape area also. Then Vensa again in Hyderabad we are doing. So it's a 3 blocks, the beautiful architecture, and the front facade is with the uplighters we do have. Then the vertical blade columns from the side we are illuminating with the hidden fixture. So there is the fin size around 500 to 600 projection approx, and we have integrated the LED bars into it, and there is no visibility from the outside. It's a completely concealed pattern. And in the side elevation, some drama we are playing with a different pattern. Then again the celebrations, all moods we are going to play here, Diwali and all. Whatever you want you can generate and play on a facade in a very subtle way. So interior renders. These are fixture details how we are mounting. Then here you can see some details like, so the lighting fixture is going to be concealed in the vertical fin element, and especially the uplighter, this is uplighter for a vertical blade column. So the every day is not going to be like a huge drama. The Friday, Saturday, weekends only we are going to play some kind of drama and all. So these are some more example how we are integrating. The challenge is how you are going to provide the power supply to each lighting fixture. Once you puncture the system, then there are chances of leakage and all. So that is also one big challenge, and simultaneously you have to do a beautiful lighting and all. So that we have already executed in a proper way. So this is for a landscape area like inspired from Athens. So we have a central core here which is going to the main temple. And similarly we came like, we have a 3 different terrace gardens where you can see the 6th floor terrace, then 17th floor, then sky garden. So this center one is behaving like a staircase, this area. So these are the renders, the conceptual renders for them. The linear bars on the floor, then grazer on the wall, and these are the vertical blade columns we are leading. This is what we have already done and executed. So it's a mixed-use development, is a G plus 27 story facade, multi-curve, and we have installed multiple dots, the pixel lights on a facade, which are making it's like a movie show where you can make heart, you can make any other patterns also, you can create faces on a facade. So this has already been executed, tested also. So here the client was thinking how we are going to integrate, because already contractors were on board and the panel installed around 30% of facade is already been installed. And again, for a post-construction, how we are integrate this pixel and all. So we did a lot of R&D, then we have done an on-site testing for a water and air leakage as well. And another challenge was to provide the power supply also. So successfully that we have done. And this is a dynamic belly curve, this area especially. So here they are running some kind of advertisement for anchors. So here the fixture details you can see. So for this dot, the fixture looks like in this form. So it's a 100 and different sizes are available in the market. And for the horizontal linears, we do have this integrated LED bar. This is one more project we have recently completed, the testing and commissioning in a progress. So it's completely a dynamic facade where all the vertical fins have pre-installed, pre-drilled, whatever provision has to be done, it's done in the factory only, and we have successfully installed this facade. So there are around 115 design patterns we are playing on a facade. So in the daytime you can't see any fixture, no projection, no bulky fixture on facade. The architectural feature, the vertical fins, we have utilized that, the same fixture, and we have integrated 25 by 13 mm LED linears into it. Then what are the challenges and the future business? So there are the technologies like day by day growing and all, so projector mapping we can do. Then we have already like a 3D, 6D, 6-dimensional views I can say. So these are completely like a transparent screen with the help of like a facade. We can install in a glass panel also. It can be a transparent as well. It can be come up with a separate LED screen as well. Then the urban lighting, especially for the sculptures and to bring the more footfall in the property. Then the interactive lighting, when you walk, the lighting also behave with your action, with your intensity, with your pressure. Then urban lighting with creating some different sculptures, some lighting shows, is a projector mapping. Then landscape also can be done in a dynamic way with the projector mapping, not even a facade. So instead of like going a very dark way, we can go with some dynamism and all. Then interactive thematic parks. Then the drones, anything you can communicate. It's a language actually, like you can communicate anything through the facade with the drone. So lighting also is a language. Then augmented reality shows, this is a very like new technology. From your tab with your phone, you can view the building of the 6-dimensional. So these are already executed project in settle in USA and all. Thank you.
Thank you so much, Ahmed. Again, visually very stunning, the presentation. You have any questions for him? Okay, thank you so much.
Thank you.
We'll move on. And we have two presenters for the next product presentation from Fisher India, who will, we have Edward Thomas and Uday Shikhare, who will talk on innovative solutions for facades. You can start.
So, very good afternoon, everyone. First and foremost, I just would like to welcome you all, and I would like to extend my thanks for Zak. We are talking since morning. About virtually meeting, or we can find about 18 to 20 months on a 12-inch screen or 20-inch screen. But I could say that this is not just a full stop. I think we need to take it out, something good out of it. And definitely as a Fisher, we have taken something good out of it. Individually, most of the people have taken something out of it. They utilize this time. I think I was, Bhasin, he was talking about, he gone through a book, some of the points he wanted to cover up. So on the same line, individually people have decided, and the same way company also decided. So what, in this span of about 18 to 20 months, we actually tried to policize, to make something new, or as we know that Fisher is known for innovative solutions, so we have given some thought on this basis. And earlier, like we were associated with some other thing, but now as we are coming up in a new platform, so we decided that we should launch a new products, new scheme for company or betterment of the industry. And first, it is also not apart from this, beside all the other reality. So I'll just run through a small presentation about this. I'll just brief you about some of the part of this, and a detailed presentation or detailed product introduction will be taken care by my colleague Edward. So the first about company introduction, I'll just brief you about company introduction, and the detailed presentation about each and every individual products will be taken care by Edward. So as you know, the Fisher, it's established in 1948 by Professor Arthur Fisher, right? If you know the flash photography of a camera, so the invention of that flash photography, if you can LinkedIn, if you can check it on a Google, or if you can check it on a other platform, you can find Arthur Fisher is known for flash photography. So as you see that such kind of invention always takes up, we are also a company where about 1,500 patents is on our name. So we are always innovating. We always try to evolve the industry. A small roadmap of our company, if you can see that it's founded in 1948. And if you see some of the remarkable journey, the invention of the S-plug. Now you can see, you can find the commodity, S-plug becomes a commodity, and you can everywhere find it. But the first invention or the concept of this S-plug came from Fisher, that is Professor Arthur Fisher. This is one of the remarkable, I would say, invention, and it changed the anchoring system altogether. Another very important parameter I could say, that in the event of journey in 1986, when we are talking largely on a facade, the undercut system, so undercut system invention or undercut system methodology, been developed for a stone facade, and not only constrained for a stone facade, it expanded for other substrate as well. But in 1986, we evolved, or we patented kind of a system, we call it as an undercut system. We crossed, at 1996, we crossed a 500 million euro benchmark of our turnover. During the journey, we also acquired some of the companies like Upat. You know, it's very well known into the European market. But like one of the remarkable journey, I could say that we also evolved ourselves into the automation. So if you're talking about the high-end cars, the automation of the high-end cars, we evolved. In 2017, we started our own company here in India, like Fisher India. Before that, we were in sync with Bosch, and that was the reason we have a different understanding of business operations. But when we came on our existence in 2017, we started our own subsidiary, and we started our entire portfolio, entire product basket. If you talk about Fisher, we have about 4 or 5 different subsidiaries or business units, we call it as. Our first or larger subsidiary or larger business unit is Fisher Fixing System, right? Along with that, we have Fisher Automation. We have Fisher Technique, some of the very innovative toys, we call it as for boys. And we have Fisher Consulting, along with Fisher L&T Automation. In a nutshell, if you see the growth or the company owner is Mr. Klaus Fisher. We have 5,200 people across globe. We have subsidiaries in 50 countries, right? And we have production locations across the globe. This year, we are running a policy of 525. So that means we came in our own in 2017. So this year, we are completing 5 years on our own. 25 years in India because we associated with some other company. So that is also one of the very remarkable parameter. And this is how a company nutshell we talk about. Now, for a detailed product presentation, I would like to hand over mic to my colleague, Edward Thomas. Thank you.
Thanks, Uday. So, yeah. So, good afternoon, everyone. I will be taking you through 4 products, 4 different portfolio products that we have. First, to start off with our undercut anchor for drywall cladding. I'll show you a video first.
Standards for facade durability, energy efficiency, and design flexibility are increasing continuously. The Fisher Facade systems fulfill all of these expectations. Fisher Facade systems, subframe systems and undercut anchors from one single source. The system provider for ventilated rain screen facades. The Fisher Facade systems are the optimal modular system for all requirements and materials. This visually most appealing solution is achieved through concealed fixing using FZP2 undercut anchors and suspending clasps in horizontal profiles. The innovative assortment is the perfect choice for visible and concealed attachment of all common cladding materials for ventilated rain screen facades. Fisher Facade systems utilize the effect of a rear ventilation to create an energy-efficient facade and provide optimal weather protection. With high quality, a long service life and a consistent recycling circuit, the matching shape of the undercut anchor creates an interlocking and stress-free fixing in the conical undercut drill hole. The fixing is not externally visible, creating a visually appealing facade surface. Setting the anchor using undercut technology allows the user to select the best structural position in the facade panel. This significantly reduces the bending moment of the panel. The consistent residual wall thickness as a reference in drilling holes allows panel thickness tolerances to be compensated. More freedom in aesthetics and materials for visible fixing using rivets and facade clamps, and for concealed fixing using undercut anchors and cassette solutions. With more than 50 subsidiaries, Fisher is your global project partner on every level. We support you in all areas of facade construction. Fisher Facade Systems, subframe systems and undercut anchors from one single source. The system provider for ventilated rain screen facades.
So what I was showing you is a complete detail on the undercut technology and the system that we provide. So irrespective of the base material, whether you have base material which is natural stone, ceramic, high HPL panels, or even glass, we can support you with these kind of applications. And we have different anchors. So the anchor selection is based on the application and the base material. So the anchor construction is pretty straightforward. We have a simple expansion ring, which actually creates a stress-free holding into the base material. We have the M8 connecting rod, a polyamide sleeve, and a cone bolt which goes into the undercut hole. The functional principle is pretty straightforward. As the video told you earlier, we create an undercut hole. We have a machine for it where we can support you for the entire application. The anchor is placed, and as it is tightened, the expansion ring expands, and you get a stress-free fixing. So for a load, you get a complete stress-free fixing into the application. Sorry. And now when we talk about stone panels, if we talk about a 30 mm panel, there is a 2 mm tolerance that comes in, plus or minus. So when you're doing a stone cladding, there's a lot of chance that it looks uneven on the surface, so people opt for shimming. We also have anchors with standoff options, where the entire facade on the front will look in complete level. Now, one of the things is we do have the traditional methodologies of stone cladding, where we fix the clamps at the top end and the bottom end. Now, because of this, what happens is the bending stresses are higher. Because the anchors are placed inward in the stone, The bending moments are a lot more efficiently managed. And the biggest advantages of this is we can work with bigger panels. We can have a greater safety in calculations. We can also work with slimmer stone panels. So that reduces your weight and the cost. So there is more freedom to design. Of course, at Fisher, what we also support you with is our entire subframe system. So the entire horizontal, vertical profiles, the entire bracket system, the undercut, everything. So we don't leave you with just the anchor and undercut. We give you the entire assortment. Now we also come across applications where you have at window levels you want to bend and have the stone facade coming in. So we also have a reveal angle option which can be used. We have them given a demo of all of this at our booth outside. We do support you with stone testing services, panel calculations, subframe calculations, and of course section drawings as well. All this of course is vetted by the consultant once submitted by us. So this is one of the biggest references I can give you across the globe. This is a stone cladding done at a height of 412 meters, Al-Hamara Tower, which is the highest natural stone facade cladding in the world, stone facade in the world. This was the Bai Temple reference. We also do applications which can be where you can have cladding at various angles. Now with this, I'll move into our second product portfolio, which is passive fire stops. Now, why do we consider fires in facades? The main thing is structural integrity. The reason of spread of fire is two reasons that we come across. One is curtain wall through the gap between the facade and edge of the slab, and the rain screen cladding. Of course, the material which is burnt and dropping is also risky to people trying to escape out of the building. So what we are talking about is vertical and horizontal compartmentation. Now, this is something I'm talking about how fire spreads through a perimeter joint and the leapfrog effect. So we have a fire incident that's happening, and if the perimeter seal is not closed, the fire passes through. But if the same thing is sealed, the fire can be contained, fire and smoke can be contained in the area. But can it be contained completely? Actually, no. If your glass is not fire rated, the fire can pass through leapfrog effect and come into the adjacent flow. So when we talk about our products, we are talking about we are an extension of the slab. To avoid leapfrog parameters, one of the two major points that we generally recommend is one is increasing the spandrel height. The second is use of fire-rated glass. So we have two products in our portfolio. One is a preformed product which, for perimeter joints, which is FCFCL. We have and we have a spray applied system. We have two systems. One is for UL approved and based on EN standards. So based on the project requirement, we can support you accordingly. One of the points that I really wanted to highlight was with reference to the orientation of the safing material, which generally gets a lot of time mismanaged at site level. And second point was with reference to compression. So if you have a gap of 100 mm and we say 30% compression, a lot of times the discussion comes at 130 mm of mineral that's required. Actually, that's not what it is. Actually, it should be about 143 mm. That is, 30% of 143 is 100 mm. So that's the calculation we have to work on. A lot of time this gets misunderstood and misrepresented at projects. A couple of presenters earlier mentioned about ventilated facades and why fire stopping or fire sealants are important for these applications. So we also have products where you can compartmentalize your ventilated or rain-screened facade, both vertically and horizontally.
The Fisher FFB VS VentiStop system is an effective fire protection option in ventilated facades. By using FFB VS, the rear ventilation essential to the building physics is maintained, but closed in the event of a fire to prevent the spread of flames.
So these products can close a gap of up to 50 mm. So these are designed for these applications, and these can be worked on with. Now, just to bring into one of the new products that we have launched here in India, which is cast-in channels.
For building industries. Fisher cast-in channel systems have been granted ETA approval. The main compositions for Fisher cast-in channel includes one-time forming hot-rolled or cold-formed C-channel anchors and accessories. The material is using ETA-recognized one, and surface can be treated with hot-dip galvanized or zinc aluminum coating, which is seismic resistant, high strength, and corrosion resistant. In the applications of building facade, rail, and subway transportation, integrated pipeline tunnel, etc., Fisher cast-in channel systems have been more and more widely used, greatly improving the installation efficiency of post-installed fixing parts, reducing potential risks in on-site work and maintenance cost. In building facade application, Fisher cast-in channel systems are widely utilized in the installation and structural bearing of facade panels. Fisher cast-in channel can be connected to facade assembly through channel bolts to achieve an effective connection of the entire facade system. Position and install Fisher cast-in channel in the concrete formwork. Place the steel mesh and fix the cast-in channel via self-tapping screws. Fill the concrete evenly throughout the casting form and remove the formwork after the concrete is fully solidified. The filler in the channel is removed by a rip line. Insert the channel bolt and rotate 90 degrees following the grooved curve. Freely adjust the bolts to the proper position. Install the facade bracket and tighten the nut. Fix facade frames and other accessories, and then install the facade decoration panels. In this manner, the facade system construction is completed. In railway and
So because I'm running out of time, I'm not going into the other applications. So we have both the options, which is hot rolled and cold formed channels. So the primary difference is pretty simple. Hot rolled, in the process itself, it is heated and then it is gradually deformed, because of which the residual stresses in the channel is lower. We are also able to get a thickening of lip, which in turn gives us a relatively higher load bearing capacity. Whereas when compared to cold formed, it is directly fast manufacturing process. It is manufactured in a cold state, but the residual stresses around the edges of the bend will be there, because of which the load bearing capacities are relatively lower when compared to hot rolled channels. Of course, also because of this, the torsional and the resistance weakness, there is a weakness on the material as well. All our products with the casting channels are designed as per EN 1992-4, which is the ETA's, the European standards for casting channels. And we have a ETA approval for the product line as well. In terms of support, we have our in-house software where we can, and it is available free of cost online. You can download it and use it directly. The entire design option is available. With that, I'll just touch upon the product which everybody is well aware of, so I'm spending the very least amount of time with it, which is anchor fasteners. Now, in terms of anchor fasteners, Fisher has a wide portfolio of products, both for cracked and non-cracked anchors. Our first anchor, in terms of approvals, we have all the approvals, but one request is please select the anchor based on the application. If you don't have a requirement of a seismic application, you can look at an anchor which has non-cracked concrete approval, but does not necessarily have a seismic approval. Just because an anchor has a seismic approval does not mean it is going to work if we design it for static. Because we've had a lot of discussions, and I just wanted to point it out. What better forum than this to gain a wider audience? Then we have another anchor, which is FBS, which is a concrete screw. This is can be used for your balustrade fixings or railings where you do not want a threaded rod or a nut being shown up. So we have this option available. This is again ETA approved. In case of any applications that you may come across in masonry or other base materials, we have the nylon plug anchors as well. And finally, we also have our chemical portfolio. The reason I want to touch upon is there are certain projects where we have done an entire facade project with using chemical anchors. So, and these all products are ETA approved, have relevant approvals for seismic and fire rating. So we can work on these. So with that, I come to an end of my presentation. Thank you so much.
That's perfect timing, Thomas. Thank you so much. And of course, any questions, they have a booth outside, and you all can go and check their products out. With that, we'll quickly move on to the next presentation for today, and I would like to call upon Ravishankar. Again, a face that everyone who's in the glass industry or aluminum industry will be very familiar with. He's from Dow Chemicals, and he will speak on innovative products and project management services for high-performance facades. And just in case you've got some silicon kits with you, please give it to me right now.
Yeah. Hey, good afternoon, all of you. It is again nice to see you all in person. So thanks to Zak. So Zak has been a great organizer. The amount of energy and passion today I got after a break of, say, last March, and to this, has been quite nice. So meeting people always gives us an opportunity to interact, learn from each other, though we were trying to do it through the small screens for so many months. But this sort of interaction always helps us to pass on so much of learnings. So with that, I wanted to start my presentation. I'm going to talk about a few of the products, because in over 2 years, there has been a lot of innovation happening around. We never got an opportunity to present it to you. So this forum, we are taking that rather than talking about a case history where we have been successful, though there are many. I am going to talk about few of the products what we have introduced in the last couple of years for the facade and other segments. So just to give a very brief on what Dow is all about, you all know that we were previously known as Dow Corning. From 2016, the Corning sold their share to Dow, and then we became part of completely Dow. From 2018, our brand got changed to Dow Sil from previously Dow Corning. So with the Dow coming in, there is a very positive outcome for this, whatever you call it, merger or takeover, wherein we are now able to leverage to different chemistries. Previously, Dow Corning was restricted to only making silicon as only chemistry, and we were making a lot of innovation on silicon. So with Dow coming in, we are able to leverage on other part of the chemistry, which is more of an organic. And today, whatever products I'm going to talk about is only because of this collaboration, we are able to become more and more become a one-stop shop for most of the facade application requirements for sealing as well as for the airtight membranes. So Dow is a $39 billion company with close to 36,000 employees working for the organization with 106 sites and in 31 countries. So we are present in India quite well. We have 3 manufacturing sites wherein there are different product portfolios of Dow are getting manufactured. And also we have got close to 3 application, 1 application center, 1 engineering center, 1 corporate office in India. So Dow, if you talk about the technology on the facade, we are into advanced engineering calculations, because more and more design challenges are coming out. Cold blend glasses has been one of the trends which is recently coming out, wherein there is a requirement of an engineering calculation to understand the stress coming onto the sealant part of it, or if you are talking about even a hard bend. And then also the wind loads are going higher and higher, so you cannot keep on increasing the bite. The aluminum section width will become more and more complicated. So Dow has got a excellent technology to calculate the stress and come up with an innovative designs, which could be a trapezoid or with a rectangular design on how to do the stress distribution. So that is one thing which we are getting expertise with. And there are many various other products which I will be covering on in my further slides. So I would like to skip and then move to the main slide as we go forward. So I am going to talk about totally 5 different products today. So all of them are displayed in our booth. So please feel free to come and have a touch and feel of these products. So I'm going to talk about a paintable sealant. So one of the drawbacks with silicon when we had Dow Corning was we could never get a paintability on a silicon, because silicon has got excellent water resistant characteristics. The surface becomes very unique, and it does not allow anything to stick onto that. So that was being a good advantage for a facade applications to give you the durability. But there were applications where people are coming up with precast panel, and they wanted that joint to be sealed and painted. So their silicon was not a choice to them. Then we made with Dow integration, we are able to come up with a molecule wherein get a durability as well as paintability. So that is a silicon hybrid technology which we introduced recently. I am going to talk about glass embedding using a PU sealant again. So PU, Dow is a strong manufacturer of polyurethane products. Either you talk about the Carlon type of a foam mattresses, or you talk about a car seat, or you talk about insulations. Dow has got many products into the PU segment. So the extension of that is making into a sealant for the facade application happened, and we just launched the product last year, which is called glass embedding sealant. Membrane, again, Dow packaging is a 50% of the business of Dow comes from packaging, and they make EPDM as the raw material for many of their nodal series. So we took that raw material, made into a membrane through a calendaring process, wherein we are able to make the product suitable for air and watertight application requirement for facade again. And I'm going to talk about a new, again a product introduction, because we being a strong service provider for the facade, all the DGU processors, they came to us whenever there was any of the problem in the DGU, they used to come and approach us because the service levels were very poor with other suppliers like primary seal manufacturers. So Dow also introduced a butyl primary sealant. So now both primary sealant and secondary sealant are available with Dow. And then I'm going to talk about a peelable coating. This is again a super product. I would say this again comes from Dow's coating material, which has introduced a paint which can be applied on the facade, either at site at the factory, which will give you excellent resistance against concrete falling, or to a sputter, or even to the electric arc resistances. So if somebody is doing a welding and there are spark coming out, this will have an excellent resistance. And also there is no adhesive which is applied on it, so there will not be any transfer to that. So you can keep this film for 12 or 18 months and then peel it off nicely, it will come out. Last but not the least, a very innovative, creative solution from Dow. Dow has been talking about a lot of crystal clear solutions for their facade. So we have an unique spacer which can be used in the double glass facade, making it for an interior application only on the vertical sides using the spacer. So you get a complete transparent view to look at whatever is behind in terms of freezer arrangements, or it could be for the partitions. So with this, I'll quickly take you through some of the details of this product. What does this product can do? So as I told you, this is a paintable hybrid. This can have a good weather resistance and also can have low staining. Okay, that is the beauty of the product. Since it is a weather seal, we came up with a one-part system, neutral cure, so it can be easily applied to any of the expansion joints, precast, or window perimeters where you are looking for a durability with paintability. So the paint can be both. It could be a simple water-based system, or it could be a solvent-based system. Whatever is the paint you have, we have done excellent testing with different types of paint. You take the top brand of paints available in the market today, apply it on top of the sealant, and then we did some wet aberration test. We also did scratch test to pull the paint out of it. In none of the cases we could see that the paint could peel off from the sealant. So what does it mean is the pickup is very good. So it is on the durability of the paint, because the sealant is going to be protected with the paint. So if the choice of the paint gives you a good durability for 10 years, definitely the sealant will be protected. And after that, even if the sealant is exposed, it is also going to give you further protection. So that is the beauty of this whole system. We have already done a few projects using this product. It could be even a 30-40 millimeter wide joint. We can still do it with our hybrid sealant and it can be painted. Or it could be a precast panel or a fiber cement board. You can do the application with this product. So we also did a concrete to concrete type of a joint, and then we pulled it. You can see there is a complete cohesive failure. That means the sealant fails within itself and does not leave the substrate. So the bonding is very good, which is one of the important criteria to give you a watertight seal. So we talked about any type of paint. Mainly water-based is what is used in the exterior, but some of the interior application people might use certain type of alkyd or a enamel paint that can be also applied on top of it. That's my first product. So second is the membrane. So this is an EPDM membrane, and what does it really do is, whether it is a smaller or a wider joint, what happens is you cannot apply a sealant if it is less than a 6 millimeter, or if it is beyond 50 millimeters. You tend to have an application challenge. So how do you make it more and more water and airtight? That becomes a challenge. So one of the beautiful technology we came up with, which was there already in some of the areas this was introduced, is a membrane. So the local membranes might look like a rubber, it will have a very poor tear resistance. With the raw material being supplied or manufactured from Dow, we are able to give you a good mechanical property. And then if you look at that membrane, it looks like a fabric. Excellent tear resistance, and also it can be easily bonded with an adhesive. So your coping areas where you are using a GI prefabricated system, which is one of the tedious things, you can use this product and bond it to both concrete as well to the aluminum. So it gives you excellent water vapor resistance. It can be used on different ventilated curtain wall or window insulation facades. So connection is very important. If the connection is weak, there will be a leakage. So how to make the connections very strong, whether it's a similar material or dissimilar material, one of the best ways to get that tightness is through some of these barrier systems like membrane. Okay? Sealant works very well on to a certain dimension, especially on silicon when you do a proper application joint design. But where there are challenges where you have dissimilar materials, there are, it's quite a possibility that you may not be able to apply a sealant all over the area. And also when there is a big connection you wanted to make, then membrane becomes an easy way to maneuver over that particular joint. So these are some typical applications we can see. One could be a canopy type of an area where the facade gets in, end, and you have a opening, and then it could be a connection between two joints, or it could be the end of the facade area. So all of this can be completely sealed, because these are the weak areas where the water can come in. So we have three different types of thickness with us, 0.6, 1 and 1.2, and we call it as a dual. Dual means it gives you an excellent water and air tightness. We also have a breathable membrane, so that is generally meant for a moderate climate. A climate like India where we run the air conditioner every time, and then we have very high moisture and then rains, it's better to go for a dual system. And this will give you an excellent resistance in terms of water vapor. If you talk about 0.6, it gives you 60 meter water vapor, equivalent air layer thickness resistance. 1 millimeter will give you 100 meters, and 1.2 will give you 120 meters. So you can see the breathable membrane will give you a good dryness behind the substrate, but it will allow a certain amount of water vapor to pass through. Okay, so it comes in a 25 meter roll, and the maximum width is 1.4 meter. So if you are able to do some of this application at factory, you can have a good quality control, but most of the application need to be done at site. So surface preparation becomes one of the common area to be taken care of, and I don't need to say that we are expertise. We have developed our expertise in applying many of our site-based adhesive applications over the years. So that's my second, and this one is a quick one. This is just a butyl. We have a primary seal which needs to be bonded to keep the spacer intact with the glass, and then it also acts as a moisture barrier. So the dual seal system on the DGU, the primary seal and secondary seal, gives the long-term durability against moisture or the condensation, and that primary seal gives you the barrier against moisture. So if this seal is not proper, then you will tend to have a failure on the DG unit. So the amount of width, thickness is very critical. Also the temperature stability of the butyl is very, very important. So we have two types of butyl. One is called the standard black, like what you see in the market, and we also have a special black butyl which matches to the color of the secondary seal. So sometimes when you look at the facade, you might see three different colors: butyl color, secondary seal color, and then the weather seal color. All three will look very different. Architects, they don't like it. So for you, we have a choice now. We can match the butyl to the secondary seal, and then also the weather seal will be similar in that. So everything can look uniform. If you like it, then there is a choice today, you can get it. And also the special black has got a temperature resistance of 100 degrees centigrade, and the standard black has got 90 degrees. Most of the general butyl available in the market are in the range of 70 to 80. So what does it mean is, if you closely go to your window and then look at the butyl, you might see a small wavy rundowns. Okay? So that is because they don't have excellent temperature resistance. So this is very critical for selecting a right butyl. We have tested it to EN 1279 part 234. What does it mean is, with this combination of primary and secondary seal of Dow, you can get a long-term durability against water vapor intrusion. Okay, that's what it talks about. So the fourth one is a peelable coating. This I talked about. This is like a facade. You have a paint to be applied. This can be brush applied, or it can be sprayed, a simple application. 100 micron dry film thickness is what is required. With a 2-coat paint, you can easily reach that. And it can completely protect you against facade against dirt, scratches, corrosion, debris. This is one of the common thing, and the repair cost because of that or the replacement is very, very high. So you can go for such a simple system. It can be done at site or it can be done at factory. This is a single part paint, so which can be easily mixed initially and then applied with a brush on top of the glass. What we have done is we have done a 12-month natural weathering also. We have done an accelerated weathering up to 8,600 hours, 8,600 hours of UV. That means that even after 18 months, if you pull it, the peeling will be very clear, and then you can get the underneath surface completely protected. So these are some of the actual projects wherein this has been used, and in India we are now trying out with samples and mock-ups. So very, very simple application. So and this gives you a light blue color, which also gives a nice finish on the facade. So this is just talking about how it can give you anti-weld sputter also. The one without that has got a lot of scratches on the glass, and when it is protected, you can completely see nothing has happened to the glass. So the last but before that, this is one of the beautiful sealants we have introduced for the balustrade. It can give you, it could be a high-end residential or a stadium or a shopping mall, airport, wherever you have a glass partition and only one side of it is being sealed. So we have come up with a PU sealant, and this PU sealant can be slightly poured into that. It's a very pourable grade. It completely takes the shape of the U channel and holds the glass. So there is a release which is applied. We don't want that to be bonded. So there is an uniform stress distribution happens because of the system. And if you want a replacement, you can cut the weather seal on top of it, and with a lot of mechanical force, you can remove the glass as well. So replacement is also very easy compared to many of the standard systems available today. If you talk about rotulas or clamps, they tend to put local high stress areas. If you take a cementitious one, it is a very thick material, very hard one. The distribution is there, but it is very high. So we came up with a polymeric material which can give you a good stress distribution along your width of the glass, and then also can be easily applied. So this is the red one is a PU. You put a setting block on the bottom, keep the glass in, and then pack the glass, apply the PU into that, it nicely fills it in, and leave the top areas clear, apply the weather seal, and that's all. So this weather seal gives a protection against weathering, and the PU will hold the glass completely for your balustrade application. So you can add any color you want. The pigments can be added while mixing the two-part. This comes as a two-part system. It's very fast curing, 7 hours the sealant will completely cure and hold the glass in place. And it has got initially a nice open time for you to apply. So all the advantages of what you can get in the product is being designed in this. So this is just to show you how it can be removed, as I talked about. You can cut the weather seal, and then with mechanical clamps you can pull the glass out in terms of breakage, and that becomes a big issue. You cannot go out of the facade and remove them. So this is another simple option to do that. Sorry for a bit rush. So this is one of the projects wherein a 12 meter by 3 meter glass has been completely done with our PU embedded system. This was one of the dream of an Indore Maharaja who wanted to make a temple, but it didn't happen. So they have a sculpture in, this is done by the Stefan Dorin in Romania. So this sculpture is available, wherein they have used our structural to bond the glass louvers, and then the outside is embedded with a PU. My last product is a clear spacer. So Dow has been very strong in designing clear, and that is one of the, glass has been one material which is clear, and other material is again with silicon, being of same family, we can make it clear. So this is one of the innovations we have been making. So some of the malls, what you would have seen is this entire view get obstructed when you have such a big frames and black sealants, which can be completely eliminated by having a crystal clear spacer, which can be put on the vertical sides, and the top and bottom will be their normal DGU with a spacer, desiccant, and secondary seals, primary seals, and the vertical can be only with the spacer. So this is a pre-extruded tape, and which can be applied by bonding with our primer on vertical sides, and the horizontal sides are normally done with the usual system. So we have a sample I can show you in my booth. So it could be for various applications where there is a challenge or architect is looking for a unique solution but mainly for interior. We have not tested it for exterior so far. The testing is going on, but right now it is for interior, where somebody is looking for a very high transparency, very high durability, and then also looking for a good aesthetics. So what does not stop? The services. So Dow has been very strong in services. We have a full-fledged laboratory in Navi Mumbai, where we do all the testing, we do the design reviews, we are very connect with our customer to do the on-site quality checks, so that all our projects which are coming to us for review are being taken care of, and a warranty is given for the durability of it. So which is an important part. It is not a product which matters. What is that you give to the customer and how you are connected and what is the service you offer is what makes Dow a really unique company. We have this facility in Juinagar, and where today we are doing close to 200 building projects with 3,500 lab testing today done by my team here, and then we are managing that surveys to our customers effectively over last 2 decades. A single slide speaks 1,000 words. So if you take top 20 projects done in the world, the top 10, 20 high-rise buildings, 14 of them are done with Dow. So in first 10, if you take, there are 8, and then there are 6. What does it mean is, it is not just a product, it is a design, it is a solution, and the service, everything matters, and that's what we are able to be associated with top landmark architects, consultants, not only outside India and also in India. So thank you. Thank you for your opportunity, and sorry if I rushed a bit fast.
Thank you, Ravishankar. Prompt as always, right on time. We'll move on to the next one, the last one before we break for tea and coffee. I would like to call upon stage Malvinder Singh from Shikhare. Again, a very known face for anyone who's in the glass industry. Shikhare is a manufacturer of interiors for glass, laminated glass specifically. And there's an interesting topic and a product demonstration that he will give today. It's on burglar bullet blast resistant glazings with their products.
Thank you, Tariq Bhai, for the nice introduction as always. Sorry guys, I'm the hurdle that you have crossed to before you get your coffee, but I'm sure I will try to make the presentation as attractive as possible, because we have a live demo of a security glazing. So the entire presentation is going to be action-packed. So why I'm today here to talk about security glazings? Because recently the trend of security glazings has become quite in. And the reason why it is so, because there have been a lot of incidents of terrorism, which has made the demand for security glazings picking up. So before we dive deep into the subject, let's know who we are and what we do. So at Shikhare, we are the manufacturers of we are the leading manufacturers of the interiors for the PVP laminated glass. And you just name the application, and we have the solution to match your needs. So it can be safety, decorative, acoustic, and structural and security. So for today, the focus will be on security applications. So if you have any questions related to any other application of laminated glass, we just have a booth outside. You can just visit us, and we can answer your questions. Yeah. So why I'm here today to talk about security glazings? This world map about the most recent terrorist attack which have happened in the past 2 decades tells you the entire story. So no country has actually been spared from the terrorist attacks. And the infrastructure buildings, the glass facades, these become the soft targets of such attacks. And the glass actually becomes a secondary weapon which can injure people. And it's not only about the terrorist attacks. We are a democratic country, and people have they just vent out their frustration when they're unhappy with the system. So they get into some sort of riots, and which can actually be very destructive for the glass facades, corporate offices, and we have seen very recently some incidents happen in our country where the big fashion brands or the corporate offices, they faced huge damages. And always the glass becomes the weakest link, because for a layman, it's just a glass. And the perception is that the glass can be easily broken. And from the architectural point of view, the architects, they just love to have big panels so that they get the maximum view. So this poses a great amount of challenge for the facade consultants because they have to suggest the right combination of glass which can sustain those attacks. So the challenge is to match not only the glass but the framing system which can sustain such kind of attacks. So when we talk about security glazings, the intention or the objective is to mitigate the threat from not only natural hazards but also man-made hazards. Here are a few examples where you may have to use the security glazings, some examples of man-made threats. So it's important to clarify that the safety glass is often confused with the security glass. Many people say that I have put a safety glass and I don't need a security glass. So of course you can improve the breakage pattern of the glass by choosing the right combination. On the left hand side I have the annealed glass which has got the worst breakage pattern because it has got big shards of glass. And if you go on to tempered glass, of course this is safety glass because the code says it breaks into small fragments. So you are improving the breakage pattern. And if you go on to laminated glass, it is still safety glass, but I would say it will be the entry level of a security glass. And if you want to increase the security level, you have to increase what is inside the two glasses that will actually govern how secure is the glass. And here is a more apple-to-apple comparison between the safety and security glass. So the biggest mistake that people end up doing is they think that tempered glass is the most strongest glass and they end up using a tempered laminated safety glass for a security application. I would say that that is the biggest mistake that you would do when choosing a security glass. And here it's important to clarify that for security glazings, these should not be considered as a standalone solution. So here the intent is to increase the time and the effort that a person will take to break into the glass. So I have clarified that you don't have to use a tempered glass. And the design of a security glazing is influenced by the anticipated threat level. So you need to have a very precise idea about the anticipated threat level. And of course, SPOL is acceptable or not. What is SPOL? SPOL is the risk of injuries when a person is standing close to the glass, so he may get injured. So I mentioned about the man-made threats, and here we have some examples where the threat from man-made threats needs to be mitigated. So when a person is trying to make an entry forcefully into the building, that is called forced entry, and then you have a risk of firearm attack, or it could be a bomb blast explosion. So we saw last year in Lebanon what happened. It caused catastrophic damage to the glass facades of most of the buildings. So here, these are the few examples where you may need to have a security glazings from man-made threats. And when we talk about security glazing and the forced entry glazings, here are a few examples of the country standards. So for testing the suitability of the glass for such applications, the European standard EN 356 standard is a very common standard. This standard has two types of impacts, the P1A and P5A. This is a ball drop test for low level of securities. And for high level securities, we have the levels from P6B to P8B. So the picture that you see over here, at the top we have the ball drop test, and at the bottom we have this mechanized axe, and the intention is to make a cutout into the glass. And also we have a mention of the standards that are coming up in India, IS 16978. This standard gives, this is the Indian standard which has come up very recently, and it's very similar to the EN 356 standard. The US standard ASTM 1233 is also one of the common standard which is followed worldwide. It's very important to say that when you have a very good security glass, then it's important to ensure the framing into which the glass is being put up, that is also very rigid. Otherwise, there is no use of putting a good security glass if it comes out of the framing. So it's important to test the framing and the glass as well. So on the right-hand side, you see the standards which are used for framing. But as of now, we are focusing on the glass only for today's session. Yeah. So, yeah, so my hitman is there. So we will have a live shoot of the glass to, so he's going to hit the glass. Before that, I would request the people standing, sitting over there to be, maybe they can move just a few steps back so that, you know, they don't get injured. Sorry? That is inside. Yeah, that's enough, yeah. That should be enough, yeah. Now try with the hammer. That's it. Now I would like to request someone from Sohail bhai, can you just go back? Okay, okay. May I request the gentleman sitting over there? Can you just go back and touch the back surface of the glass? So the back surface of this particular glazing is making use of a PET film. So that PET film is actually protecting the people who are sitting very close to the glazing from any kind of small injuries that they might happen because of the fragments of the glass. So is it safe to touch the glass? Perfectly safe? No fragments? Thank you. Yeah. So in a real-time situation, the person who is going to attack the glass, he may choose a variety of weapons like sledgehammer, a pipe, a fire extinguisher, a propane burner, or some sharp tools, as we have just seen. The person, my hitman, he made use of an axe, and he may be also carrying some chemicals with him. So let's see what happens in a real-time situation. I have this video. This is what happened in New York last year. So this was a showroom of a big fashion brand, which was attacked by mob, and you can see how innovative people can be when they attack the glazing. So in the interest of time, I will just cut it short. So then we move on to BRGs, or bullet-resistant glazings. So over here you see the European standard 1063, which gives 7 levels of different threat levels. So the difference between all these threat levels is the speed of the bullet and the mass of the bullet. So BR7 is the highest level, and BR1 is the lowest level. And we have solutions for all the different threat levels, which are the lightest one compared to the conventional glazings. And then we have the US, these are the two standards which are very commonly followed in the US, the NIJ and the UL standard. This has, NIJ has 4 levels and UL has 8 levels, as you can see. So some of the levels are very similar to 1063, the European standards which we saw previously. So what are the needs for the security glazings from the market? So market is always looking for solutions which have got a very long lifetime. They are lightweight, and the transparency is maintained throughout the lifetime of the glazings, and they have a very high durability, low density, good optics, and they're easier to process. So BRGs with Curare's advanced interlayers. So here we have a conventional BRG, which is very bulky. It is making use of multiple layers of glass and PVB, and the yellow one that you see is a polycarbonate interlayer, which is used for nose polish solution, and it may have an anti-scratch coating as well. Yeah. So the polycarbonate that you see over here, that has some durability issues, and it tends to develop scratches over its lifetime. Now, when we make use of advanced interlayers like Sentry Glass and Spall Shield, so these enhance the durability of the product, and they make it lightweight, and they have got a very high scratch resistance and chemical resistance. They are easy to process as well. So here we have a comparison for NIJ level 3A and NIJ level 3. So you can see the BRG is made with advanced interlayers. These can be up to 15% lightweight. And when we make a comparison of the thicknesses, the BRG made with conventional glazings from one of the leading glass manufacturer is 65 mm thick, whereas we can make it in just 37.9 mm thickness. Yeah. Yeah. So it is. So the BRG for NIJ level 3 is 40% thinner. Okay, so when we talk about the automotive glazings, like automotive application is one of the biggest application of BRGs. So the automotive standard, which is IS 2553 part 2, it says that the automotive glazings, when they are making use of plastic glazing materials, they should be resistant against attacks from chemicals that you see in this table, because the standard feels that the glazings may come in contact with these type of chemicals, and these may also be subjected to abrasion. So it's important to check the durability of the BRGs for this particular application. And you can see the glazings made with Spall Shield CPET, which is the PET film on the inside of that glazing. That is the clear winner. It has a clear edge over acrylic and polycarbonate solutions. And also in terms of abrasion, Spall Shield is the clear winner because it maintains its transparency after the abrasion test. Then another important application is the blast resistance, which is getting very common these days. On the picture on the right hand side, you see this how the resiliency of a glazing against blast resistance is checked. We have this shock tube test when you want to check the suitability of the glazing inside the lab itself. So we have this shock tube test where when the glazing is subjected to a sudden blast of air. And then at the bottom, this is open arena test. And this we make use of a real bomb, and the glazings are exposed to this shock wave, and the behavior of the glazing is studied. So of course, if we know the threat level, which is the peak pressure and the impulse, then we can support you with a blast simulation, and we can give a very detailed report. But for that, we need to have a very precise idea about how you want the glazing to behave in case there is an explosion outside the building. What it means, so these are the 5 levels, which it's a pictorial representation of the behavior of glazings when it is subjected to sudden blast pressures. So the level 1 is the most safest level. In this case, the glazing is, you can see the glazing is intact. It is not even broken. And the level 2, the glazing is broken, but it is retained in the framing. Level 3A, in this case, the fragments, they can fly up to a distance of 1 meter after they have broken. It's a very low hazard, again. And the low hazard, it's level 3B. So the glazing fragments, they can fly up to a distance of not more than 3 meters. So I would say you can choose between level 2 to level 3B depending upon, of course, how much the client is willing to pay, because behind every solution there is a price factor. So based on that, the client can choose the safest level for him. And of course, the level 4 is certainly not safe, because the glass fragments can fly anywhere. Yeah. So I would like to summarize that the BRGs made with advanced interlayers, they have got the highest optical performance, as we have seen, because they are making use of advanced interlayers like Sentry Glass, Trossi for Ultra Clear, and Spall Shield, and they have no yellowing effect, and they have got the minimal haze. And when any material is subjected to the 5 elements of nature, nature can be very cruel to the toughest material that we know, and this picture is just depicting that. Even hard rocks can get weathered down. So again, glass and polymers, these are just polymers, they are plastic materials. But we have studied the weathering effects on these materials And Sentry Glass, after being subjected to natural weathering conditions in Florida for more than 20 years, has not developed any kind of defect. So we call this as ESN number, which is edge stability number. And this is 0 even after 20 years of natural weathering. And Florida, as you know, is known for its harsh and humid climate environment. And last but not the least, Spall Shield. It's an exceptional product that we have, and it withstands 16 hours of high temperature test, which means it is subjected to 100 degrees of temperature for 16 hours, and it does not develop any kind of bubbles or delaminations. So why it's important to highlight here, because other conventional BRGs which are making use of polycarbonate or polyurethane, they don't withstand this particular duration of high temperature test. They can withstand only 2 hours. But just imagine the glazings can actually be subjected to much more severe conditions. So that's why it's important to test for 16 hours as for a laminated glass. And lastly, the glazings are thinner and lighter, as we have seen in the previous slides. And they are easier to install because they are lightweight. Thank you very much.
Thank you. Thank you, Malvinder. And thank God that worked. So now I can tell you this was from FG Glass. So we'll break for tea now. 15 minutes, please. We'll come back at 5 o'clock. And in case any one of you wants to still try, there is a hammer and axe outside. You all can come and bang as much as you want. Okay, welcome back everyone. In the interest of time, we will move forward quickly, and I request all those who are outside to please come in and take your positions. We have a slight change in the schedule, so we have some panelists who are short pressed on time. What we have decided is we will start with the panel discussion first, and then we will have the final two presentations. So the panel is titled Facade Value Engineering, Managing the Progress and Limiting the Risk. I think a lot of topics that we spoke of in the morning, some of them will be carried forward here. This will be moderated by the very dynamic Kamlesh Chaudhary from Glass Wall Systems. So we'll wait till he sets himself up. And I would like to also call the panelists on stage one by one. So Shekhar Patki, the principal architect at PG Patki Architects. So if you all don't clap, he won't come. Welcome. How are you? I would like to call upon Nirmal Mangal, who's the India Director of Architecture at M. Moser Associates. The next panelist is Neerav Parmar, the Senior VP Contracts and Procurement at Shapurji Palanji. And next one is Vijay Pawar, who's the Director of Project and Development Services at JLL. Welcome. And we have Sam Robinson, the Managing Director, Middle East, India, and Southeast Asia at Hydro Building Systems. Raman Sapru is late, so he should join us as soon as he's here, maybe another 15 to 20 minutes. But meanwhile, I will, oh, there is a chair missing. Okay. One chair. So the brief on this panel discussion is integrating the right assessment models for getting the most value out of facades. Value engineering versus value extortion. Is it cost reduction for diminished value? I will have a lot of questions on that. Continuing the process improvisations for best practices and value engineering for bespoke facades procurements to suit local requirements. So I'll leave it in the good hands of Kamlesh Chaudhary to take this forward.
Hello. Very good evening, everyone. Very good evening. Fantastic. Welcome to this panel discussion. I'm sure we are going to have a good session, a good knowledge sharing session today. So coming straight to the point, and since we are running out of time, and integrating, managing, facade value engineering, managing the process, limiting the risk is what is the topic that we are into. And my first question is to Neeravji. Is that today there are a great number of facades technologies that are readily available into the market. The decision as to how they are designed or costed, operated, maintained, assessed, that remains a big challenge. Can you throw some light on that? And this question is to all the panelists over here. What are the views of yours?
Thank you. Yeah, good evening everybody. I think, as you said, new technologies are coming, new designs are coming. I think what we found is, enough display is not happening. Things are coming in bits and pieces. Like if you have such events, we have everything coming under one roof. That's where display is done, and it's through the architects who bring it to us from that point. I think that's the entrance from that part of view. Regarding getting new technologies, I think this should be done at the design stage. So enough things is done. What happens is, once we have a particular budget, we start with the project. We invite the quotes, we go ahead with that, and then when it doesn't meet the budget, and then the whole helter-skelter starts, and then you work backwards, which way you should do, should we do something, and then there comes in the the design component part of it, new product is coming. So the whole thing is that what I'm trying to insist upon is we get very little time to evaluate, assess, and are not very sure whether this is tried, tested. So that thing is missing. So there I would request our most important stakeholders, architects,
correct.
to guide us in this matter.
My question to Sir, Shekhar Sir, is then, are we prepared to adopt these most advanced technologies which are coming, and every day these are keeping upgrading? So, and if yes, then are there any risks which you see on above adaptation? How do we mitigate any of such risks on the facades?
Hello. So when you refer to facade, I think you're largely talking about glass.
Glass and the outer skin, the outer envelope.
So the outer envelopes, of course, when we speak of facades, we're talking about cladding systems on the outer envelope. Outer envelopes can also be purely plaster paint with texture paint, right? So every time you begin to clad a structure, you are exposing the structure to various dynamic forces of external elements, which then have to be dealt with, because each cladding has its own inherent properties which will deteriorate with time. Keeping that in mind, I think all of the development manufacturers' research systems have continuously strived to try to bring in a better product, try and improve its efficacies towards changing environment, changing bylaws, changing requirements of society. So I think each of this material that we have, whether it's glass, whether it's metal, whether it is clay, whether it is laminate boards, I think they have continuously strived to improve their inherent qualities. And together with that is the bracing system that attaches itself to the main structure. So I'm seeing that there is a continuous evolution of all of these materials that come in terms of their weight, in terms of their ability to withstand external forces. And since your question was how safe are they, I think every product that's coming into the market today has been time tested. It is going through certain very rigorous.
So we are prepared to adopt the new technologies.
Yes, absolutely.
So
absolutely.
we are open to ideas. So how do you see that, sir? And how when the project is there, how do you strike a right balance between innovation, the new product, the new technology? How do you adapt that when it comes to facades, probably?
Yeah, which is what I was trying to say. So if we are referring to facades, really it's about the negative positive. The negatives being the glazing and the positives being the dead wall cladding.
The daylight.
The daylight. No, the daylight is to do with the glass. So glass manufacturers and glass technology itself has taken several leaps and bounds in terms of improving the efficacy of the glass, improving its relationship with the environment, with relationship with the light penetration, with the heat penetration and all of that. As far as the other external treatments are concerned, today we have buildings which require a lot of controlled climates within the system, and therefore you have louvered facades, you have aesthetically treated facades. And a lot of buildings you have simple treatments like either they are stone or they are metal. And each of these developments in these facades is coming in the combination. I'm not talking about aesthetics. I'm just talking purely about technology that has to evolve.
Technology, correct. So my question to Nirmalji is that when you are adapting and when we are in a continuous phase of adopting new technologies, new innovations every day, what is your expectation from the facade consultants or the architects, or as an architect, what are your expectations out of them?
Hello.
To get the most value when we talk about that, how do you get the most value and what are your expectations?
We normally start the design process with a kickoff meeting with the client first, actually. We really want to understand what are the development objectives, what is the feasibility study, what kind of financial pro forma they are looking at the building as such. There is, among architects, we have absolutely no shortage of creative ideas and looking at things to use in a very innovative manner. Once we understand that, then I think that's where, before we put any line on the paper, we start working with a facade consultant, and we start exploring the ideas as to what is the availability in the market for the different kind of facade system that we are looking at. And that feedback is so important to us, actually, because certainly we are not going to propose a facade system which is way out of our reach to begin with. We really need to understand that. And we, and the facade consultants we are working with, they have been very kind. They've shared with us the kind of systems which are available, their approximate cost impact on the project. And that really gets the design process started. And we begin to look at the different type of building design, the creative design, and how our design can be supported by different kind of options as far as exterior envelope is concerned. So what we are looking for from the facade consultant is to really participate with us in the design process itself. We don't want to design something and hand it to the facade consultant and say that, guys, go ahead and put the skin.
How more value is added to the whole facade, and the whole process is what we are talking about.
And our design, actually we are looking for the facade consultant to be partner in the creation of that design.
Absolutely so.
And nowadays, with the kind of innovation which are there in facade design or exterior envelope design, the options are really limitless. I mean, what we can do with materials, with lighting, with the energy efficiency, ventilated facades, and I mean, the sky is the limit actually.
Absolutely.
And so we want to make sure is that our design is in alignment with the reality of the project. Certainly, we are looking at something that the client would buy in, and it would be appropriate for that project. I mean, the list of things that we expect, and facade consultants who work with us, they're very acutely aware that we are very demanding from that perspective, because we see them as a design partner.
So more and more value addition you expect from them, how to adapt to that. So when we talk about value engineering, this is the most common word nowadays used in everything, in every process, value engineering. So value engineering or value extortion, how do you, is it cost reduction or diminished value?
Okay.
So my question to Sam is value engineering a systematic process or approach aimed at arrive desired function? Is it a process, system, service without any way affecting quality, reliability? What role does it play in today's market scenario? Because I'm sure you must be getting the most requirements that how do we do value? How do we add value?
First of all, good evening to everyone. I'm I'm delighted to see everyone in person after so long. I have to thank Zak for giving us this opportunity. It's almost being 18, 19 months, very restricted travel. I think we are now back to normal mode. I'm very happy to that. Kamleshji, I think coming back to your question, I think you've got 2 or 3 part of questions in your, it's a long sentence. Okay. In the morning, Gautamji has really made it very clear. There is no value engineering. Value engineering always done at the time of design stage, specification set. It is a cost analysis. We've been taken this value engineering into a different context. As a cost analysis, he was very, very clearly explaining how the things are done. You go with option 1, option 2, option 3. Each component has, for every value, you got a cost. Now, each cost as a value, behind that value, you have a performance, you have a durability, you have a quality, and functions. What is common between any value of a material? It's a functions. Now, what are the other ticks you want to have? It is a choice of the client. It is all the stakeholders have to decide. So I really say that, when somebody is saying that, I can meet these specifications, these functions, this durability, quality, all comes at this price, when there is somebody is giving it a very high price, I think then it is something wrong in our material itself. So this is the very important point people have to do. So whatever done after a post-contract or even tender, it cannot be a value engineering because the specification set by a client, then it is a cost controlling. It is a tender process, and you are analyzing your cost based on open tender.
So
It
Robin-
can never be a value engineering. So,
Correct.
because the value engineering word, if you see globally in our industry, even in the management, it is a cost analysis.
So as you rightly said, so question to Vijay is that, so that means what we understand, so is value engineering, there is a myth in value engineering that it's a glorified suggestion, as Robin said that it has to be cost analysis and not about value engineering. So are we talking about, is value engineering a myth or value engineering adds real value to it? How do you look at it?
So good evening, everyone. Yes, so continuation to his discussion, I would put it, it's not a myth anymore. Like previously it was a myth, but today, in today's scenario, it is no more a myth.
But as Robin said, it has to come before the design, before the specs.
Yes.
So if there is anything which is after the design and after the spec, then is it a myth, or are we now trying to squeeze things more out of it?
So as a process, what we are doing or modernizing it right now is the value engineering part becomes a part of the design process. It's no more a part in the later part of it. And today, like all the stakeholders have to be part of the project. So earlier the trend was, it was a value engineering for one entity, and the other entity used to understand it as a failure of design. So today it's more like it's all together, working together, and it's normally done in the design phase. That would what I would suggest for. Also, value engineering, I would say it is a process. It is not a one-day workshop where you do a value engineering. So it's a process which happens during the project life cycle, and also some detailing which normally happens in the project execution phase. That also adds to the part of the value engineering. So I would not say it's a design fault or the design incapability of closing detailing, but it's basically a value engineering which has happened in the process of execution.
So according to you, that's a continuous process.
It's a continuous process.
It's a continuous process or a journey. As you keep on going, you keep on adding things, you improve yourself. So are we saying that this process, the question is whether we should have this before or whether we should have it afterwards?
Before is obviously the obvious requirement, and today the trends have changed, the technology is inbuilt, so more of the value engineering happens today. So like budgets are defined earlier, and what best value engineering can help, the material selection. So that is predefined today earlier. Even the process of planning is where you have everything detailed out, and during the execution is just implementation of the work.
So sir, the question is that this journey of value engineering, there is a design which is done, there is a design which is already in place, and then it comes back to you with this statement of value engineering. How do you see it? Whether you see it as some shortcut somewhere, or is there anything, compromising anything? How do you see it, and how do you balance that value engineering?
So value engineering can be in different shapes and sizes. Actually, it stems out of a client-architect relationship. It also stems primarily out of a budget. Because value engineering only comes into play when there's a budget. If there is no budget, there is no value engineering, right? So it's very specific to a project. It's very specific to a development that you're doing, whichever the developer may be. So his value engineering principles will differ when he is doing a hospital, a school, or a hotel, or a residential building. It will also differ from market to market conditions.
Location and the project.
And the location and project. So I mean, you could have a building which is being clad in stone and glass, and you could have the same building being converted into plaster paint. We have examples of very good plaster paint buildings, high quality hotels sitting in the city of Bombay, and demanding better prices than ones which are clad in steel and glass. So it is actually a function of how you are treating the project. And since we are talking about facades only, therefore I'm restricting myself to a conversation on facades and not getting into the rest of it.
The whole topic is about facades and how do we really adapt to the innovations. And while adapting to the innovations, how do we bring this value, so-called value in value engineering? Is the question.
But you've already simplified it into making it into a unitized system, right? So everything here is unitized. So beyond the point, what are you going to do? You're going to see a glass and then try to. So the value engineering is going to come out of what glass do you want to use? You want to use a low E glass. You want to use a glass with better VLT, with lower VLT, I mean, everything here is going to be a function of how it is going to relate to the end
We
customer.
see in some other part of the world, we see that, the contractor or the facade contractor is as early on the board, as early as the conception of the project itself. We are still not in that stage over here.
No, it's not that. It's not that. So let me give you a personal experience of myself. I mean, we decide to use a building, we decide to treat it in stone. Okay, so the client says, so sorry, I can't afford granite. Why? Because granite itself is very expensive. You're going to tell me to use 30 mm granite, and then the backing system is going to be that much heavier. So okay, that goes out. Then we convert stone into metal cladding, which is full metal cladding in 5 mm or thick and 4 mm aluminum. He finds that expensive. Then you go into making your what do you call your standard ACP cladding. So standard ACP cladding also, after a point he says, no, I don't want to use the fire rated cladding, let's use the non-fire rated cladding. So value engineering can go down, it can slide you down into zero.
But whether that should be the process or the process should be other way around, rather than reducing like this, going from a fire rated to a non-fire rated, let's not put it onto the building.
So Kamlesh, I will like to add in this is that I think the design brief at the initial phase of the project is very important. So that's where you crystal out the requirements of the client, as well as also you understand what they are looking forward. Obviously budgets happen and then there is a change in the specs which may come up. But this client brief I think would be a primary part.
How many clients really understand what a brief is supposed to be with respect to? ये बहुत अच्छा लग रहा है, ये लगा दे. And when you start coming down, you realize, boss, I can't afford it. Then you say, you fire rated, nikal, non-fire rated. I have known clients who've told me, boss, if it is aluminum cladding, let's bring the 4 mm down to 2 mm. And then it starts waving. So who are you going to stop and at what point are you going to stop?
There will be exceptional clients,
the client, there is, firstly you need to educate the client.
Educate them.
Okay. Only then can this value engineering come into place.
Yes, Robin.
This is what I said, the functions is same. When he says the granite or the aluminum solid sheet, ACP, fire rated or non-fire rated, finally it is going to clad the wall. The function is same, but what is required by the client, this is the problem. I think maybe the understanding of our clients and the safety requirement or the importance of what all the material has to be there with a proper budget. This is where the cost analysis comes. So I can't give a non-fire rated ACP cladding just taking a fire rated specifications. It cannot be. So this is where I think we need to be very clear. And sometime I think also the cost analysis, it does not come to a particular facade only for a building. He was really pointed out very clearly, he made us steps. It is not only facade, there are so many other things, superstructure, substructure, tiles. So it has to be a holistic rather than, just a product of one product you pick and then you do a cost analysis or something, then you will end up in getting only a functions, not the other things. So this is where we need to be very, very important. Manage.
So you want to say something?
Yes, and that's why I made the comment that at the kickoff meeting itself, we need to define goals and objectives and the budget of the project. And the budget should be achievable budget, not an abstract budget which cannot be achieved as such. Once we know the budget, what is the budget of the project, we can show them the options as such. If the client continues, starts with granite and goes down to non-fire rated ACP, that means, to me, that is change of design brief to begin with. And the other thing is that as the design evolves from schematic design to design development to construction documents, there needs to be a budget validation, and the client needs to sign off at each milestone to say that, yes, I'm happy with this budget, I'm happy with this design, so that we can go on to the next stage. If everything is done right, there shouldn't be any need for value engineering to begin with, because value engineering by itself, it's synonymous with compromise. We don't want to do the compromise on our design. We don't want to do compromise on the client's goals and objectives. So once they are defined properly, then I think the process should go very smoothly as such.
So the fundamental foundation of design brief budget has to be very, very strong to achieve a desired architecture or achieve a required thing.
Yeah, I'll just like to add to that, in continuation to what has been said. One is, I think we are mistaken, that's my thought process, like when in the initial stages at the design brief stage, that should be options. It should not be a value engineering part. Those are the options which are being put up. And it gives the liberty to the client with thorough knowledge imparted by the architects and more importantly by the facade consultants. Because we are solely, as a client, we are solely relying on the skill of the facade consultant. That is where it comes. So that is all options to be given it. So let us not put it there as value engineering. Because value engineering, as you said, later on when it becomes an extortion, or I would say it's not an extortion, it's a compulsion. Because when you look at the budget part of it, then you start feeling what you want to do it, and then you start going down. Very rarely have we seen that in a value engineering. So one is, the first part is that as you do it prior, that's the options, and once the option is selected, tenders are done. And when we finalize the contract, then we find that it's not fitting into the budget. Then you start looking at the compulsion aspect of it. And once you look at the compulsion aspect, that's where the real thing has to come back. So I would suggest, as a consultant on board, this option should come in much before, and we should not reach that compulsion stage. So that's where we are somewhere, always fighting. And it comes at a later stage when it becomes, now take it or leave it. Or either you jack up your budget or you take it what is available in that. So that is where the thing needs to be plugged properly. And then later on, during the, as somebody said, post-award of contract, of course, that's a value engineering, that's a situational part of it. So let's keep that part. But it's something which is only mainly out of compulsion,
so
and
now,
not
so
by
now
choice.
coming to that whole process, now at least we have evolved to that situation where projects have facade consultants, experts on a very early stage, which was not the case a few years back. So that's a really good thing happening, wherein you really know whether it is achievable, it is not achievable, to the desired intent. Where it is very, very important. Whatever you design, whether it is achievable in terms of practicality or not, is what we are talking about. How much role can a facade contractor play in this design brief stage? And do you think it is important that he should play a role in that? Please.
So one of the things which are evolving these days is a process called design assist. So there are, globally I've practiced in other parts of the world where I've used this process is design assist, in which the facade consultant and a potential pre-qualified facade contractor can team up and say that, guys, with this budget, with this design objective, with this kind of look and feel, with this technology, these are the 3, 4, 5 options as such. And so that what happens is that they own that design, they own that budget in a metaphoric way as such, so that when the design is completed, everybody knows what they are going into, everybody is comfortable with that, and there are no compromises to be had at the end of the construction document process.
So good point you touch base is design assist. This is something new for this part of the world. This is very common when we see in projects in US. There is a design assist process which is there where the fabricator is on board. And with design assist, it is not necessary that it's not a commitment to the fabricator at that stage, but it's all probability, understanding the whole design intent and adding value to the whole situation. As Robin, you said that, now the world is open, we are meeting, we are discussing. My question to Shikhare sir is, sir, how do you deal in this current COVID crisis? Suddenly when the whole thing disrupts, the routines are disturbed, and in order to thrive in times of uncertainty, what are the improvisations that you look into facade? Is there anything that you think now that suddenly, we look about residentials, we hear that earlier they used to be 2 BHK, now they have been transformed to 2.5 BHK with half BHK as a work or office or something. Do you see something from the facade point of view?
On the facades, actually no. I haven't seen any sort of variation in whatever facades we are trying to put up. There was a knee-jerk reaction to suggesting let us have more balconies and let us keep more open window systems and stuff like that. But that is possible in a different typology of buildings. If you're doing a high-rise which is 40, 50 stories high, that's not possible. And I don't think any building system or any facade system has adapted itself to the COVID conditions. I'm not seeing anything like that. No. Not in my practice at least.
So how do you improvise? You know, how do we, is there a scope of improvise, or we remain as is, where is?
But what scope are you looking for? I mean, I haven't
as you rightly
your
said,
question.
air or balconies or something, as you rightly said.
But these are functions of sale and leasing. I mean, you can create a balcony. Balconies are still being created. I don't think they have gone away. But I don't think COVID has played any part in terms of a facade treatment change as far as buildings are concerned.
Okay.
Because air conditioning systems are going to determine how your facade is, right? It's not
correct. Question to Nirmal sir is, how will you improvise the facade for the future, which will catalyze the process proactively, like trying new things in an attempt to anticipate what could happen?
Well,
for example, we didn't know COVID will happen. You know, suddenly it has happened. So,
well, things which we are looking at in facade. I mean, you know, the technology evolution is faster than it has ever been in our lifetime. So, the innovations that we are seeing in last 5 years are far greater than what they were in previous 5 or 10 years as such. But the future trends are actually that there is a greater need for energy efficiency, and facade systems will continue.
Energy efficiency. Okay.
There is a movement towards net zero or carbon neutral buildings as such. We are looking at facade systems to be embedded with photovoltaic matrix actually, so that they become a source of power to the buildings. We are looking at facade system to be embedded with transparent LEDs, so that they become part of lighting, they become part of embedded video screens as such. And this is happening in major urban centers, not necessarily in suburban areas also. And in addition to that, we are looking at evolution of kinetic facade. These are the things which will be driven by the state of technology as such. They started out about 10 or 12 years ago, and then they stopped for a while. But we are seeing that in last 3-4 years, that push for innovation in curtain wall design has really intensified quite a bit.
So coming back, you want to add something?
Yeah, I just want to add is that also there is innovation being planned on solar panels.
Solar panels.
Solar integration of solar panels. Photovoltaic. And also I think the video wall concept, that is primarily being looked into few of our recent projects also. So that kind of new innovations are being looked for. And there is
the whole topic about how do we march ahead with the world going together. You know, what are the new technology, whether we are ready for the future, how do we adapt the whole situation, you know. So my next question to Sam is, you know, now that we understand that being a system company, and now that we understand that Hydro is producing a lot of aluminum extrusions in India, as Arvind mentioned, we saw about the Sarkal and all these things. What kind of value addition it can be done? When we talk, you know, people want to understand more and more how they can use more about, you know, systems and how they can help, you know, when we talk about fixing a value or, you know, fixing the cost, because now you've been doing it for years together. So how that you feel that it would help the industry, that by using a system, you are really coming.
It's really, I think Nirmal sir said that, you know, when the project is there in the design stage, we do have a design assist. This is what we say, the pre-sale time without commitment. And when there are sometimes we work with our facade consultant to the architect to the client, and we sign an agreement, we just do that, and we understand the situations from the day one, what is the client requirement. This is what I think in Arvind presentations, he has shown one tower in Dubai, which is you know, designed and built. And from the day one, it was worked along with all the stakeholders, and what is the requirement, and including the per day panel erection. And because there was no space for them to do the panel, you know, so this is all the things we do as a system companies from the day one. And then also, like, it is not that like only when we do a system, of course, we've been present in many countries. We have different knowledges. And when we bring that knowledge to a local adaptation, we say glocal. It is not a global, it's a glocal. So we understand the local needs, and we come up with one another system, which is the 65 ml, which is very, instead of stick curtain wall, we just converted that one to a unitized curtain wall, almost similar range to the stick curtain wall prices. Whereas, you will get a much better quality, more clean, easy to install, that type of product. It is adapted only for India. We are not promoting in any other place. It was just came in last 1 year time here. So this type of things we come up with. And of course, as in the sustainable front, we are all have to work for our future generation. And each one, even myself and every panelist here, they may agree with me that, it is our responsibility to leave them live peacefully. So it is our future. We need to work towards. Today we are not, when we say that sustainable, it is not a recycled aluminum only. I think the first step in the fenestrations, we need to look for the polyamide, the thermal break. Of course, the heat transmittance will be less. It also gives less, acoustic, gives better. So these are the added advantage also it gives. Now, as you said, that COVID has changed some people to work from the home as an office. So you mean acoustic is maybe a better important role to play. So probably the normal slider in a window, in a hall, or in the slider, even though it works better, maybe it is going to come more and more in a skyline where there is no noise should come. Because if I am attending a meeting, I should avoid that noise. So these are the things it will come over the period. Maybe it may come as a requirement, and we are up to that challenge. I think we really want to work with all the seniors here. They are there, and we support them. And as a metal builder, all the metal builders, we want to support our technology, and we can do it here itself. So it is the main thing. Yeah.
So how do you see the current scenario after COVID? The short supply situation which has been created, the demand supply situation which has been created, and suddenly we did all value engineering, we did all the brief, we did all the project, we did all the costing, suddenly came in COVID, and suddenly now after COVID there has been the dam has just burst, and there is a short supply, there's a demand supply gap which has come. So how do you see that, and what are the challenges in those things in the current scenario?
I'm not an astrologist. I don't know how long.
Because see, we all spoke about brief, we all spoke about design, we all spoke about cost, and then this certain uncertainty has come now, suddenly, which is all value engineering has gone,
Yeah, can I answer this?
Please.
In fact, we are facing the brunt for this because, as you rightly said, supply chain, because that's our main
touching
part.
a very sensitive
very
chord,
sensitive.
But I think, we all spoke about a lot, we did the whole theory, but when we came to practical, the entire value has now eroded now, So how do we cope up with that? So are we doing 75 stories, so are we reducing 4 stories down and making only 70 now, or we still make 75?
No, we have to continue with whatever we have promised, because all the projects have been sold, and with RERA and all that coming in, there's no change in that.
So one very good thing, sorry to interrupt you, but one very good thing you told us that, now the properties have been sold. So let's say if they have sold at 10,000 rupees to 10 customers out of 100, so the 90 still are there where you are going to sell it at higher value is what we are looking at. So the contractor, the contractor is the guy, or the developer is the guy, because now he is already committed to it. How do you balance that whole situation?
That's what I'm coming to. See, again, the beauty of it, or it's a, you would say it's a situation in which if you are working for a government client or working for a private client, that's where the difference lies. Even in the government, they know that the prices have increased, escalation is there in the thing, but that doesn't take care of the actual escalation which has happened. So, and they are bound by the CVC guidelines. So that nothing is going to happen, the contractor has to live with the fate. Whereas if the contractor is working with a private sector also has to see at which stage of the project, what is the current scenario, where we are we nearing completion? So we have to went and provide them rates. Since January, this is the only thing which we are doing. We are doing escalation of contractors, evaluating that. Prices have shot up by 30 to 40%. So this is the thing which is, you can't do it. And most of them whom I have spoken to them, they are facing the problem of ocean freight, which has gone up, I think, by more than 10 to 12 times. So which is, you know, even if they were willing to supply us at the previous rate, they can't, because their dependability is for getting the material from abroad. Once the material is available, only thing is the sea thing is not happening properly and the price is
How do you see it now more? You know, we are hearing about the coal shortage, we are talking about energy, we are talking about China becoming an importer. Do you see now more shortcomings coming in the future? Are we prepared for it? Or how do we prepare it?
I think with Make in India, things moving around, if it falls in place, and then slowly we are gearing up, but it will take a time. This is in fact a transition period. As you rightly said, COVID was not expected. It is most unprecedented. It has taught us so many things. Then this Atmanirbhar initiative came up. Things are happening, but it will take time. As it matures, it will happen.
Any
Till
case
that time, we have to face the world.
any case that has come to you, sir, that now that because of the supply, demand, the costs have gone up, so do you need to change the design or intent, something? Anything? Has it gone back to the drawing board any day because of this?
So, I mean, yes, the projects have been affected.
Wow.
So we had to take a look at the budget in terms of what we need to do. To me, that is a perfect example of value engineering.
Yes. I was just coming back to the whole thing. How theory and practical.
So there are cases as such, but you know, my firm, we do both design and construction of buildings actually. So in what we are looking at is that our whole concept of supply chain has changed now, because things that we used to tender out, let's say 2 years out, we are no longer doing that. And we are convincing the clients to take a look at that rather than hard bid of the projects. We look at cost plus model to say that, Mr. Client, if the prices go down, then you get to keep that money. But if the prices go up, you are the owner of the project. The risk is really yours. It is not the contractor's risk. It is not architect's risk. It is yours. Some of the clients have accepted that concept as such. We think that, you know, with COVID, what had happened is it has taught the world that we all cannot just depend on China as the supplier for the world. That means most companies are looking at alternate locations for the supply of products actually. We think that it's a matter of time that the world would stabilize, that it would learn to not count 100% on China, but look at other locations also. And it's a matter of time that it would stabilize. And I think the problem of supply chain is really because of what happened with China's participation in the global economy.
Sir, you would like to say something on this?
So my experiences on these are absolutely to the contrary. I have actually seen most of my clients wanting to double up on their facade systems, on their treatments of their buildings, and be that much more with a competitive edge with their other people, with their colleagues. And no, I mean, there was a bit of a lull last year in terms of projects going slow or project halted because of government restrictions, but none of the projects, whether residential or commercial, have come down on their facades or saying that let's try and make granite into aluminum and aluminum into ACP. No, not because of COVID at all. I think they are actually on a hyperdrive in terms of wanting to take 70 stories to 80 stories,
yes,
and stuff like that. But no, it's not going, not in my practice.
So going towards that, resolving this problem is what we said is use more about made in India, make in India is what we are talking about. So when you talk about that, the first thing it starts is with the specifications. So are we really prepared to take this, some of the make in India or made in India into the specs? Because we still see specs which have products which are not made in India and which are not make in India. How do we set up this process
more dynamic, to make it more in India and made in India?
But I'll give you an example not related to facades, but I'm facing it all the time. I mean, I've just come out of a meeting where we have no option but to go into making PT beams, because India does not manufacture a certain typology of steel beams. It doesn't make it. You have to either import it from some country outside, or then give it up and accept a different workability for the design. So we want a beam which is about 600 mm deep, and we need to import it from Japan. We can't do it.
Wow.
So, but this is the reality of the Indian market. So either we require our manufacturers to gear up to what the international competition is all about. So when we do make in India, I think we also have to up our ante in terms of developing something that is going to stand a competitive edge.
Absolutely, you said it. But I'm saying,
and the same will go for facade systems. I mean, I'm just using an example of the building construction industry, and I'm sure you guys are also facing it somewhere.
Because
I mean,
I see it as Hydro has started manufacturing over here. They have dyes over here. So we really don't have to rely about getting everything from outside.
Shapurji is the contractor for the same company for the project I'm talking to you about. So it's going to happen.
So the whole idea is, how do we make use of more and more products made in India? The idea.
See, as Sir said, that I think it's not all the product we could do it now at the moment with the limited resources. There are something like in our process, in our supplies, almost 65 to 70%, or you can say even 75%, if it is fully facade only, almost 80% locally we are able to source it.
Yeah.
Because what we have done that, we have trained our suppliers, we have done the quality assurance checks, so they are in par with the European or the other standard things. But still there are some fittings when it comes to the doors and windows and these things, it is imported, and this is where the things are.
But probably we are talking about 10-20%, 80% if you are doing it. So
10-20%. I beg to differ here. I mean, I'm just talking about glass. I don't want to take the names of the companies. But again, very clearly, glass manufacturers which are not out of India are definitely have a better quality of glass that's coming out. Okay. And so what does a developer do? What does the end user do? Use an Indian product?
The idea here is, what we are talking is about how do we upgrade ourselves, and this is, and that is where to the audience and to the people, that if we have to match up to the supplies and to the standards, we need to improve our quality levels, we need to improve about innovation, and we need to get more ahead of time if we have to make use of made in India and make in India. Yeah. So thank you so much, gentlemen. It was really nice talking to you. There's a lot of ideas that has come. Now it is open for the audience. If there are any questions to any panelist, quickly we will take one or two questions. Anybody?
Hello. Good evening, gents. I would like to thank Zak for this outstanding podium here. My question is a general question. The thing is that we talked about past, we talked about present, but not about future. As we know that IPCC report says that we can't go back what climate change we have done. So my question to you is, in near future or in future, do you have any advice as an industry leader that we can adopt or to walk on the path that we can take towards low carbon, zero carbon, or net zero buildings? Thank you.
Would you like to answer this?
I kind of answered that question. I mean, we, as architects, I mean, we are already, this is whether the building is LEED certified or not. I mean, all designs that we are to do, sustainability should be a foundation for that to begin with. There are products coming out in the market which would, the curtain wall, the facade system would be solar facade system, means they would generate power. We are looking at also, there's a concept of embedded carbon neutral buildings as such, in which we are calculating the material that has gone into manufacturing that system, is that how much carbon was used in that. We're also looking at, what is the energy efficiency of the facade system. Not, and I'm including the exterior envelope, not just glass, because the facade is a lot more than just glass as such. And one of the things that we are, in addition to taking a look at Atmanirbhar, make in India, we also need to explore the possibility of using local material. We're doing a project there in spite of the client, some of the people who were looking at that. This is in Kerala. We changed the facade to go to brick actually, simply because brick is a local material. And in some parts of the world, it is a premium material. In India, it is a cheaper material. So we need to change our thinking as to how we perceive different materials and use creative, understand the qualities of the material and use them in an innovative way. It doesn't have to be expensive. It just has to be used very carefully and look at that, how it would support the overall sustainability effort. Technology is changing. I mean, what we are seeing that more and more Indian companies, or they are tying up with global companies to have that technology to really produce world-class products as such, which is very encouraging. So these are the things to come. As those who design profession, I think if the product is not available, talk to the vendors and say that, guys, this is what we are thinking. Can you manufacture that? Can you fabricate that with us? I haven't had a fabricator or people who are in this business turn us down to say, well, they are really inspired by us giving them some proposal to say that this is what we are trying to do. So I think this is what we need to do as far as the design professionals are concerned. Hope that answers your question.
Thank you. Thank you so much,
Thank you,
gentlemen. We really appreciate your time. Thank you so much. Thank you.
I have a very quick question. I'm sorry, I know this is running late.
Yeah.
I'm just sort of taken aback by the discussion we had in the first half on value engineering. And if you split this on, and let's limit this only to facades. If you split this between form and function, and say there is a certain form that is intended, and there's a certain function which cannot be compromised, obviously, because it treads on the borders of having a safe facade from a fire perspective or from a structural perspective. You value engineer form, that's fine. That's going to spoil the image of the building or compromise the image of the building. Compromise is a better word. But if you value engineer the function, and I heard this saying that a fire-rated aluminum composite panel is replaced by a non-fire-rated aluminum composite panel because it's cheaper. And if something happens, is it individual liability that rests with the contractor or the architect or the developer, or it's a collective responsibility if something wrong happens there?
If I was the architect, I would decline.
You would decline?
Yes.
Okay.
So would I.
Because it's a matter of life safety, guys. Just because of the money, cannot take risks with life safety.
Absolutely.
So I think safety is one of the parameters which is there in any project.
Non-negotiable.
Yeah, non-negotiable.
Non-negotiable. Good to hear that. Absolutely. Good to hear that. Thank you.
Thank you so much. Thank you, sir.
Thank you so much. It's been a pleasure. Thanks. You're leaving? You're staying? Okay. So thank you all the panelists for that very. Oh, there's a photo up. And while they do that, I would request our next presenter, Nithin Hosabettu, who's a design director at IMK Architects. There he is. He will speak on designing the Symbiosis University Hospital and Research Center. That's one particular case study. Blending biophilic spaces with naturally produced SEB from site and energy efficiency, and the design principles for creating healing spaces. So you are all set, I think. Thank you. It's been great.
Good point. Yeah.
Hi, good evening, everybody. I think we are running out of time, and I will try and make it quick. I would like to thank Zak to, they switched my presentation with this panel discussion. Now, why I would like to thank you is that the discussion, that point that was discussed in the panel meeting was that has COVID made a difference in execution? Like, the materials are not available, and what about Make in India and things like that. So my presentation is what I would like to say, instead of making in India, I would like to say a partial solution is make it on site. That is what our project is all about. So I'll just run you through the overall proposal first to make you understand how the project is, and then I'll talk about the material. So this is a Symbiosis University Hospital and Research Center project. Now, this is very dear to our team, to me. We have spent a lot of time detailing out this entire project and put in a lot of personal effort to get this executed the way we wanted it. So initially, this is a hospital of 215 beds and approximately an area of 4.5 lakh square feet. Now, we went about designing this project like the entire hospital is based on certain, I'll talk about the planning part. If you see this part, so that's how we have created an envelope around green space. So everywhere we have tried to emphasize on biophilic spaces, and we have designed the building around these green spaces. So first part is how to have natural ventilation within the hospital. So I'll come to the facade, but I'm just giving you a basic brief. So everywhere, right from the central courtyard, from all the 4 sides, we have seen to it that there is a green space or a garden or some kind of a terrace garden or a courtyard where people can look into. Because we are dealing with hospital, we are dealing with an environment, we are creating an environment which is stressful. So how to calm them down? That was the idea, and that's how we designed the envelope of this building. So if you see in this, it's like everywhere, wherever we highlighted is green, so that's where people like to give you, people will try and see the green spaces, and that will reduce the stress or anxiety for any stressful relative or patient. So that's the idea, that how we developed these green notches within the building mass and kept everything very simple. And also the central courtyard not only brings in a biophilic space, but also creates a sense of understanding of the space and reduces the complication of a hospital. Like, when you go to a hospital, there are only corridors. You don't know where to go. You've been told to go to an MRI or a radiology section. You have to find out in a road map or on a wall where is how it is. Like, but here, you come to the courtyard and you can tell him, okay, ground floor over there, that's the MRI, that's the radiology section. So everybody who comes in, it becomes very easy to orient themselves. So this is thought from the stories that we thought about patients, what patients will think about, what relatives will think about. So this is the overall concept. I can go on this, but I'll just go ahead. So this is what we created. This we created out of the soil from site. So this is called compressed stabilized earth blocks. This we have made bricks on site with laborers using 2 molds, 3,000 bricks a day, and every facade that we created, we have tried to add kind of an element in design. We have tried to make these boxes without support. These are individual walls. They are not cladding on the wall. We have twisted the brick to get that shape. The concept was to create shimmering effect. When the sun falls on these surfaces, every panel are twisted in different angles. So actually the photograph has not done any justice to our project. This is what I keep on telling everybody. For this project to be seen on site is the best thing to be done. In fact, we have some contractors here who have worked on it, and they will be able to talk about it much more clearer. So here, so this is one of the photographs. This is the other one. So what here we have tried to do is kept the design very simple. We have tried to keep it very simple, the design, but at the same, why we have kept it simple? First part is that, you know, when a patient comes in, when relative comes in, architectural dynamics, it doesn't matter for them to get treated, but then subconsciously, somewhere, you know that you are entering, if you are entering into a good place, subconsciously somewhere you feel that, you know, okay, I've come to a place where people know things, and you know, maybe I'll get treated. Or if you go to a very posh looking, fully glass structure, and when I'm going to get inside, so maybe they'll think that it looks quite expensive, maybe bill bhi zyada hoga. So our concept was to keep it simple. The idea came up with the fact that the client always wanted a natural finish. This was initiated by Mr. Rahul Kadri, who, when he did the upper campus for Symbiosis in Lavale in 2006, so he initiated and he got this brick as a facade element, which continued in all the later buildings. So initially we thought that maybe brick is not the right thing. That was a discussion within the team that, you know, maybe the fungus may grow or something, but then we studied what we had done. There was no issues with it. Plus, what we did is we figured out that we coated this with a nanotechnology solution, which impermeates to 10 mm, so that the bricks can breathe. At the same time, it will not allow any water to settle. And that's how we get the color. It's a transparent coating, and that's how it gets maintained. So we got a natural effect. We got it from the site soil, and rest is all. I'll come to how we did the boxing and all, but I'll just run through all the other images. So this is the entrance canopy, and if you see this entrance canopy, this is nearly 80 meters in length and 25 meters in depth. And the idea was that one, it needed to be grand because the client wanted a grand entrance. Second is that when patients' relatives are standing, if they are not supposed to stand inside, they are supposed to stand outside. So it gives you a good depth. It shades you. There's a lot of space. They can stand in a relaxing mode. 3 to 4 cars can park below in layers, I'm talking about. So it's like an airport canopy. So that kind of shape and size this is. And it also gives you some kind of an assurance in terms of proportions and size. The angle is tilted so that, you know, it looks a little welcoming. At the same time, the angle, because of the tilt angle, which is a terrace garden on the top, the upper areas, the first floor, where the single rooms and the twin rooms are, they open up into these gardens, so they can see greenery every time. That was the concept for this entrance. This is an entrance of the same building. This is a skill center, because this building is not only a hospital, but 2 floors above this is a skill center. So the client wanted a separate entrance for this skill center, because they did not want that one entrance hospital and skill center, because patients should not feel that, you know, you have been treated by doctors who are learning. The idea was the doctors definitely won't practice on them, but yes, the skill center would create opportunity for them to learn. So the skill center that we are having here would be the studies what the doctors go after MBBS when they do post studies. So they used to go abroad. So these kind of high-end studies will be done here in this institute. So the client wanted a very grand entrance, and we had made some 11 options for this. Ultimately, the concept for this one was we thought that doctors use stainless steel as their apparatus to do surgery or to operate on patients. So that was the concept, and how it is related. The stainless steel is used as a material to express the technology, like how this is an expression of new technology or into the future. That is why we use this material. Definitely the shape was a big challenge, and how we executed this is a secondary part to it. This is the third image which I was talking about, the courtyard. This is the courtyard that we have done in the hospital. So how we have done this courtyard, and how in hospital what happens is green spaces are not allowed in terms of any microorganism growth or anything that can create some sterile, non-sterile environment. So what we have done here is, first of all, they are all shrubs. There are no lawns. You're not supposed to maintain the lawns. Secondly, what we have also done is that the patients, the users will not walk through the green space. They will walk through the paved area, so there is no soil, dirty soil that comes into the courtyard. From the courtyard, it comes into the hospital. So everywhere, all these detailings we have thought about, and how we have merged. Now, initially this was supposed to be a concrete texture, and then we decided, no, we'll go with the sand kind of a shade to give it more earthy look. So everything looks very natural, and when it looks natural, it settles down. It doesn't hit the eye, and that suits a user. That was the entire concept behind this. This is how the courtyard looks from the other side. So this entire courtyard is adorned with the corridor. So what happens is that you relate to your position with terms of corridor, because maybe half of the patients are not educated and they'll not be able to understand. So this is how we thought how to make it more user friendly. This is the one of the main facade. I'll explain this how we had done this, but this is the main facade boxing, and like you see the upper two, it's like approximately 5 meters, and how in certain areas it is cantilevered out, which would be there in certain images. It's not then. You see the right one on the top, third one, it's cantilevered out. Now, over in the images it may not look, but actually the difference of cantilever is nearly 2 to 3 feet. And achieving this in brick is very difficult, and we did a lot of permutation combinations, and how we talked to many technical knowledgeful of people who have worked on bricks, and how to come up with this kind of a shape, and how this shape will help in creating that effect that we want, and how to have not that monotonous feel, but to keep on changing it to get that multifaceted look. So there's a lot of options that we did. It broke and it did not get executed correctly. Then again we tried, and how we did the pointing. Even the pointing was not coming very clean. So when you look at it very closely, at that time you'll understand how this actually looks. So this is an image which I don't like. Basically, if you see every side, there is so this on the left hand side is the terrace garden, but on the right hand side also there was a green space which the service consultant took over. So I always have that problem that the green space is all gone, because he had to put in the oxygen bullet and things and the other service requirements. So this is one more typology of jali that we created with bricks, and these fins are actually 75 to 100 mm in thick. And the contractor, when he executed and sent me the photograph, I asked him to break everything, because when I stood down, it was like a snake. They were not able to do it. So many places we asked them to cut it, And actually, I wanted exposed concrete. We initially figured out to do it in exposed concrete. Then we ultimately put that sand texture to get that natural effect. So many places we had to break it, but keep that thing very thin, and also the vertical members, the slab areas also very thin to get the proportions. And how we manage this boxing, they are all brick, there is no support, there's only brick and nothing else. So all bricks, nearly, I think so for this building we used around 7 lakh bricks, and approximately an area of around 40,000, around 2.5-3 lakh square feet that would have been covered. So this is the other image where you see all different types of jalis. The upper one is a boxing, the second one is where the entrance canopy is over there. We have a different kind of a brick opening, and the lower two are actually basements. So where the DG set is there, where the car parking is there, and how we have managed to do a different detailing over there. So everything, when you look at it, it should look like a composition. So no modern materials, only 2 materials. One is brick and other is a regular structure. This is how it looks. So this is what I was talking about, the singly loaded corridor, where there is natural light and ventilation coming into the corridor. It's not artificially lit. People are connected to the external environment, and that makes a big difference in a hospital, and that's what we always try to do it. This itself creates that positiveness or the warmth of a space that no matter with doubly loaded corridor or with the best of lights will not be able to achieve. So this is one topic where we're talking about blending biophilic spaces. So this is a small video about CSEB. So for me not to talk about it, I think the video will see. So what you saw is that creating this CSEB bricks, so low emission of carbon, and it is locally produced. You get local masons to work on it, and handmade. You can do it on site, and the effect is quite different. Only one issue we had, that within a year some kind of a white thing that came up on the brick, and that is actually soluble salts. Which would definitely dry and come out. It will ooze out in the period of time. And when such kind of things happen, we've just scraped it out with a sandpaper, and it is done. So that essence of that rustic feel, we will never get in paint. The essence of that texture, you will only get in stone or a brick. You know that the natural, whatever is natural is just not replaceable. Any material we can put. I'm not saying that we should not go for modern facades and all. I am very much in for it. But then natural material stays, and it survives, to all the natural calamities as much as possible. So when we are designing a hospital, we don't want maintenance. The client doesn't want to keep on painting the structure. So as minimal as possible, we have tried to use paint, or we used a textured material over here, and majorly it's all bricks. So how we have done this? So this is the CSCB Jali. I think I'm done with the. I'll just quickly go through it. So this is the typology that I explained you earlier. This is how we have placed it. I'm not able to. Yeah. So this is how we have placed it, and how every panel we have done it on site to see how actually when it tilts, how it looks in the sunlight, how it looks, and then we finalized one, and then we did not repeat, but we repeated it in between. We did the moduling in between to achieve that kind of a effect. This is the other one which I was talking about, where we have that entire massing. That's a ramp. Actually, it had to be done in a very nice looking mural which never came up. I'm still awaiting that mural over there. This is the boxing that I was talking about. This is how it is tapering on sides, and then in each panel this tapering shifts. So there were at least 4 to 5 modules that we had done. And this module, what we did in projecting it inside or out, how we achieved is that around 5 mm, 6 mm twist to 1 centimeter twist. Every brick would twist slightly to come out or go in. And from the central RCC member, we have taken some rods. So they are only in between, they are just a support, but this is all just a double boxing that not only cuts down the extra heat that comes in, but also creates the multifaceted facade, and as an overhang, nearly a meter. So you have regular windows, you don't have any DGUs or things like that, anybody can operate. The idea was that, we don't want a glass box. We don't want people to get trapped in the glass box, but doctors made us lock this because, they fear that patients will jump from the rooms because of psychological problems. So what we have also done is, in many places when such kind of situations, we had to put metal railing to cover it. So in that case, what we have done is we have made it openable in case of worst, somebody has the key, and it can be accessed. But I was we were very insistent on how to use this. We wanted everything naturally open, even though it is air-conditioned building. At the same time, it should be able to open. Now, such kind of situation works very well in COVID. When we were doing OPDs, in a recent situation where my mother had to be taken to she had an orthopedic injury. So the doctor had to keep the doors open. Why? Because it is completely air conditioned, there is no windows. Our idea right from the start has been that we should try and provide windows and natural ventilation, even though it's AC. So when you do something like that, it just works in any worst kind of a situation. That's what we have followed over here also. Normal windows and no structural glazing and all. This one is this one is a laminated glass that we had taken. Okay, I'll just quickly go through the other images. This all talks about different types of jali. I think the photographs explain it a lot. These are all the different types of jali that we had done. This is energy efficiency. So as I talked about this earlier also, energy efficiency was one of the prime most idea and the story of our project and how we have done this. So one more important aspect, our facade, only 18 to 20% is glass and rest all is massing. It's not 60 to 40 ratio, it is 80 to 20% glass. So we have actually reduced this glass use, at the same time covered it, and also because the angle is tilted, so we are making use of that sun path and trying to reduce on the heat gain on the building. This is again the double skin that we all know about. Spaces like this, the corridors are natural. Okay, fine. I think I am done. If maybe I'll just quickly just talk about, not talk about, just run through it. So these are some design principles. design strategies. I think this will go on, and I'll just not be able to finish it off. Treatment areas, you see from the ICU, you can see the garden. These are some energy efficiency. I think everybody talks about this, so it's one of the part of our design. So I'll not discuss on it. The modular systems that will make a big difference in our execution. Here, in COVID, we are trying to improvise on the way we do the segregation in terms of sterility, like low, high, and all. And instead of one corridor, we are having 3, where we have doctors separate, patients, relatives separate, and service corridors separate. This is one of the approaches that we are doing in the hospitals. So these are the design summaries that we normally inculcate in our design. Thanks.
Thank you so much, Nithin. Yeah. The last presentation for today on fire-rated aluminum composite panels, and I'll call upon Faizer Ali Dastagir, who's the National Head of Projects with Viva Composite Panels. And we just have confirmation that fire-rated panels are not going to be value engineered, so you have all the business in the world now.
Very good evening to all of you, and it was a day well spent. A lot of information that came through. Good to see everybody in flesh and skin after a couple of years. Feels really good to be on the dais as well. So I'll quickly get into the presentation. I hope I keep up the energy and keep all of you hooked on to my presentation. So we're just going to go through the basics of FR composite panel. Before I start, I'll just introduce Viva. Viva is a company which is into ACP manufacturing. We are the largest ACP manufacturer in India today, with 2 decades of expertise in ACP and a 7 million meter square production per annum. We have 500 customer touchpoints throughout India. We produce Class B, A2, and A2+. What is A2+? I would explain at the later part of my presentation. 7 state-of-art production lines, I would detail on that as well, and 300 plus shades and further can be customized in any of the FR grades you choose. We can offer products that are from 10 years warranty up to 30 years warranty depending on your project requirement. So basically, before we step into understanding FR composite panels, a small history, a recap of composite panels is, it started as a joint invention between Singh and BAS in 1969. By 1980, the industry discovered that ACP could be used as a cladding material, but the real use came in the 1990s. And lucky to be part of the facade industry, I still remember those days. Aryan Flyman used to come from Singapore selling Helico bond in India. So those were the days. And from there, ACP has evolved as just a straight cladding material to today we have 3D panels that are being made by ACP. The project which is highlighted there is 3D panels. So ACP has come a long way from where it began. It's gone through its big journey. It has also had its own share of challenges as well, which as an industry we've addressed and still addressing as well. The biggest challenge that ACP faced was fire, a threat from fire and how it contributed to fire. And the major incident that all of you know, most of you know, that was the Gleffen Tower, which really brought this to highlight that it contributed to the propagation of fire. It caused risk to human life by 2 reasons, mainly smoke and flame droplets. But the incident still continued. The Cube Bolton was also a big incident, the incidents in Sharjah. But then the industry realized that if they didn't work on it, they would end up losing the market share what ACP had. So this is just a fire accident where you can see the facade burning. Now you see there are 2 key issues here. You can see the flame droplets that are falling down and spreading the fire, and the release of toxic gases through smoke, which is causing trouble to people inside the building. So these are the 2 key major issues that ACP had to address. This is just a demonstration to show you how non-FR ACP behaves with fire. So we did this at our lab, and basically we lighted this fire at 1960 degrees, and that's blue flame. So you can see that when non-FR ACP burns, it does emit toxic gases through smoke and flame droplets as well. So this is where the issue lies. we've spoken about issues, now let's speak some solutions. So the solution lies basically in making ACP a fire retardant material. Now how do we do that? We basically do that by changing the content of the core. The core needs to be a material that would retard fire. So that is magnesium hydroxide and aluminum trihydroxide. Simple chemistry, when hydroxide reacts with fire, it releases water molecules that basically retard fire or the spread of fire. So now this is mixed in different proportions depending on the grade of ACP you require in your project. So first we talk about the basic FR grade ACP, that's the class B ACP as per the EN 13501-1 standard, which is 70% mineral core and 30% virgin core. So now what we're doing here is we're adding the mineral core to retard fire at 70%. But this is, as per EN 13501, this is S1D0, but still there is some amount of smoke that is being released. There is some combustion that is happening, so still we are not safe. So we evolve further and we go to class A2, where we have a 90% mineral core and a 10% virgin core, and now we have something that is non-combustible, that is not burning, it's not emitting smoke or giving you toxic gases. So the inmates in the building are safe, the building outside is also safe. So this is where ACP at the moment stands at, that we have a class A2 product. This is just a demo which I'm just showing you on video, where we've done class B and A2. The same flame, you can see that there is some amount of combustion happening on the class B, but there is no flame droplets that are coming down. Smoke is absolutely very less compared to the non-FR ACP. So there's a closer shot of what's happening. Now when you look at the A2 at the same flame and temperature, you see there is no combustion happening at all. Absolutely no combustion, no droplets. Smoke level is not there, so you're devoid of smoke, so no toxic gases are being emitted. Very good that we've come up to this A2 where we've made the building safe. Now, I'd just like to highlight a very important point here, that yes, as a manufacturer, Viva or any other manufacturer claims that we are FR retardant ACP manufacturers, but how do we validate that? How does a project stakeholder validate that? So there is something called testing, which is not a complete foolproof solution to it, because you can send any better good sample to the lab and get it tested and then the test is passed. But what we need to focus as project stakeholders is basically the certification. We need to look at certification, because certification ensures that there is a factory production control. The testing body is monitoring the plant every 6 months, ensuring that the plant is manufacturing products as per the standard that has been certified for, be it EN 13501 or be it NFPA 285. So what is EN 13501-1? This is basically a classification based on reaction to fire tests. So when we give fire to the product, EN tries to classify the product depending on the smoke release and the droplet release. So this is a classification test where you classify the product as a class B product or a class A2 product, or in case of solid aluminum or stone, you go to A1, A0. So this is basically a classification product where you have classified your product in the respective class of class B or A2. Now if you see on the left hand side, we have a certificate that is from Thomas Belwright for EN 13501. So this is a certificate which is inclusive of a test report followed by a factory production control audit that happens every 6 months till the validity of the certificate. So you can see the validity till 2023 it is valid. Until that time, there is every 6 months there's an audit from Thomas Belwright. NFPA is an American Standard National Fire Protection Association, which is basically a fire test at a large-scale wall assembly to see the potential flame spread. In layman language, fire propagation. How is fire getting propagated? Whether the fire is spreading or is it being contained? That is what we're trying to understand in an NFPA 285. So an NFPA 285 basically has these 8 clauses that the test needs to be passed on. The first clause being a flame emitted should not go at more than the height of 10 feet. The second being on height. On width, it should not go more than 5 feet. Flame should not go the intersection of the test specimen. It should not go to the second story. Then you have temperature sensors where you should not cross 1000 degrees Fahrenheit. You should not go into the cavity of air space at 1000 degrees Fahrenheit and at certain points at 500 degrees Fahrenheit. So this is a screenshot from the Viva NFPA report for Class B from Thomas Bellwright, where you see the conditions have been passed. And this is a photograph of the actual test that was done in Dubai at Thomas Bellwright. Then we have another test, which is an ASTM E119. This test is basically to check the duration of fire in terms of fire resistance. Now, how long does the product hold in terms of fire resistance? How does it contain fire? How does the structural integrity stay? So this is basically the certification from EXOVA, which we have here. Now coming to the most important point which I wanted to cover is that, okay, we've come up to A2, now how do we evolve ACP further? Evolving ACP further is making it better than A2. Can that be done? It can be done, and it is being attempted to be done. We've not reached there, we're on the journey. So what we've tried to do is we've tried to replace the mineral core by another core which is more non-combustible. Same time, you hold on to the structural strength and the integrity of the product, not compromising on that. So we came up with this product called aluminum corrugated core panel, which is basically a ACCP which has a aluminum core, a corrugated core. The concept remains the same. You have a top skin, you have an adhesive film that holds on to the core and the skin on both the sides. It's an 100 mm micron adhesive film that binds your core and the skin. Now what we do here is we have 2 layers of this film. One, before we corrugate the sheet, we have the film stuck to before the flat sheet, then we corrugate it so it takes the shape of the sheet. And then we have another film when it comes on the top, before the top skin is attached to bonded to the core. So we have double layer of adhesive film to give the bonding. So you can see this, you can see this basically in the fire test what we did for the other samples, and we're doing it here as well. So you can see there is absolutely no combustion, no smoke. It is performing better than an A2, but in terms of classification, it is still an EN 13501-A2 product. We have an A2 certification for that. We've still not got an A1. But in logical sense, it really does perform better than an A2. I would just like you to go through this clip where we've just highlighted the advantages of ACCP in terms of comparing it with an A1 product like solid aluminum. Now, if you have solid aluminum in a project, and if you want an alternative material, you can surely look at ACCP, and the advantages have been listed out here, which I would again repeat. So basically the advantage what ACCP has over solid aluminum is that it's a single point warranty product. So it's not that you're buying a coil from somebody and you're coating it with somebody. You're buying it from one manufacturer who's giving you the entire product with the coating, with the warranty for the integrity of the product. Second, you can get a larger range of shades and textures because that we have the same coil coating, so we can repeat the process. Third, it is easy to install because it can be routed and made into a tray like ACP. Fourth, Workmanship is much more easy vis-a-vis solid aluminum, where we face challenges of finishes. I'm sure you must all agree on that. So there are a lot of advantages. It is a light-weighted material. It has thermal properties as well, acoustic properties as well. So this is the advantage what we have vis-a-vis a solid aluminum, which is an A1 product. I always believe that any manufacturing unit, the heart of the company is the plant. The plant is where everything gets done. This is our plant in Umbergaon, which is built on a land size of 13 acres. We have a paint mixing unit, which is one of our unique features where we develop all our shades and textures. So any shade and texture that you see on our catalogs is made here. Now this gives us a big advantage in terms of customization. We can customize shades. So if you want any RAL color, any Pantone color, we can do that. Very interestingly, for a project in Doha where we are working on a zoo, it's a panda zoo. It's not a vertical cladding, it's a roof cladding where they want a bamboo kind of finish developed because it relates to the panda. The panda eats bamboo. So they wanted a 3D bamboo feature, so we developed that, and they are going to be using almost like 50,000 square meter of that. And it's a very futuristic structure, which I would share photographs with you. It's like one of those structures that come in the Jurassic Park movie. So it's something built on like that. So there are a lot of options we can explore. There's humongous options that we can explore in terms of customization. After the paint is developed, we need to coat the coil. So we have one coating line. This was installed in the year 2018. This is a single coat, single bake line where so if you have to do 2 colors, we have to repeat the process 2 times. The width allowed is 4 feet on this. This is our latest inclusion, which we believe is a game changer, which is a 1670 width line. It's a 3-coat, 2-bake line. First of its kind in India. Incidentally, Viva is the only company which has 2 coating lines in India. The good news is we are planning the 3rd coating line as well. So most of God's grace should be out by another 6-8 months. So that would be a coating line that would be able to do 2000 mm, which will be supported by laminations line that can be do 2000 mm as well. So that's the work on it has already begun. These are our 4 production lines that basically laminate the FR Class B. Now this is a very interesting line where we do 3 products now. Initially we did 2. We are doing A2 plus, that is ACCP, and we are also doing honeycomb panels, 12 mm and 25 mm. Now, apart from all the FR grades we provide you with a large range of textures and shades, apart from the customization which we also do. So there is a lot to choose from, and what we believe is in any shade in any FR grade. So that is a tagline that we have, that any shade in any FR grade is what we can provide. And if you have time, please, I would request you to come to our display there outside. And thank you so much. I really appreciate the audience, and it was a great day well spent, and looking forward to see you all very soon. Thank you. Thank you.
Thank you. Thank you, Faizer, for that presentation, and thank you to all of you, the last people standing. Where is Ahad? So day well spent indeed. Finally, good to be back in these normal times. And quick round of applause to the entire team to my right for the wonderful job with all the AVs and all the presentation and everything. They've come a long way. I love that pointer with the magnification. That was something really classy. And thanks to all of you as an audience, and a big thanks to this man on my right. No, I didn't do much. No, continue. He can be modest, but I can tell you there's a lot of hard work that has gone into making sure that all of us have been able to come here today. So a big round of applause to Ahad and his entire team. Shraddha, they've done a fantastic job in organizing everything. And
a big round of applause for Tariq himself.
Thank you.
He's been a patient host.
Thank
you so much. I hope all of you enjoyed today's event. It's a restart again, so we didn't know what to expect. very overwhelmed by all of you being present here in person, despite what's happening around us. I hope things become better from now and we only go from strength to strength and achieve normalcy by the time we return to Mumbai next October 2022. So thank you all for being here. We have live streamed today's event, so all presentations are available on our YouTube page and even the event website, facades.ind.in, so you can visit there and you can see any presentations you've missed. That's it from us, signing off. Looking forward to hosting all of you next year.
Next year.
Okay, take care guys,
See
bye-bye,
you.
see
And
you.
be safe.